Hello, everybody, and welcome to Mine Day at Liftoff Week. It gives me a great pleasure to welcome all of you today to this incredible series of events and celebrations to celebrate Filecoin Mainnet's launch. There's a ton of great sessions today. We're going to have workshops and deep dives. We're going to have panels. We're going to have a Q&A. So stick around. It's going to be a fantastic day. You can find out all the information about upcoming sessions on liftoff.filecoin.io, including links to our breakout lounge where you can meet your fellow attendees, and also to our Slack channel. Most importantly, you can still submit your own session and share your wisdom with the community. By attending Liftoff Week, you agree to abide by our community code of conduct. So please be awesome to everybody. Okay. Our sessions are also being translated in real time. So if you would like to listen to this session in Mandarin, then please select the translation button at the bottom of your Zoom screen. In our first session today, we'll hear about the developments of Filecoin proofs and some of the very exciting improvements planned. Please welcome Dig from Protocol Labs and Kelly and Sean from Supranational. Over to you guys. Dig, Kelly, are you out there?
We should be coming up in just one moment.
No worries, we'll just give them a second. Please, you'll see people popping into the chat and letting us know where they're tuning in from. I am coming to you from sunny, not very sunny, rainy Glasgow. So yeah, please pop in the chat and let us know where you're tuning in from today. Dig, whenever you're ready, let me know and I can let you go off to the races. Can also ask questions from the chat. Does anyone know if the events can be imported from the Google Calendar? Yes, they can. Someone will pop a link in the chat for you.
Can you hear me now?
Yes. Hi. How's it going, Dig?
That is awesome. I couldn't unmute myself. I'm sorry.
It happens. It happens.
Couldn't answer you.
Okay. Well, a very warm welcome and excited to hear what you've got to tell us about proofs.
Thank you. Can everybody see my slides? Hopefully. Sweet. All right, now that this is over. Hello, everyone. I'm really excited to be here. Finally have some time to actually talk about the things that we've done in the past months. Yeah, as mentioned, my name is Dig, or Retrieval, whatever you like, and I work for Protocol Labs. Here with me are Sean and Kelly from Supranational, who have been collaborating with us for quite a while now, but especially this past month, to push the crypto and Filecoin to the next level and to make Filecoin a really fast network. So without further ado, Sean, if you want to say some words about you, Kelly.
Sure, thanks, Retrieval. My name is Sean Gully. I'm a co-founder here at Supranational, where we focus on hardware and software acceleration of computationally intensive algorithms. And of late, our primary focus has been around cryptography operations in the blockchain ecosystem. And prior to that, I was at Intel for about 20 years as a principal engineer, where I co-invented some of these CPU features that we'll talk about today.
Excellent. Thanks, Sean. Yeah, my name's Kelly Olson. I'm on the product team here at Supranational. And as Sean mentioned, we're focusing on accelerating verifiable and confidential computing. So back to you, Dig.
Thank you. Yeah, as I mentioned, I've been with Protocol Labs for a while now, over 4 years, and I've been focusing on the proofs implementation, and so got to work with Sean and Kelly on this. So we're going to look at 3 things today that we've worked on, as the title hints at: sealing, signatures, and snarks. And so let's get it started. So the first the biggest thing that probably everybody who has run a miner so far knows that there is a process called sealing, which is the first step in proof of replication. And you've likely also heard it maybe under the code name called pre-commit 1. And it is the slow, but very crucially slow part when you onboard new sectors. Sealing is designed to be very computationally intensive. That is what it makes it secure. But we end up, of course, not wanting that everyone has to pay a high cost, but only as much cost as we really absolutely need to achieve our security, which is why it's crucial that the implementations that are out there are as fast as we can make them. Now, the other part where it's really good if these implementations are faster is that the difference then between the host, between the honest and the malicious miners becomes less, because if all the honest miners already know the really good code and have it running, then there's simply less room for malicious miners to improve on, and as such making the network more secure. We also really want everybody to be able to mine as easily as possible. So we really want this process to be as take as little resources as possible. But it, of course, unfortunately, still takes a lot of resources. But we've done a lot of work to reduce that, and Sean is going to tell you a little bit about what we've achieved there.
Thanks, Zach. Yeah, so here you guys can see on the left-hand side a picture of what's called a stack depth robust graph. And this is from a paper by the great Ben Frisch at Stanford from a couple of years ago. That was the foundation for what's in Filecoin today. And you'll see these nodes, and each node is represented by a 32-byte SHA-256 digest. And you'll see the red lines are the edges that represent base parents. So, and this is all intra-layer. And then you'll see these blue edges below. Those blue edges, they are interlayer, and they represent what's called expander parents. And the idea here is that it's a very serial process, as Dig said, where you've got a node that you compute, then you've got the next node, and it relies on the previous node or the previous layer's nodes. And so what you'll do is you'll concatenate the value of those nodes that the edges connect to into a buffer, and then you'll hash it. So the key point here being that the theoretical limit to this graph, when all of the edges are kind of randomized and pointing to previous nodes, then you'll have whatever your hashing compute can handle. That should be what your theoretical limit is. So when we looked at what can we do with sealing as it is, we looked in two places. One was, all right, what's that theoretical limit for the hashing? And then two, where are some of these bottlenecks? And it turns out the bottlenecks mostly are in the memory reads. So what we did in terms of the process is, most of the miners now, when you generate the graph, you'll only do it once, and then you'll cache it on your machine. So whether you're doing a 32 gig or 64 gig sectors, you'll cache that graph for later use. So if you're sealing a whole bunch of sectors, you don't have to repeat that process. So what we do is we pull that cached graph into memory, we pin it in there, you got to lock it in there so it doesn't get swapped out. So that graph is always fresh in memory. Then when we look at the buffers, we kind of map this current layer, and then we have another buffer for the previous layer. And so those are our three kind of working memory spaces to deal with. And so we put some constructs in to make those efficient. And then the next piece that we looked at was a sort of a threading. So we create one thread that's doing all of the hashing, and then we create, in this case, we use two threads for prefetching all of this previous node data. So in this producer consumer model, we create two threads that go off and run and do the prefetching based off of what's in that parent node cache. And then we have the other node that's pulling them off of a ring buffer that's shared between them and actually hashing them. So this whole process, we have another process in there that tracks, hey, what if I was prefetching a node and it was too close, so the base pair was too close, we track that, and then the hashing thread can pull that in. So we found that to be like, all right, two threads with some tuning of some parameters was sufficient enough to read ahead back, pulling out of memory or even off of disk into the localized cache. Another thing we do in this case is we also pin the process to a certain, say, complex. So in this case, we're using the SHA extensions that are in mostly the Ryzen's or AMD cores. So AMD is set up in a complex where you'll have 4 cores in a complex with a shared cache. And what we do is we pin the process to sit in that context. So you'll have maybe your hashing thread, and then you've got your prefetching thread, another prefetching thread, and they're all running tightly in this complex that all have a shared cache. So everything's really hot. And so really it all comes down to how fast can I hash, assuming all of the data is available. So we can just turn the page a little bit, and then we can see just some of the results that we got here. So we started off just using, if you guys could use like Lotus Bench and things like that to see where it was before. And a lot of people were reporting in this 4-hour-ish range. And by just doing a couple of these tricks, well, we brought it down to around 2 hours. And if you presume that the graph is entirely serial and there is no way to hash another node before you completely hash the previous node, then we are close to that sort of theoretical limit. In general, AMD can hash at 2 cycles per byte. So we could take how many bytes are we hashing in the buffer. We could figure out how many cycles it takes based off of frequency, say, about 4 something gigahertz, perhaps. That 2-hour range is pretty close to about as fast as you should be able to seal a graph that's entirely serial. So
one thing I may add here that just may be relevant to the miners in the audience is, the AMD processors today do have this special instruction set that makes hashing faster. They have sort of a custom accelerator within the CPU. That accelerator is going to be expanding out into other both Intel and also ARM processors. But just one thing to sort of keep in mind is if you're looking to do this sealing as quickly as possible, at least today you're going to get probably the faster times using the AMD processors because of this specific accelerator for the hashing.
Yep.
Also, a note, we do have experimental ARM support, and I believe technically we actually do call the current ARM instructions in most of the code. So I believe some people already reported that they are also doing this hashing on ARM with the sped up instructions if you have an actual ARM64 processor supporting those. If folks out there are running this and are seeing times, it would be really interesting because we haven't done any larger tests on ARM processors. So any info that you can send our way would be appreciated. All right. So pretty good, right? 2x, that's pretty good. Let's see if we can do better. So signatures. Most blockchains, well, I'm saying most, I assume all blockchains use signatures for signing their messages or transactions, depending on the lingo. Filecoin additionally uses signatures to also in its consensus process. For sending messages, we have 2 options currently available, and one of them is BLS signatures. The other is the classic cyclic K. BLS signatures have the big bonus for us that they allow aggregation. And so if you look at the block production in Filecoin, all messages that have been signed with a BLS signature, they get aggregated by the block producer to a single signature. And so if you verify the signatures for a block, you only need to verify the single aggregated signature. But that means you have to verify an aggregated signature. And so this is one of the verification methods that gets called quite heavily. The other part is we use it in the VRF to generate the election ticket. It gets signed. There's a signature based on the private key of the miner that is mining the block. And so any block validation also has to verify that signature when doing the block verification. And so you can see that every block that you need to sync and produce heavily uses these signatures. And so let's take a look how fast we have made and been able to improve on these signatures.
Great, yeah, thanks, Steve. So when we look at signatures, just in general from the BLS perspective, there were a handful of libraries that existed. Some were somewhat experimental, some were kind of driven by researchers when they were getting this off the ground. And there's a couple that were pretty good performance to begin with. But when we took a bigger look at where the problems were, we thought, hey, I think we could do a little bit better. And since this is new, this is emerging just for us, we thought, hey, this is great. Like Filecoin's using this. This has been being pushed by other blockchains as well. So, hey, we should really do a pretty nice library for this. So this is great because this is the Filecoin is the first production blockchain that we've put this library into, and we created what's called Blast. And this Blast library is kind of comprised of a few different areas. One, we looked at some algorithmic approaches, and these are some of the more classical approaches to field and curve operations, like just using Montgomery multiplication, things like that. How do you represent points? Some of the endomorphisms and batch efficiencies are additional techniques that you could be used when you're dealing with a lot of different points. And in this particular case, for Filecoin, as Dave mentioned, these aggregated signatures and aggregate verification of a signature is kind of where we were starting to deal with. There's a whole bunch of points here that we're going to have to deal with, because at the end of the day, a signature just boils down to a point on the curve. So we were focusing on algorithms of that space. We also focused a lot on the assembly. So given our background, we're most of our experience came from assembly coding on CPUs, whether that's x86 or ARM. And one of the first things we saw when we looked at a Rust, which was what the pure sort of native Rust, which Filecoin was using before, we were able to get a 3x performance improvement just by hand tuning the code. So it wasn't compiled, but it was more assembly based, that was using instructions like mulxadd, cxadd-ox for parallel carry chain and things like that in the very intensive modular arithmetic. And then the last piece, which actually drove a huge performance improvement. So as you're saying, like, hey, I'm a miner, I'm generating a block, I have a whole bunch of different signatures that I need to aggregate. When you look at the actual operation underneath that can be parallelized heavily. So I could take a huge chunk of signatures, I could break them up into buckets, I could feed them to a variety of threads. And as we talked about earlier, if you're talking about using an AMD processor, as we know, those processors now come heavily loaded with a lot of cores. And so we started to take heavy advantage of parallelization, and it was on a very fine grain using lightweight threads. So we saw that even in Rust. We played around with like the built-in libraries with Rust and decided to create a different thread pool associated with our code, so that we could maximize the performance, especially over the long run. So you could see on the next slide where we ended up getting as a result. So the x-axis is the batch size. So consider this, a single value would be a single signature, and then so on the left is aggregating signatures. So if you're a miner producing a block, now you've aggregated, say, all the way on the right hand side would be, say, 1,000 signatures, and then on the right hand graph, this is signature verification. So I've got an aggregate signature, and as part of that aggregate signature, you need a whole list of public keys and a whole list of messages associated with it. So it also could be heavily parallelized. And so what we see is we're tapping out in this 5 to 8x performance improvement range. So we were seeing that potentially 3x off the bat with some of the assembly optimizations that were made and some of the algorithmic optimizations. And then by adding the threading, we started to get that much bigger boost. So the whole key point here is that we're trying to alleviate bottlenecks in the system, so it allows you to decrease block times. It gives you a little bit more room transfer things over the network, which could be a little bit haphazard. It can allow for more things in a specific block. So all told, it really, by expanding it to these bigger numbers, now we can really scale Filecoin much greater. So I think we're pretty happy with the result. I think
Nice.
Snarks. Yeah.
All right, well, that's pretty good. 5 to 8x. All right. Anybody think we can do better? Anybody want to do better than that? All right, let's take a look at our third problem, snarks, or short for ZK snarks. So ZK snarks have been around for a while. Well, you know, in crypto terms, they haven't been around for a while, but in blockchain terms, I think they have been around for a while now. And they are starting to get more and more adoption by different systems in order to improve what can be done in terms of computations off-chain, but verified on-chain. Filecoin very early on decided to use this to allow the proofs of storage that we need to do to be verified by all participants on-chain. And so we currently use this for the PORAP in order to make the commitment to the storage and to prove the correctness of the aforementioned seal. We generate currently 10 snarks. Well, every miner generates 10 snarks when they onboard a sector of 32 gigabytes. And then for post, both winning and window post generate a snark that gets posted on chain for every such post. So you can see that we generate quite a lot of snarks, but especially there's a lot of need to verify these snarks, as everybody needs to verify the blocks that contain these snarks to get posted on chain. So we've looked heavily into snark verification as such, and so Sean will tell you a little bit about what we achieved there.
Thanks, Eddie. So, you know, as Dave just mentioned, the snark verification can be a pretty big bottleneck. And I guess, you know, today already we're seeing thousands of snarks being generated by Filecoin a day. So anything we can do to speed this up, once again, helps impact scalability and helps improve validator performance. So when we look at it, there's as you mentioned, there were 3 different types of proofs that would need to be verified, so that winning, the seal, and the window post. And realistically, where the bottleneck becomes is in this multi-scalar multiplication operation, and each one of the proofs has a different number of points that need to be multiplied and added together. And you can see winning and seal are relatively small, but window is much larger, and window is the thing that you're constantly being challenged on. So this is it's a pretty common snark to be getting, and it's not just a one-time thing. This will be happening over and over and over again through the life of the storage. So it was a big area of focus for us. And so we looked at, again, that 3 sort of areas. We're looking at the algorithm, we're looking at assembly code, and we're looking at multi-threading. So from an algorithmic perspective, the interesting thing about the snarks was we had some interesting opportunities here for pre-computation. So there's a verification key that was generated along with the SRS, the structured reference string, as part of the parameter generation, the trusted setup. So these values are fixed for all time, and we could pre-compute some things. So there's some Greeks. You can see that the formula is is there. It's a little convoluted, but you can see we could do some pre-computation on some of those Greeks, and then we could also pre-compute on some of those points in that middle sigma function right there. And we ended up using this fixed window, this 8-bit fixed window multi-scalar multiplication operation, and that dramatically sped up the performance. And another thing is these pairings. So there's not just the multi-scalar, there's 3 pairing operations. We combined the 3 pairing operations into one, and we also would do those operations in parallel with the exponential use, the multi-scalar multiplication. So that parallelism starts coming in that multi-threading. So we talked about the Groth 16 is the proof system that they use, but we use the pairing and the exponentiation together in parallel. But there's another added feature that we had that helped significantly improve performance, and that was deserialization of these proofs. So as they get sent over the network, they come in, we need to deserialize them. And then as part of the validation responsibility, you're supposed to check, hey, are these valid points in the group, the elliptic curve group? So that's another expensive operation. We were able to parallelize that. So between these sort of 3-4 different buckets here, we were able to shrink it and dig on the next slide. You could see the performance that we were able to get across the three. So, on the big one, on the window, which is happening every day, we've got the 12x performance improvement. So that made something that was, a scalability potential concern, and we shrunk it down a lot. So this is great. So this means, there's an opportunity for more challenges, or there's an opportunity just to validate a lot more storage and challenge a whole lot more storage on the network. And similarly, we got 10x and 8x respectively for winning and seal. So again, this is all lightening the load on validators. So we were also extremely happy with these performance improvements.
Yeah, I think one thing to add is, this work and the use of snarks is really groundbreaking here for Filecoin. So as Sean mentioned, I think, we're seeing at least 8,000 or 9,000 snarks being processed today by the network, which I think is, unprecedented on mainnet systems today, right? So this is a one snark every 10 seconds or something like that. And, even on some of the maybe more established blockchains, we're not seeing this sort of use of advanced cryptography. So it's really groundbreaking work, and I think this optimization work is going to be more important as snarks are more widely deployed by not only Filecoin but also other blockchain networks.
Yeah, one small note to these things and when they will get deployed. As Nicola mentioned earlier in the chat, the sealing improvements are currently in Lotus, and at least most of them, and there's a link to instructions on how you can enable them. They're currently still marked as experimental until we have further wider testing. The snark verification and the snark verification is coming soon. It is currently partial. You can currently also enable it. There's a use fill blast flag that I believe we have some documentation. We'll post something later in Slack and the fill proofs channel for details. And the BLS improvements are actually already deployed by default currently in Lotus. They are only in Lotus deployed, as far as I know. I don't know about Fuhuan and Forest when they sit there, but I know that they are deployed in Lotus currently. Sweet. All right, so the future. So there's certainly a future here. This is not the end. This is the beginning. Now that we have mainnet anyway, and in performance optimization, certainly there's still a lot to be done. This is also a call to the community. We really want your help and any ideas, how crazy they might be. Some of the ideas that we had were certainly crazy, but they did work out, so that's nice. Send them over, make PRs, let us know what ideas you have to make these things faster. It just benefits the whole community if the default implementations get better and better, and people can learn from this code. All the code that we've discussed so far is already open. It's just not necessarily integrated already in the chains. Some of the topics we hope to be looking into, or I already started looking into for the next, are snark proving. As I mentioned earlier, snark proving is still pretty heavy for all miners. So making that better and faster is definitely going to help the network. Syncing is still not as fast as we would like it to be. So improving that in all areas is going to be a focus. And then VDFs are the next level. We're still looking into VDFs, and especially Supranational has been working on on them for quite a while, and hopefully at one point we will have a VDF that can integrate into Filecoin. So definitely stay tuned there. Yeah, thank you, everyone. Kelly, Sean, if you want to say some last words.
I think that's great. Certainly feel free to reach out to any of us here on the panel today if you have any questions. Always looking to add value or expertise if there are questions that you have for your projects or your deployments.
Yeah, and I just want to thank the Protocol Labs and Filecoin guys and the whole team. I mean, it's been great. I mean, you guys have been super receptive to just improving. And so you guys every single day are doing your best to improve the protocol, improve the network, improve the code base. Solid. So, I mean, it's a super solid project with a great team. So we're ecstatic to be a part of it.
Yeah, I want to extend that thank to Supranational. They have been amazing partners, and they have been teaching us, at least me, and I know some of my teammates, day in and day out, and how computers work and how to make them do what you want a little bit faster. So thanks so much.
That's amazing. Thank you so much, Doug, Kelly, and Sean. It really is groundbreaking work, and it's so exciting to hear what the future holds for Presto. Thank you all for your hard work. I think that's a great call out to the community to get involved. It takes everybody. So yeah, thank you so much again for taking the time to share with all of us. Okay, up next, we've got Benjamin. He'll be teaching us how to get started on Filecoin as a solo miner. In the break, you can head to the lounge and catch up with Dig, Sean, and Kelly and other members of the community, maybe ask some more questions, and we'll see you back here at the top of the hour. Thanks so much. All right, welcome back everybody, and hello to everyone who is just tuning in for the first time today on Mine Day of Filecoin Liftoff Week, a week-long celebration of Filecoin mainnet launch. Our next presenter is Ben Hyashvo. Ben recently participated in Space Race, Filecoin's incentivized testnet competition, as a solo miner. And he's here today to share some tips and tricks on how to start mining Filecoin as a solo miner. A very warm welcome to you, Ben.
Thank you. So I hope that you can see and hear me. Yes, perfect.
Perfect.
All right. So so let me just go and share my screen here. And let's get it up there. All right, everyone can see my screen? I hope so. Yeah, so my name is Benjamin, and I've been participating now in since we did the calibration network. Did a lot of experimenting with the mining setups, and now I also kind of presented it already during the space race. So we figured out that, you know, why not spend some more time on actually going into this kind of solo mining setups. One of the things that I also said last time was that I'm using an unmodified Lotus version, meaning that I generally don't go in and modify, optimize, or do any hacks to Lotus. So I kind of have to work with the software how it is. So how I do that is more like trying to make the hardware fit and trying to make that work as good as possible. So last time I you saw some pictures of some of the equipment during Space Race 1, which was basically just taking a lot of hardware and trying to stack it up and see how much storage we could get on there. I'm going to show you some more pictures of what it looks like today, because obviously it's not like this. But the general idea for what we're going to talk about today is the sizing. So now you see the rig here with some different computers, and the general problem when coming to being a solo miner is that when you have quite small mining setups, you really need to have a focus on how do you balance the mining setup. So that's really important. Now, I also did some experiences doing Space Race 1 and doing some more experiments doing Space Race 2. But basically, it comes down to now that I kind of try to lay out what are the different ways of doing this with quite small setups. So so this is so far what I've been working on. Basically, what you see here is a list of different setups, coming from having a single rig and into having a kind of, you can't really call these big mining setups because these are not data center size. So you know, no matter what, they're not really that big. But anyway, this is kind of trying to say what could it look like when you are dealing with smaller size computer clusters. I grayed out some of them, and that's basically because I have not tried them by myself. So the community here on Slack is very strong. You can get a lot of help on how to set this up in all different kind of ways. I've only personally experienced with some of these, and it's not everything that, you know, is really feasible to actually do, although that it might work. So what I try to do is basically just put it up here, saying that, you know, for a single rig, you will only have a single computer, which is a miner. Then you can add on workers to that. And what roles would you have those workers to do? So so basically, you start from just having a single computer, and then to having, in the biggest setup here, I had 9 when this happened. So from that, I also tried to do something down here in the bottom where we have some performance measures. So one measure that I use is, in general, how many. So I guess most of us are running 32 gigabyte blocks at the moment. So that's what I measure everything in. but basically you have an idea about, how many blocks would you be able to do every day. So that's one thing. The other thing that I use very much is what I called my balancing metric. And that's basically how I calculate everything. And I would really like, if we could get out of this session today, and you also had this idea about this kind of metric, which is basically how long time does it take between I can pledge a new sector. So for these systems you see down here in the bottom, we have a lot of them saying around 2 hours. So how I would interpret that is like, so every second hour I would be able to pledge a new sector, or pack a sector with deals in. It doesn't really matter. It's much more of saying, how much capacity is there in here. So the reason why this is important about how many hours between or how many minutes between I can pledge a new sector is because you can actually use that metric for each of the workers. So for each of the jobs that they have to do. So basically, if I need a rig like this that can do a new sector every 2 hours, then I would need a PC1 worker, which can produce a new sector every second hour. But it would be the same for my PC2 and for my C1, C2 worker. So basically, I can apply this to all of them. And coming up here in the end, which is the biggest setup that I did, which I was using here on Space Race 2, I got it down to about pledging a sector every 24 minutes. And basically, for me to figure out, what is this number? Well, one thing is I can figure out how many PC1 processes can I run in parallel. So how much can I get through there? So that's one thing. But then I also need to make sure that I got enough PC2 workers to actually handle that workload. And then also the C2 workers to actually finalize and get it, out of the way, because otherwise I will get congestion somewhere in here. So just taking back to what this says is that you can have a single miner doing everything on the box. You can have a split where you say that you have one being the miner, and then you can have a worker actually doing all the sealing. That would be the basics of having, a separate sealing worker, and then having your miner just doing the operations of proving the storage and so on. So that's also a way to do it. But I haven't tried any of these solutions, and I generally did not try with anything simple. I just went for the cluster directly. So the minimal setup that I have running right now is that I am only using three servers now. So I have my miner, which runs the daemon and the ant miner process, and it actually has a pretty good GPU. But that was just the intention of making sure that I would be able to win new blocks, and not having a miner that's slow that it would actually not be able to mine. So that's one thing. Then I have a fairly little PC1 worker, which is nothing special. It does have some memory, and it has an epic CPU, but apart from that, nothing really special about it. The reason why I'm holding a little bit back is also because we all know that there are optimizations going on, meaning that, if we get a new version of Lotus where we now have, the new features and the optimized PC1, then we might have double speed on PC1. So now I might end up having a PC1 worker, which is actually producing the double amount of sectors per hour, time between every sector get the half. So then I need to balance the rest of it. And then it might be next month that we also have optimizations going on for PC2 and for C2. And that's why it's really important to understand these metrics, because every time something like that happens, so something gets double speed, meaning that you can pledge now the double, well, then the rest of it needs to rebalance to actually make it work. So I'm not sure that we're going to see that the improvements is going to be for PC1, PC2, and C2 at the exact same time. So that's to take into consideration. But this is actually the setup that I'm running now with the 3 servers. Then we have another setup where you could actually you could split it in another way. So right now I have a separate PC1 and then I have another worker which just do the PC2 and C2, which basically in this setup just needs to spend about, if it can do that within 2 hours, then it's all good. So both processes within 2 hours, because my PC1 worker would only spit out a new sector every second hour. So, that would work. But another way to do it is actually to say that, you might have your PC1 and PC2 on the same machine, and you can actually do that with the newer Lotus. But the problem could also be that if you do this, then your PC1 gets really slow because PC2 is taking up some of the CPU resources. But in general, this could be a good idea because you would use the PC2, which does not use much memory, and you would use the GPU for the PC2, and then generally leaving PC1 on its own. So you could kind of share the same server for these two things. But currently, I don't think we're. It might work, it might not. But at least it is a way to do it, but not the way that I have done so far. And then for this setup here, you would have a separate CPU worker. Then the other clusters that I've been working on so far has been the smaller setup here, where you have a dedicated worker for each role. That's how I started. And that turned out to be a really good way of doing it in the early Lotus, because a lot of problems were, we were facing a lot of problems when we started Space Race. Basically, the scheduler having some bugs, which means that it, for some, it did not really work at all. I did not see much of that. And I believe that one of the reasons why I was not so harmed by these kind of bugs and things that need to be tweaked in Lotus was because keeping each of the jobs on a separate node meaning that I got really good control over how the scheduler would assign jobs, because basically one job could only go to one worker, and when it was done, it would be ready for the next one, and not having multiple jobs running and having to fight about the resources. So I'm sure this has improved a lot in the later Lotuses. It's just, for the early days, this worked really good having just dedicated roles, and also having this flexibility that you could basically scale up and down for each of the resources. And I guess this makes more sense the larger you go. And if you go into data center size, then obviously you would have much more flexibility in how much resources you put at each of these workers. But for my minimal setup, this was actually what I was going with, and I was almost hitting about 1 gigabyte of pledge storage every day. So I got a bit over 10 terabytes in the Space Race run, but I actually did a couple of different miners just to try things out. But I'll just come back to that. So then we had the bits bigger setup here, and basically what I did was take I actually had a big server which I split in half, and having 2 different workers running, one on each CPU. So it had 1 terabyte of memory, and it has 2 CPUs. And basically I just split it in half. But that was a pretty powerful setup for actually running also on Space Race. And then to match that, actually the PC2 is not that problematic if you have this this kind of setup here, because it is quite fast. It can actually, I think it can do a new sector every 25 minutes. So that would actually be all that you need. But then on the C2 side, that gets a little bit heavy again, because these one takes about an hour each. And then for the rest of the PC2, I did like a big rig, and actually it's a little bit oversized on some of the things, but it turned out to be a good idea, because some of the congestion that happens when you have to shut off the miner and start it up again and so on, that actually takes some time. So just to get back to that, I also showed this the last time, how to actually try to visualize what is actually going on now that we are mining in a smaller setup. So what I tried to do here is show what does it look like if you have a miner that can, where you have a PC1 worker that can do 6 sectors in parallel. So that would be one of those workers that I just showed with the 512 gigabyte memory. So, it's not small, it's quite big, But then again, you know, this is just a setup to show what is the dynamics of this kind of setup. And basically, the PC1 is running six sectors in parallel, but they are all pledged with that you know, that hour between them. So I wouldn't sit over, you know, just start up six pledge sectors at once, because what happens is that in the start you underestimate how much NVMe storage you actually need, and then in the end it might be too much. Another thing is with the memory, it might also be, if you do that, that it actually doesn't figure out that you actually know. So what I do instead is I actually have a pretty slow startup, but I only you know, pledge one sector at a time. Right. So what happens is that when you do it like this, then you have in this setup a new sector every hour coming out of PC1. That's basically what happens. A sector comes in and a sector comes out every hour, meaning that I would have 1 hour to complete my PC2. Otherwise, I would get congestion. I would then have it sitting in wait seat, and wait seat is fine. I don't really care about that much about my time for packing and my time for wait seat, because what happens is that the data is sitting on my NVMe drives, which is fine as long as I have the capacity, but I'm not spending any compute resources, so I don't have to take them into account for, you know, sizing the compute power I need. But in this setup, basically, I have an hour to do every sector. So I have an hour to do the PC2. I don't care about wait seat, but then I have an hour again to do the C2. And as long as I can do that within an hour, I won't have congestion in this setup. And basically, I had this running just like this setup right here, the double setup of this, and it runs very, very nicely. As long as we're not updating Lotus or doing any of these stuff, the brand outtake and all these kind of things that will screw up everything. As long as we're just in a normal steady state, this is very, very stable. And actually what happens is it's so stable that if I just, you know, set it to automatically just pledge the sector and I come back the day after, it is still going. So the variance between how long time it does take to process and seal each sector in each stage here is pretty predictable. And I haven't seen that much variance. So that's pretty cool, because it means that if you get into this kind of scale, then it can actually run pretty good without that much maintenance, unless something breaks, of course. Right. So what I wanted to go into is basically just go through some of the kind of, I could call them like archetypes of workers. Because the thing is that you can't just say that one worker would be the perfect setup, because it really depends on how, you know, how deep your pockets are, how much you want to invest, and also some people have hardware lying around, meaning that might size some of it, and then you need to make the rest fit, and then you know, in general, this can just look different depending on how you want it to look. But I've seen these kind of different setups here. I haven't tried the high one, so that's why it's grayed out again. But that would be like a pretty strong single CPU PC1 worker. And again, this is thought out of the idea of having them individual, so not combined, which you of course could do, but then you need to kind of you know, also combine these numbers here. But the thing is that this is thought out of a setup where you are using a fast network. So you have a 10 gig network between the nodes. So you would have dedicated workers for doing PC1. And what is stated here is that you can have this small worker, which basically what I have right now running, just here starting mainnet. And basically what you want is you want some kind of CPU, which is definitely an AMD for this one. So far, we will have Intel joining the party, but it will be with the Ice Lake, I think it's called. And so far, it's only mobile processors. And I think we will have to wait a bit for the Ice Lake SP, which is a Xeon version. But sometime we will be here with the Gen 4 PC Express as well. But it is pretty slow. But that specific version of Intel Xeon CPUs will also have the SAR instructions, which is specifically needed for this process as it is today. Because another point that I want to make is that although that I might come up with these archetypes now, it is really important that you try to keep it flexible and not, make each worker so individual and so customized that it will never, be able to reconfigure, because we don't know in a couple of months if we will be using GPUs for all processors. Could be. So basically, it would be pretty stupid to make something where you need to go and buy new hardware when things change. So that's one thing to take into consideration. We'll just get back to that. But this was just to say that you can have different sizes. Another point that I want to make about this is I have been doing most of Space Race and also starting mainnet here on consumer NVMe drives. And I just had this funny calculation where I actually figured out how much data is flowing, because I can see that in my network traffic, but I can also just use those normal metrics for how big are the unsealed blocks that need to move between PC1 and PC2. And I figured out that my poor normal consumer NVMe drives were doing just like 2.5 drive writes per day, 2.5. So they are technically engineered to be able to handle about half a drive write. So basically what it means is if you have a 2 terabyte NVMe, it is designed to write about 1 terabyte a day. And I was using it a bit more like 5 terabytes a day. So you could argue that I might be burning these disks down, and that's why we make these jokes about that it smells like burned NVMe and so on. So far I haven't broken anything, but I'm pretty sure that they are in pretty bad shape compared to when I started. And the point I want to make is basically if you want to make a miner that needs to be ongoing sealing for years, I think these consumer NVMe's, they will burn in the end. So what you need is basically, you have to pay, because enterprise NVMe's are way more expensive, but also they do provide this kind of setup that you need, where they can actually handle this workload without dying on you in the next couple of months or half year at least. Yeah. So that was just for the PC1. We kind of have the same on the PC2. What is different here is that if you have a dedicated PC2 worker, you actually don't need that much memory, because in itself, it's not really a memory consuming process. You can also do with more or less cores, where on PC1, you need to go with a higher clock frequency. I don't think it's that needed here in PC2, because PC2 is in general pretty hard on the GPU. And you will see that by if you have a dedicated PC2 worker that only does that, and it does it all the time, you have a pretty hot GPU, because it is hammered all the time. But that's pretty good, because it means that your computer might not have to be that, the rest of it doesn't have to be that hard. What does need to be there is, it is the same with the NVMe's, because as you have NVMe's in the PC1, which need to create these kind of large size sectors, they need to be transferred to PC2 before they can be processed there. And for that, you need the network. You can't do 1 gig. You need the 10 gig for that. But you also need an NVMe in the other end that can actually, get that data in. Yeah. But the thing is that you will also see here that these kind of setups using a 2070 Super or a 2080 Ti, they can actually handle quite a lot. They are pretty fast, so most of these are, can actually handle a pretty big workload. But we've also seen that if you do go into some of the the older like 1080s, not TI, but the 8 GB versions, it can start to slow a lot. So I had one older machine with an 1080 that was more like 1 hour and 15 minutes to do a PC2. So these cards are really good at it. Another point I could make here is that we have some very lucky people experiencing with the 3000 series. And I think the problem there is that basically when you do the Bellman that operation, it needs to be optimized for the GPU. And now the 3000 series comes in with a new CUDA count, which is awesomely high, and a new count of memory. And there is this calculation when you give it how many CUDA cores that you have, then it tries to, figure out what is the best setup. But currently, I think there's a lot more juice in those GPUs that is currently not being used, because probably that needs to be also optimized again. So it seems like right now the 2080 Ti is probably the most optimized card for doing these processes. So it's still a good choice, and the other ones will probably be better in the future. But right now we don't really see it that much. So on the C2, basically you also like a lot of cores here, because some of the C2 process is also a lot of CPU intense actually. So that's good. A thing that I didn't say with the PC2 and the C2 is that you can actually use Intel CPUs on this, and it works fine. So I have an Intel worker right now doing PC2, and it does it, the PC2, in also these 22, 25 minutes. So no difference at all. But then again, if you are talking about high core counts, then you will be talking about Xeons. That's really nice if you already have them. But I experienced that it works better on the gold and on the gold scalable versions. I also have some older like 2680 V4s, and although that it is a V4, you should think that it's like fairly new, but it seems to be pretty lame. And also it's using a lot of power. So it's kind of running on all the cores and spending all the power it can do, but it's still slow. So I don't think it's really, if you're going to buy new hardware, then buy probably new instead of buying that kind of old stuff, hardware. But it is important to say that that the Xeons does the job just as fine on these workers, not on PC1. Yeah, so that's pretty much it. The differences I just pointed out here is that while I was able to do a pretty good time on the 2070 Super on PC2, then actually here the difference between these GPUs is pretty significant in C2. So I would say for C2 specifically, it's a pretty good idea to have a strong CPU or GPU. Sorry. Another thing that we are also seeing is that a pretty big EPIC CPU can actually also do the whole C2 in 1 hour and 45 minutes, I think it was. So if you're looking at this over here with the 2070 Super, actually it's about just as slow as if you just had the EPIC CPU actually doing the C2. So that's interesting if you're not going into having expensive GPUs and doing it really fast. So that's another thing. But you see over here, when going back to PC2, that the difference between these two GPUs when doing PC2 is actually not that different, and probably both could work for having a pretty big setup. So what I did was basically I had one of each. So one of each of these, and in general, they are in average about half an hour if you combine them. So I was able to reach about a sector every 15 minutes on this setup here, combining these two. Yeah, so that was basically what I wanted to talk about, what is interesting on these parts. I also have some things here on the miner. Now, the miner in itself is much more difficult because the workers, doesn't need to be very secure high available, and all that kind of stuff. Because the worst thing that can happen if a worker breaks down or the LVM drives burn and so on is that you lose the sectors that it's currently working on, which is like not a big deal. And probably if you even have more workers, then you can reorganize them into keep on sealing. So it's not the biggest problem, but the miner is a much bigger issue. And the thing is that, you know, I'm not gonna say that you should do it in one way or the other, because in the end, you know, if your miner breaks and you lose your I don't know, you kind of your metadata and so on, and can't restore your sectors, then you are like super screwed. So, you know, how to set this up in the best way is it depends on how much money you got and how much risk you're willing to take, I guess. So having a single rig to do everything and not having any rate or anything, that is maybe the more like a cowboy style. And as long as it's making money and you get some of it out, it's good. But, you know, if you lose it all, then that's just it. But for these setups, I basically just try to say that, you know, you can put it into three different types. You have the ones which use GPU, like I do. So basically, you rely on having a pretty strong GPU to do the window post, which would be the proving sectors, and making sure that you keep your power, your storage power, and also the winning post, which would be you know, when you get enough power to mine blocks, that you're actually fast enough to provide that winning post to actually be eligible for a block reward. So that's also an important part. But what I learned, not by my own experience, but what I learned from the last month, is that you also have the opportunity, if you have a pretty large CPU rig, you're actually able to run this without GPU, and you're also able to mine blocks. But the general thing here is that it probably needs to have a lot of cores, because if you are getting you know, a lot of utilization by the daemon and so on, then you might have issues on actually, you know, making your window and your winning post in time. So that's really important. Another thing that I put in here is that in general, you know, your OS data and so on probably should be on a RAID 1. You probably also need to do the backup, which is also a new feature that you can do of your data store. So just to keep that safe, keep your wallet safe and so on. But at least you need a RAID 1 so you can continue working. But then again, you know, if you have a small rig, it could actually be okay to just have backup, and then if it breaks down, just rebuild it. So we have seen workers, or like, sorry, we have seen small miners actually moving their setups from one computer to another. So it is totally doable. So basically, you could back up things, and then if it crashes hard, then, you know, rebuild and get on it again. But in general, you know, I think it would be a good idea to have a RAID 1 to keep that up if one drive breaks down. And then in general, on the data disk, I have so far been using RAID 6, and I haven't seen much problems with it. So I would generally say that if you have like small setups and want to make this work without too much trouble, then it might be a good idea to not make those RAIDs too big. So one of the things that we see is that if you have like using the new 18 terabyte disks, well, do you know how many hours it takes to actually initialize an 18 terabyte disk when it can only read and write with 200 megabytes per second? Well, that's 1.5 days. So if you need to rebuild a RAID 6 that has a broken disk, it's 1.5 days. So, you know, that can be a problem for you if you get too large. Another thing is that don't put too many disks in. So my RAIDs is generally 12 disks each, but I would rather have many RAIDs. And then, you know, if one breaks totally to crap, then, you know, I still have a lot of power, but this area I might not be able to recover. I might need to do a backup or something like that. that's in general there. So one thing that I have been another pointer here is that in general I have been using the app piece. So when you pledge a new sector, I have only had that running on my PC1 worker. In the start, and I don't think it's like that now, but in the start, if I also had that enabled, like app piece was true on my other workers, then you could get an app piece job that went to a C2 worker that already had 2 C2 jobs. So basically, it wouldn't start the process of a PC1 before after like 2 hours. So that would be pretty stupid. I think that changed now, but still, you know, I normally just use my PC1 worker to do the app piece, and it takes a little bit longer. But again, I don't care about that time because that doesn't really, you know, go into the bigger resource calculation. And the other thing that I will generally stress here is that, you know, when you look into this size, and you might go back and see them afterwards, remember that although that they are each specified a little bit different, then you might be able to use the same computer for each of this. So think about maybe having the same motherboard or the same server as base. And then, you know, some of them you don't put that much memory in, some of them you put a little bit stronger CPU in, some of them has a weaker one. But in general, if you keep the platform the same, then, you know, when we go a couple of months from now and from the Lotus team come up with something totally cool, or we change the algorithm, something like that, you know, you are still able to rebalance and flex the system and not locked into that, you know, I just built this on a Ryzen which can have only 128 gigabytes of memory, and now I have no process that I can run on there. So that would be my recommendation at least. Not saying that you should, you know, get rid of it if you already have it. Just if you buy new stuff, then might think about having, you know, a bigger set, just having this idea about that you could, you know, change everything if you'd like to. Yeah. So that's about it. So from here on, I have some pictures of what it looks like today in my basement. I know that I got a lot of comments on this last time, so that was a lot of fun. But the general idea is that you know, it's not enough for me to be a little bit idealistic about Filecoin. I also think that this should, you know, not be a total waste of energy. So what I do is basically have my my workers and my miner hooked up to my my floor heating. So what I do is basically what you see here is the back of these 2 rooms. So that's basically where I have my miner and my worker and my storage. And what I do is basically just have everything water cooled, which is like basic computer cooling. But the trick I do is then I send it up to the boxes up here, which is heat exchangers. And heat exchangers basically goes on to my floor heating, which is kind of dirty water. But I kind of keep it separate, so you have that that really cool green fluid that you can see. But anyway, it is clean. And you heat exchange the heat from all the GPU, CPU, and so on up into my floor heating. And the good thing about my floor heating is that it's kind of an endless way of getting the energy out, because I haven't been able to pull it higher than 40 degrees Celsius so far. So it's like, you know, how much power I put in. It basically, you know, there is so much that needs to be heated for the water to be 40 degrees. So that works very well so far. So I think I have a little bit over 100 terabyte of accessible data for so far. But I also made it really upgradable. So what you see is, I don't know if you can see it, but actually I have like a quarter of my actually drive base populated at the moment. So there's a lot of space in here. Another thing that is pretty funny in this setup is I have these custom made. So I wanted something that, you know, would not fill up like a full big rack, because this is in my basement at least. But so what I did was I had these custom made these disk arrays. So they basically only can contain the front part, and they're only like 25 centimeters long, about 10 inches, and then nothing after that. Because what I do is basically I just take the power cables from my power supply on the miner, and just drag them into powering the array. So I don't have additional power supplies. And also the SAS cables is just coming directly from the controllers, just using like a 1 meter SAS cables. And what that means is I can basically run this whole array on my single miner. And I'm not using redundant power supplies for this, but I'm also not using that because, you know, yes, it's nice and we use that on all the server hardware I work with, but for this purpose, it doesn't really matter that much. Of course, I don't like data corruption, but then again, you know, it is, you know, unlikely that it will be everything broken. Probably if it's writing a sector when it happens, then it's really bad. But apart from that, I think this is a pretty good way. And the cool thing about it is that, you know, running the miner without any workers on, I only have one power supply. So another thing that I set up since Space Race 1 was that I actually downgraded from the 56 gigabit switches that we normally use that on my high performance clusters, and I had something in spare, so I just use that for Space Race run. But basically now I went back to the regular 10 gig and just use that, and in general, you know, that performs just as well, and it's not really a bottleneck. But I have this kind of combination of using normal RJ45 for some of it, and then I also use fiber for others. So basically, all this is set up with fiber. But you know, whatever, it works pretty good. And I haven't seen much problem with the networking. You just need to make sure that you're using jumbo frames for that one. So that's MTU 9000. Otherwise, basically, you don't get the throughput. So I see the throughput about a gigabyte per second. That's pretty much around that. Yeah, and another comment that I was just making with this one is that when we did Space Race 1, I had this Intel mining set up where trying to see how much can I actually do on Intel. And I ended up with having everything else than PC1 working on Intel machines. So the only caveat about this is that on this rig, I did not get enough power to actually be able to win blocks. So I'm actually not sure if my Intel Xeon here would be able to do that. But then again, you know, it should also be a GPU job partly. So it might just work at least for synchronization of the chain and for doing all the window posts and so on. No problems at all. So basically, this is just to say that you can actually run this on pretty old hardware. And as you see here, I also got some pretty old stuff going on over here. And you see the memory is not even fast and so on. But still, you know, this is actually producing sectors. So, you know, if you have stuff like this lying around, it might be usable. The only thing is that probably you'll just see that, you know, the power consumption of these old, big, slow setups might not be that efficient. But I'm actually still using the Intel setup down here with the really small, it's only a 4-core CPU. And I've actually also been using that for C2, which really stresses it out, but it does the job. So it's like you can still use that. So it really depends on what you got already in stock. You can use a lot of different things, but it really comes back to the beginning with you know, having these kind of calculations where you're actually able to calculate. So how fast can I do PC1? So how fast do I need to produce my PC2 and C2 to make sure that I'm not doing any congestion, and also that I'm not oversizing my PC2 and C2. And if you go to the start of my presentation, you will actually see that the big setup I had for Space Race 2 was actually quite oversized on the C2 and the PC2, and that was actually just part of, you know, figuring out who of or what of these workers was you know, performing good and who wasn't. So that was too much resources in there. But you know, from the example that I gave with that timeline, that's a pretty solid and pretty strict setup of how to run it right now. And it also comes with that thing about that, you know, if we get this optimization with PC1 in a couple of weeks or earlier, then we might have a PC1 worker which now has double performance. So now basically that's why I keep my PC1 worker pretty small at the moment and do not have large amounts of memory, is because, you know, if that goes to double performance, then basically the rest of my setup now needs to be double until that has also been optimized. But these are kind of the rules as long as we go with these smaller setups. So I guess we are kind of coming to the end here, and I think we also almost out of time. This one is just saying the setup that I also showed in the Space Race 1. So you can actually do it fairly cheap. But again, you know, this does not have the enterprise NVMEs. But that's pretty much everything from me. So I know this was a big mouthful, and I think there might be some questions. I don't know if we have time for them, but otherwise, you know, I will definitely be online after this as well. Yeah.
Thank you so much, Ben. That was wonderful. I was chatting to Ben earlier and said that his space race presentation was just like really, really popular. It's so interesting, I think, to hear from someone who went through space race. Obviously, a lot of upgrades and changes have been made since then as well. So just kind of like navigating that and coming through to mainnet has been such an interesting journey, I think, for you and a lot of other people. So it's been great to follow, and I hope you'll continue to kind of share your wisdom with the community. I know that you're really active in the Filecoin Slack as well, Ben. So if anyone does have any questions, like please feel free to pop in there. Ben, you've got a fan club now, so I think everyone's going to jump over and be asking your advice. And yeah, maybe we can share some of your slides as well. I think there's so much really useful information on there. It would be great probably for folks to get a second just to take it all in. But thank you so much again. It's been really amazing to watch your progress throughout, and you know, it's awesome to see miners like yourself on the network.
Yeah, cool. Thanks. And I'll just look in the questions here and see what's fine. So that's cool.
Have a peek. Yeah. Okay. Up next is our miner tooling showcase, and we'll also be announcing our miner tooling grants. Hooray! I know a lot of folks have been building miner tools, so this is a great opportunity to get some money behind it as well. In the break, you can pop into our lounge, which is linked here in the chat, and chat with Ben and other members of the community. Maybe you've got some questions after that presentation, so that's a great place to go and you know, just catch up with folks and learn more. And you can also pop into our Slack and ask questions. If you're getting started as a miner on Filecoin, there are a lot of people there who have been with us back from the calibration net through Space Race and are willing to help you get started. So it's a great place to be. Okay, we are going to be back here in about 12 minutes for our next session. So yeah, pop back in then and we'll see you shortly. Thanks so much. Hello, everybody, and welcome back. Welcome to our next session. We're going to be talking about miner tooling and enjoying some demos from the community. We're also going to be talking about the newly minted miner tooling grants program. Very exciting. If you have any questions for any of our speakers in the next session, then please pop them into the Q&A box, which you can see at the bottom of your Zoom screen. And we'll make sure that they are answered at the end of the session. Also, a reminder that this session is being live translated. So if you would like to follow along in Mandarin, you can press the interpretation button at the bottom of your screen. Okay, on to our fabulous speakers. Our first speaker is Belma Gutlick. Belma is a Master of Software Engineering with a passion for new technologies and an adventurous spirit. Lovely. Crypto enthusiast for a long time, but all in blockchain technology since 2017. She is co-founder and CEO of Node Factory, a blockchain R&D company that develops dApps, tools, and infrastructure. Today, she is going to teach us about Hactar. Over to you, Belma.
Thank you, and thank you everyone for joining us today, and congratulations on the Liftoff, of course. I'll share my screen now and start with the presentation. Just a second. So Hactar is a tool that we have developed as part of the grants program. Our motivation for building Hactar was a need that we recognize when mining ourselves other coins, or generally, is that you need to have some data insights at your fingerprint, at the tips of your fingerprints, because you don't want to connect to the remote server and check the data there, run the CLI commands, but this is a tool where you can connect either from your mobile phone or from your PC to a web service and have all your stats in one place. Our landing page is hactar.app, so you can check it out and start using there and read more information about it there. So currently what Hactar can do and which data it can read is general status of a miner node. This includes on which Lotus version your node is running. Does it need an update or not? So you'll have a check mark about that. Is it online or offline? Of course, because that is a very important metric. What's the disk occupancy? Is it the disk near full or not? And general miner info, which address is used, how about sectors and their sizes, and miner power. So a general overview. And then it contains some history overviews and graphs on miner performance, such as when was mining reward collected, history of uptime, when the node was online or offline, and list of deals and their status, price, and how long they have been active. And of course, the important part for us was the offline monitoring. So you get a report on in your email that your node is down. This is the current version of Hactar and which information it has. If anyone has any other needs that has feedback depending on this, we will listen about it. So shoot us an email. How Hactar works is actually combines three parts. On the left side, you can see that a miner has a few running nodes, let's say, on each along each node and Lotus node and miner. You need to install a Hactar daemon app. It's a small app that reads from the Lotus node and miner information and reports to our API. And then there is our application that just reads our API and data from the database that we serve this data from. So basically, you don't need to expose your miner API or so on, but the Hogtar daemon app reports all the data. I'll go through a short demo how to set it up and how it looks like. The demo was built on DevNet, just to note the numbers. So this is our landing page of the app where you can register. It's free to register. You can sign up using your email and sign in as well. So that would be the first step, to go to analytics.hogtar.app and register there. There you'll receive information what do you need to do on your miner server, and that is install Hogtar daemon app. So you connect your remote server where you run the miner, you download Hogtar, give it execution permission. Sorry for the bad copy pasting skills here. But you just need 3 commands to run it, and it works out of the box. You use the same login, of course, because we do have authentication there. Sorry, I misclicked here. Sorry about that. Yeah, and start it and enter your information, the same credentials that you have used to register on our website. This was the message that my miner is down. So just to set up everything, I have run Lotus node. This is a familiar process to a miner, I believe. And then running one miner node. And now I can start Hogtar because it needs a running node. So basically that's it. You just start it, and if everything is all right, it should be reporting. And if you refresh your dashboard on our app, you would be able to see the stats. So here's the message that update is available, and this is the general miner info that I was talking about, the sector sizes and the miner power, how old is information. You can turn on and off the email notifications. You can manage your nodes, and it supports multiple nodes. So if you're running multiple miners, you can all do from one dashboard. The remaining data is balance, how much your balance has changed depending on the previous day, how long has it been online, the disk space through time as well, and mining rewards through time. This was on DevNet, so not much data. And deals and their status, size, and price. So it's a basic data about your miner performance, which can be easily installed and easily viewed from the app, from wherever you are. And this is an example of email notification if your miner gets turned off by any chance it's not working anymore. If you want to learn more about Hogtar, you can check out our main repository on GitHub, or you can go to our application as well, analytics.hogtar.app, and just start using, and that's it. Basically, it is ready for use, and would love to receive your feedback regarding that. So thank you. Questions will be later, I believe.
Perfect. Thank you so much, Galma. Hacktor is so cool. That's the first time I've seen that demo, so it's really, really exciting. It's all brand new for me as well. Yeah, so cool. And the stuff that you're doing at Node Factory, I know you're building a couple of different things on Filecoin. So yeah, this is super exciting. I'm looking forward to your other presentation later in the week. So thank you so much for taking the time to share with us. That's really cool. We're going to pop the links in the chat over here. If you want to go and check out Hacktor now, you can. Maybe wait a minute until the other presentations are done. But yeah, you should go check out Hacktor. Also, like Balma said, please give feedback. It really helps. And yeah, it's super cool. Really exciting to see all the great stuff that's being built. Okay, our next speaker is Julian. Julian has a strong background in IT and telecommunications, working for Fortune 500 companies. In his spare time, he enjoys hiking, teaching abacus, awesome, playing Go and tinkering. He also participated in Space Race, so it's lovely to see you again, Julian.
Hi, thank you, Andy.
Today, Julian is going to introduce us to Lotus Explorer. Take it away, Julian.
Okay, thank you. Let me share my screen. There we go. Oh, can you see my screen? Angie, can you see my screen?
Not quite yet. Not quite yet. See if I can help.
Got an error message. Let me try again.
Yeah, try the screen share again. Sometimes it takes a wee minute to warm up, Julian. Perfect, you got it.
Yeah, good.
Looking good. All right, lovely.
Okay, excellent. Hi, everyone. So my name is Julien. I'm a miner. And today I'm going to present what we developed for visualization and analytics. So quick introduction. I'm using IPFS for like, I think 3 or 4 years. And I jumped on the Filecoin via the Space Race 2 months ago. 1 month and a half. And so today what I'm going to present is that how we can use and leverage Grafana, which is an analytic tool that we want to use. So it's open source. And here we go. So the objective for us was like during the space race, we identified that we were just have a lack of reporting tool. We were not able to do any proactive monitoring. We don't have any push notification to mobile. So we want to focus on that first. But part of this project, we also expect to improve all the operation on managing a miner. So actually we want to move from reactive to more proactive, and don't spend all our time just watching our screen. So this is how it looks like today, and how it was during the space race for me. So it's like a lot of terminals to watch all the different logs and command lines with all these useful information. So the good point for us is that Protocol Labs with Lotus, they provide API to get almost all this information through these APIs. So the idea is to move from this current monitoring to Grafana. So Grafana is open source. It has a very, very huge community, and we already have a lot of dashboards out of the box that we can leverage, but they were missing Lotus miner information. So what we did is like we leverage Grafana, we leverage Prometheus. So Prometheus is a database that collects all this information, and Grafana is presenting this. And so we developed what we call a Lotus exporter, which is a small component that you deploy on your miner, and you retrieve all the data that are then analyzed by the system. So we are two to work on that. There is a sender and myself, Sonic. So you can join and reach us when you want on Slack. So Lotus Exporter exports the Lotus information to Prometheus and Grafana to build nice graph and notification. So here it's how we work and why we decided to go for Grafana. So one of the main idea is that so Prometheus can collect information from a lot of different protocols and targets. So the Filecoin here icon is to represent the Lotus miner. So we deploy a node exporter, which is a component from produced by Prometheus. So it actually just bind the port and you can just retrieve a lot of data. There is a very small footprint on the server, so which was quite useful. And one of the big difference with the other competitors or the other solutions is that this one you are putting the data. And so because actually our Prometheus server is on our private network, we don't want to expose our private network to the Filecoin nodes, which is on our public network. So what we did is actually we prefer that just putting that, having a software here that is pushing the data. And once the data are in Prometheus, you just have a web UI, which is very, very nice. I'm going to do a demo for you. That is creating all the different graphs based on the data we have in Prometheus. So why Grafana? So there is a huge, huge community. You have a portal. You can download a lot of existing dashboards that are impressive. You can easily export and import this dashboard. So it's very convenient. The UI is very, very, very nice. You can customize almost everything. It's easy to deploy and configure. And the component that is deployed have a very, very small footprint on the machine. So I will explain that later on. And out of the box, you already have dashboards for all the system information and the GPU, the NVIDIA GPU that we are leveraging. They already have dashboards, so it's very easy, and you will have a lot of reporting information here. So what we developed is a Prometheus exporter. So that they define on their website how an exporter should work, and we just follow the guidelines. So it's a very small program. It collects Lotus nodes and miner data. Everything is done via API. So the idea is that when there is new release, we don't have to readapt the code based on the different command lines. It's completely configuration-less. So you have nothing to do except running the script on the machine. It's pulling the data every minute, and there is a small footprint. The execution every minute is just 1 sec. So in this 1 sec, we gather like between 1,000 and 2,000, depending on the size of the miner, information from this miner. Data are pulled from Prometheus, I just explained before, and you just deploy it on the Lotus miner. You don't have to deploy it on all the different workers. We have 2 different versions today of this exporter. So Standard is working on a Node.js version, which is a daemon running on the machine, binding a port that's connected. In parallel, I developed another one, which is a Python script that is run by the cron tab. And it's done every minute. So the result is exactly the same, just 2 different approach. I will not go through all this now. So let's go through a quick demo. Okay. Screen sharing. So now you should see my screen. Okay, so what I'm presenting here is, so let's start by this one. This one is the output of the exporter that is running on the miner machine. So this is all the lines that are produced by the exporter. So it's very easy to troubleshoot, and you can, I mean, the script is not that big, so anyone can just review it and modify it. It's very, very quick. So that's what is produced by the every minute. Then you have the Prometheus server, so the database that is collecting this data and presenting this data. So same thing, you can connect it. It's very easy, very convenient. You can run troubleshoot. I mean, you can see real time what are all the different values. And then this is how it's presented. So here, this is the standard dashboard, which is coming, I mean, out of the box in Grafana. So as an example, this one, you already have all the useful information you expect to monitor the system. You have the CPUs, you have, I mean, there is hundreds of dashboards in this one. And you can select the one, you can easily take it, create your own like this, modify it just in 2 clicks. Everything is through the you don't have to script almost anything. You don't have to script. It's just configuration. You can change the colors, you can change the threshold, you can change the notification. Everything is very easy and very convenient. So this is the standard one, which is of course missing all the Lotus information. So what we did is this one. So the idea, so what is the target for me is to get rid of all the terminal, except when I have a problem and I need to connect to the machine. So I want to get all the different screens on the same one. So this is work in progress. This is just the beginning. We're starting this like a week ago. So, okay, this is what we have today. So the first thing is that we created it to be able to manage easily different miners. So we can leverage this. Today we have, I have a few miners. So let's go through this one. So what we presented here is that we retrieve information from the network, like the chain head network. We are on mainnet. You can see your power. So this is real time. So that's my power today. Different balance with different colors. So here, like this is the available balance, the one that is the most important, because when you're running out of fund on this one, you go into trouble. So here you are monitoring the miner, the owner, the worker, the control address, so, and you get colors and you get notification when actually something is going wrong here. You have some funds that are locked, like the pre-commit, vesting, pledge, and also fee debt, and other wallets. So I've got a few other wallets that you can see here, and I can easily monitor. We can also retrieve useful information like the daemon version. So when you are managing different cluster, it's easier to identify if something is going wrong. So we are going to have a full inventory on the server that is available on this dashboard below on the page. But you can also have some, we can check what are the net peers. So if it's going too low, we know that we are going into issues. So same thing, the green is changing to orange and red. Now, the useful part that I was missing during the space race. So we can follow the number of sealing process in real time. We have here, so what you usually have in the command lines. Yeah, so as you can see, so here it's manual refresh, but you can set it up to like every 5 minutes or every minute if you like. So everything is live. It's connected to machines, so you can see what are the sealing jobs, different stages. Here we created one that is showing all the history of the sealing jobs, and you can see in the red line, as an example, what is waiting. So it gives you useful information to troubleshoot and see that you have a lot of jobs waiting. So maybe your settings are not optimal, or you have a problem in your scheduler. Yeah, number of sectors. So sectors reporting. We have, this is the sectors I've got today. The probing sectors. The mpool, which is empty, but like during SR2, it was a different story. So here we are monitoring the mpool. So if I send a message, you will show the message appearing here. I can try just to show you how it looks like. Here we go. Expecting it takes more than 1 minute. Okay. Yeah, here we go. So it's showing the message, and we have some filter here. So it's showing the owner address instead of the existing address on the network. So it's more visual and it's more easy to troubleshoot. So when you have your proof of space-time coming, you will see the control address, so you can see if there is a control address in the queue. Yeah, that's all for this. Other graph that we are doing, just to same thing to troubleshoot the different seeing jobs and the queue. The balance, different balance. So we graph over time. What do we have here? Yeah. So this is some useful information that usually we don't really have a look, but that can be useful for troubleshooting from the daemon. So you have some bandwidth and usage of the different components that are exchanging data on the network. So that are same thing real time here. And yes, that's the last one is the time that the exporter is taking to retrieve the data. So as you can see here, the last one was like 2 minutes, but most of 2 seconds. Sorry, most of the time it's more like it's more like 2 seconds or 1 sec. What is taking time is to retrieve the data from the different sectors. So this is something you can disable if you don't want to get reporting on the sectors. I personally, at that time, like to get that type of information. Yeah, so let's go back to the presentation. So what's coming next? So we can easily integrate all the storage information, all the deals information. We can create more analytic graphs. So same thing, if you got ideas, feel free to give me these ideas. I mean, presenting the data is, it's really a green field here. So we have plenty of possibilities, and most of the time I just don't really know how to present this data. So if you get ideas, that's fine. Deadlines are coming next. So they're already available in the exporter. So it's just a question to how I present the data. And useful information about the network, like the gas price, also the worker resources. We are not showing here, but I used to leverage through the different command lines, and I would like to get them available here. And the number of blocks, of course, we want. So if you want to help, you're more than welcome. I mean, creating graph is not very difficult. Jumping into Grafana, it's just taking a day. So you're more than welcome if you want to create and propose and try this software. The Python one, the one I'm leveraging for this graph we just show, is actually not available right now on GitHub, but I will release something soon, probably by the end of this week. So I will share the link. In the meantime, you can reach us through Slack. So our 2 different addresses are just there. And that's it.
Awesome. Thank you so much, Julian. So cool. And I think one of the things that I love the most about the kind of story of how this started is that you met your collaborator on Filecoin Slack, which is just amazing and a kind of testament to kind of what a lovely community this is and how collaborative it is. So great to see the progress that you've made since we last spoke. And I really encourage anyone out there who's excited to contribute to get in touch on Slack. We'll definitely post a link to the project, but reach out. Like, these projects get better by community contributions, and yeah, just absolutely brilliant work, Julian. So exciting. So thank you so much, and thank you again for coming along today and sharing that with us.
Thank you, Angie. Thank you.
Awesome. Okay, up next, we're going to talk about something very new, which is minor grants or minor tooling grants. Our presenter, Eva, has been coordinating the Filecoin Dev Grants program up to now, as well as several ecosystem initiatives. She's worked in the blockchain space for 5 years and has a background in UX and software development. Over to you, Eva.
Thanks, Angie. Okay. Can you guys see that? Okay. Hi, I'm going to give a quick overview of the Dev Grants program, then talk about the miner tooling RFPs we have and the Gitcoin Grants quadratic funding program they're currently a part of. For Filecoin Dev Grants, we accept proposals at all levels of the technical stack. This includes at the protocol layer all the way up to end user applications and user research. We also accept proposals for mining tools. Belma's Hackdar app was actually funded by a Wave 1 Filecoin Dev Grant. Filecoin Dev Grant Wave submissions are normally due quarterly, every few months. We will accept your proposals on a rolling basis at any time, but at the beginning of every quarter, we get a refresh budget and start reviewing and improving new grants after the deadline. So for priority consideration in a wave, it's best to submit your proposals at the beginning of each wave. Currently, we're in wave 5, and that was due October 1st, and our next wave 6 will be due January 15th, and wave 5 recipients will be announced soon. We currently have a special round for mainnet liftoff of grants for tools to support Filecoin miners. The deadline for proposals for this is November 21st, and we have a $50K budget in grants for this. So this is going to be part of the Gitcoin CLR quadratic funding program. How it works is that for every 1 DAI anyone from the community contributes to any of these grant projects, Protocol Labs will match that contribution using a quadratic formula, specifically the sum of the square roots of each contribution. So this allows many small contributions to matter more than a few big ones and is a way for the community to vote on these ideas. So even if you just contribute 1 DAI, it lets us know that you voted for this project and believe in it. And the more people vote, the more Protocol Labs will fund it. So quadratic voting has been a really cool idea that's been around for a while in the blockchain community, and quadratic funding has been very successful for the Ethereum community. Vitalik Buterin has a blog post analyzing Gitcoin CLR rounds and wrote a paper on it with Glenn Whale and Zoe Hitzig about applying it to public goods for the commons. And as an example, there is a Gitcoin community fund for implementing EIP 1559 by the, currently worth over $95,000 in DAI. So we are trying this out for Filecoin for the first time. Also, anyone can submit their ideas for projects on Gitcoin. So you can suggest an idea and submit it there. And you will see a few already submitted ones from this page. On that page, gitcoin.co/grants/liftoff. And you can learn if the community supports your idea, and Protocol Labs may also fund your project, even if it gets no other contributions. We'll review them. So visit that URL to look at the list of projects and contribute or suggest your own project. There are currently 9 miner tools RFPs to start, and we may post some more in the next week or so. And so to recap, we have 9 starter RFPs. Anyone can propose new projects. Anyone can contribute DAI to sort of vote for a project, and we will match that with quadratic formula. And contributions have to be in DAI, but Gitcoin is adding Filecoin soon. And we hope to help get all your ideas and tools built. The current round ends in 1 month on November 21st. And if you don't want to use Gitcoin, you can submit any proposal the regular way at the Dev Grants repo on GitHub. And if you have any questions, please DM me at Eshon, ESHON at Filecoin Slack. Next, I'm going to talk about the 9 miner tool RFPs we have posted. PL will be seed funding these tomorrow with a few thousand in DAI to start. To research these RFP ideas, we interviewed various miners and got some terrific suggestions from community members. There are some tools to support smaller miners specifically, like the monitoring tool, which is just about helping a miner monitor their system resources. It was actually Julian and Sandra's idea. So this could also just be a script or tutorial on how to set up monitoring using Prometheus and/or Telegraph, and potentially Grafana, that a small miner could easily run. We're interested in helping a small miner run it on the same machine as they're running their miner, but we also welcome more advanced monitoring tools. Yeah, so Julian Sanders' tool may be eligible for this grant. Next up, we have the miner sector checker, which is about adding more intuitive CLI for finding failed sectors and removing them. Miners currently need to keep monitoring their sectors and respond to faults or failures, making this easier to check and then pull up relevant logs and messages along with the CLI, and would be really great. So the third one we have on this list is the CID indexing tool for miners, which is about making a miner's storage more transparent and accessible to storage clients and retrieval clients, such as developers building storage apps. So this idea came from Juan Benet himself and is about indexing all the CIDs that a miner has. And it really would help the retrieval market for people to be able to look up like which miner is storing which CID. The next few we have is one is a miner transaction history and earnings predictor RFP. So it's currently not easy for a miner to figure out all the fees and gas and specific transaction history they have, even on a block explorer like Filefox. So nor is it easy to predict earnings. So we've had a lot of requests for an ROI calculator, but it's kind of complicated to build one. So we're starting out with more basic components. This is about just interpreting a miner's transaction history in detail, and then using that data to predict future earnings. And another basic goal of this is to help miners figure out how much they need to keep in their wallets for fees over time. Next is the auto add new sectors based on capacity. Adding new sectors is currently managed manually. It'd be great to have a tool that can monitor systems resources, and if there's capacity available, automatically accept new deals and add new sectors. Next is the mining task pool for smaller miners. This one is a little controversial because it's a trustless mining pool is not possible in Filecoin right now. We may have to propose an FIP to the protocol or wait for user-defined smart contracts coming next year. But this was proposed by a community member, and some miners may want to try it out anyway. And we're interested in funding any updates to the FSM that could be used to farm out tasks to smaller remote miners. Next few, we have the gas tool and guide. Any tools to help explain current gas, including base fees and fee cap for each tip set, and average gas premiums could help community members also understand how gas works in Filecoin. And the next one, miner docs and community guides, is kind of a fun one. There are two parts to this. We currently welcome really good PRs to the Filecoin docs. It will be at the discretion of the docs team what qualifies as a good PR worthy of a grant. And then the second part is if you write a blog post or make a tutorial or a video with tips and analysis about your Filecoin miner or mining in Filecoin in general, we might fund that. So here are some topics of interest. For example, like how did you set up your rig, set up tricks for Lotus, your redundancy strategies for storage redundancy, monitoring tools that you use, and your disaster recovery plans. So all contributions will be judged based on quality and award amounts determined afterwards at the discretion of the grants and docs teams. So a docs PR could be worth anywhere between $5 to $150. An entire topic that you write about could be worth between $1 to $500, and a miner video tutorial could also be worth $1 to $500. Finally, we have the miner hardware profitability calculator. It's a general calculator for hardware setup costs and how that impacts ceiling rates. It doesn't have to include collateral. Someone else is building a model for that. So this is just about sort of estimation of hardware and ceiling rates. So those are the mining tooling grant RFPs we have so far. And if you have any questions, reach out to me on Filecoin Slack. That's it.
Awesome. Thank you so much, Eva. That's really, really exciting. And I'm sure a lot of folks here have great ideas. Yeah, so please share them. Just to recap, Eva, the Liftoff round closes on the 21st of November. Any other special deadlines that we should be looking out for?
Nope, the grants are live now in Gitcoin. We'll be funding them starting tomorrow. So keep a lookout and keep a lookout for more ideas.
Amazing, that's perfect. Thank you so much. Well, that's it, folks. Thanks so much to our wonderful presenters, Belma, Julian, and Eva. Please go check out Hackter, Lotus Explorer, and the grants. We'd also love to hear about the tools that you've been working on. You can come and demo at future Miner Show and Tells. Just message us on in the events channel on Slack if you'd like to present. Okay, we're going to take a short break now. Unfortunately, our next presenter isn't feeling too well. However, we have a recorded presentation of the deep dive into Filecoin mining. It's awesome. I encourage you to still pop along and enjoy it. If you're interested in getting really into the details and into the kind of or under the layers of Filecoin mining, it's not to be missed. So join us back here in about 20 minutes. In the meantime, feel free to pop over to the lounge and chat with fellow attendees and Filecoin community members, or pop into the Slack. I know there's a bunch of folks there hanging out and asking questions and sharing their wisdom. See you back here shortly. Thanks so much.
Hi, everyone. Welcome back to our next session on Mine Day of Filecoin Liftoff Week. Now, unfortunately, our presenter, Magic, isn't feeling too well today, so we're sending our best wishes to him. However, he recorded this presentation a little while ago, so we're still able to share the amazing content with you today. But unfortunately, we won't be able to take Q&A at the end. Or in fact, I think some team members are here. So if you do have questions, post them and we'll do our best to get them answered. Anyway, introducing a deep dive into Filecoin mining with Magic.
Hello, everyone. Yeah, I want to try to start with explaining some core concepts behind Filecoin and Filecoin mining. Yeah, we'll go through some of them so everyone understands what I'm talking about. Yeah, we start with power. And Filecoin miner power, just basically the likelihood of winning a block, is based on the amount of proven storage. And that is slightly different from other blockchains where power is your hash rate or staked funds. Another thing that makes it slightly different from other blockchains is that you kind of accumulate power over time instead of using it linearly like hash rate. And one of the coolest features of Filecoin is that and Filecoin power can be actually useful. So you can use the storage to store your data instead of heating up Earth or not using your money. Yeah. The next thing is the concept of a sector, and that's the main unit of storage in Filecoin. It's just a fixed size piece of data. Yeah, each sector can contain multiple deals. A sector without deals is called committed capacity. All proofs and other operations like that are run on sectors. Yeah, moving forward, we go to storage proofs. And storage proofs are the magic sauce of Filecoin. There are two core proofs, one of which is proof of replication, which proves that a unique copy of data is it supports 32 and 64 kilobyte sector sizes, which is also relevant a bit later. Next, we go to actors, which are a bit like Ethereum's smart contracts. Every actor has a balance, nonce, code, state, and address. The key addresses, so the one prefixed with T1 or T3, are also assigned an actor under the hood. So every key address also has an actor address. Are also assigned an actor. Yeah. The difference in mainnet is going to be that all addresses are going to start with the letter F instead of T. So that's how we will distinguish between real addresses and the less real ones, or well, just testnet addresses. Yeah. Next, we go a bit more into specific actors. First one is the power actor, which is responsible for just keeping the network power table, and that is mostly just interacting with miner actors. You, as miners, usually don't interact with it directly. The only case is when you are creating new miner actors, which you go through so many layers that you probably don't even notice that you do. Next is the miner actor network power table. How you talk to the chain as a miner. It handles all storage events, verifies your proofs, tracks your sectors over time, this ties your mining operation to the rest of the network. You will be sending a lot of messages to it, without a doubt. Yeah, it can be controlled from multiple keys, but on the topic of keys, Yeah, Filecoin supports two key types, SIGP and BLS. And as miners, you have to use a BLS key as the main or worker key that you use to create blocks. This is because BLS keys have the intrinsic property that there is only one valid signature for one input message. And we use that to derive some of the randomness in the network. It also has the very nice feature that its signatures can be aggregated. So that saves a lot of space on chain, which we need. Next, yeah, mining. Filecoin mining is really free activities. It is just sitting or adding storage, just how you gain power. Then you need to prove that you store those sectors over time, which is how you keep your power. And then it's the actual block mining, which is how you get the network to move forward and also get block rewards, which makes it all worth it. Next, we go and look at the higher level architecture. No questions so far. By the way, if anyone has any questions, feel free to ask them as we go, because there's a lot of context switching here. Yeah. Fundamentally, we have 3 node types. As miners, you will likely be using all of them. On the top, you have the daemon, or what we call the blockchain node, which is what is talking to the network. The Lotus miner is what is handling all mining-related tasks. This connects the storage to the network, and that's basically everything you're interested in. And then you have Lotus workers, which are an extension of the main Lotus miner process. It allows you to add more resources to it. It can be run on multiple machines, allows you to build much larger mining clusters. And we will focus on the Lotus miner mostly for this stuff, because it's where all the fun happens. Yeah, it has 4 main components, all perform some mining-related activities mentioned before. The block mining, a window post scheduler is the thing that handles proving sectors over time. You have sector storage, which is the component which has sectors on disk and also runs most of the sealing operations. And then you have the storage FSM, which is what handles basically all interactions that need to happen between the blockchain and storage and market to get sectors sealed. So yeah, storage FSM or finite state machine. This is what is responsible for getting data from deals, assembling sectors, sealing them, getting them on chain. There is a bunch of steps involved in sealing a sector. Some of them are very computationally intensive. Creating a sector can start in 2 ways. You can either pledge a sector or create a committed capacity sector, which means a sector without deals, or you can start a sector by accepting some client deals and assigning them into a sector. When you accept a client deal, you will create a sector, put the deal into that sector, and then keep it open for, by default, 1 hour to hopefully put more deals into that sector. So you have to do less work to accept more deals, and hopefully get paid more for less work. Just probably what you want to do. Also worth noting, committed capacity sectors can be upgraded into sectors with deals. Upgrading a sector means that the initial pledge doesn't have to be paid again, or is reduced depending on the network conditions. It usually won't have to be paid. Next, from those 2 paths, we go into the common sealing path. We get into the packing state, where we just fill the sector app, so it's the full sector size worth of bytes. Yeah, it's basically just filling it with null bytes. Then we get to the first very fun step where we do the replication, which with SDR is a single-threaded process. It requires at the very minimum 64 gigs of RAM. You probably want more, and then some swap memory. Using more memory just makes it a bit faster. The process is inherently single-threaded, so you cannot accelerate it by throwing more cores at it or a GPU. It doesn't help at all. Yeah, the process creates 11-layer files, which results in just shy of 400 gigabytes of files in total that you need to keep on fast storage for a bit for the earlier steps. Yeah, you are able to discard most of that after the sector is fully sealed. The whole process takes about 4 hours in a Zen 2 and the Zen 2-based CPUs. And we're getting some optimizations soon, hopefully, so it should get somewhat faster. You'll see how much. Then from pre-commit 1, we go into pre-commit 2, where they have the encoded sectors. Now we have to build a few special hierarchical trees over the data. This step can be run on GPUs. It's highly parallel. It writes another 3 times the sector size of data worth data on disk, which is about 100 gigabytes for a 32 gig sector. It doesn't require too much memory, and it can be run on GPU. It takes about 30 minutes on a 2080 Ti, so it usually won't be a bottleneck in most cases. After we've computed the pre-commit of the pre-commit stuff, we get a few snippets of data that we send to the miner actor, where we tell our miner actor that we have replicated a sector and that we want to prove that it has been replicated. After that message lands on chain, we wait a bit for a random change, which we then use the commit step, where first in the commit 1 step, which is just reading a bunch of data to answer the challenge we get from the chain, we read about somewhere between 10 and 20 megabytes, this order of magnitude of data. That is our proof. Sending 10 to 20 megabytes of data to a blockchain doesn't work at all. So we use the magic of snarks to compress this 10 or 20-ish megabytes of data down to 192 bytes, which is a very, very large compression factor. But to do that, we need to compute a very, very big snark, which requires a lot of memory. Having a GPU is handy, and it still takes a bunch of time. So it will use a peak of around 170 gigabytes of memory, although for a very short time. So you can easily do that with 120 gigabytes of RAM and then a bit of swap. Probably should use less. We're not sure why it uses so much. It may get optimized. We'll see. Yeah, the whole process takes about an hour with a 2080 Ti for a 32 gig sector. After we do that, we submit the commit message or the port proof to our miner actor. We wait for it to land on chain. The miner actor then verifies that it's correct. If it is correct, it tells the power actor to grant us some power for the sector. And it also tells the miner actor that deals in that sector are now being proven, which means we get to have power, maybe win block rewards, and we also get paid for the deals that we've put in that sector. Do we have questions? We do. Yeah, there will be more clarifications and some config. Okay, we'll look at the questions later. We still have a lot to go over. Yeah, the second, probably most important component is the sector storage. It only really has two jobs, just to keep data around and run computations on it. It sounds like a relatively simple task. So this is the architecture diagram for it. It's more tricky than it sounds. So yeah, let's unpack. First we have the storage paths, which we address storage as paths, which is as simple as it sounds. Each path is just a directory with a bit of metadata. Both the main miner node and worker nodes can have multiple paths. For workers, that's supported since very recently, I think only in 0.57. Paths are divided into two types. There are storage paths for long-term sector storage and seeding or Squarespace mentioned before. Seeding paths for keeping temporary data for seeding operations. You can also combine and have a path that's both long-term storage and seeding. But usually for seeding storage, you want fast SSD drives, and those are very expensive. So, and seeding on a hard drive is going to be much, much lower. So you will probably want to have separate paths for those two storage types. Then we go into remote paths. So storage can be local or remote. Each node can have a different set of local paths. And when I mean node, I mean either a miner or a worker. The Lotus miner process has a built-in worker. So when I say node, I will usually mean a miner or a worker node. Yeah. So going back, sometimes sectors need to be moved between nodes. And this is when remote paths come in handy. Each local path, and by local I mean a path that a node can access locally. So it's just a local directory. Each local path in the system is exposed by its node through HTTP. And this allows nodes to transfer sectors between themselves. It's also worth noting that paths can be shared between nodes using shared file systems, such as NFS, Ceph, or any other technology that has that. And this makes it so that transfers don't have to happen over HTTP, which can be much faster with technologies like RDMA, which can be used with NFS decently easily. But yeah, that's the more exotic stuff. Yeah, next we get the worker. This is the component which gets sectors into local storage and actually runs tasks coming from higher levels of the storage FSM. Each worker will access its local storage, and it can also pull things from remote storage paths into its local storage paths. Yeah, again, the Lotus miner process embeds worker. So technically, it's not necessary to run the Lotus worker process if you only have one machine. There are still some cases where that can be a good idea, but usually you won't have to with just one machine. And now the fun part, get to scheduling. This is the logic that decides what task to run, when, and where. It's fairly complicated and still didn't receive nearly enough love from us. It's really hard because it needs to balance a lot of things. We want to support a diverse range of setups at many different scales, and we cannot just require everyone to build their data centers in the same way with the same parts. It doesn't work. So that we have to support everyone. The scheduling strategy, it has a few parts. Initially, all tasks will go into the global scheduling queue. From there, the main scheduler assigns them to so-called per worker windows. After they are assigned to a worker, the worker will process all of those tasks. The hard part is knowing which task to assign to which worker and when. It's much more complicated than it sounds. Yeah, so we use the concept of resource windows mostly to prevent resource starvation. So when you have a lot of small tasks and a few big tasks, you could be scheduling this stream of small tasks, and that would prevent the bigger tasks from ever running. We define a window to be a group of tasks which a worker can run all in parallel. So if you schedule a window worth of tasks, the worker won't ever run out of resources. Each worker has a few windows, so windows are tied to one worker. So all windows are worker specific. And if workers have different sets of resources, their windows will have effectively different sizes. This slide is a lot. So each worker has 4 windows. 2 of those are for running and preparing for running tests. The global scheduler operates in a set of open windows, and an open window is just a task. And an open window is just a window with no tasks. When at least one task is assigned to an open window, that window is no longer open, and it's sent to its worker for processing. Worker then process assigned windows sequentially, which is pretty important. And they do that by moving tasks from those assigned windows to the preparing window, and then start preparing for running the actual task. So preparing usually means just fetching the sector from other workers, just making sure it's locally available. Yeah, when the assigned window from which we pull task into the preparing window, when the assigned window is emptied, we send it back to the scheduler as a new open window to get us more tasks. When tasks in the preparing window are ready for processing, so we fetch the sector or it's already here locally, the task will get moved to the running window where it is actually executed. So this is where we actually run the bigger tasks like pre-commit 1, 2, and everything else using lots of resources for a decently long time. Yeah, when we assign tasks to windows, we guess how much resources they use based on the static resource table, which is in the Go file at the bottom of this slide. Can be tweaked fairly easily to tune some of the scheduling logic if you know what you are doing. If you don't know what you're doing, you can end up with the scheduler using either way too few resources or just crashing all your workers with way too much tasks. It doesn't care if you set it to low, it will just send everything to you, and we'll have to somehow survive that or not. Okay, so next, there will be some improvements coming soon-ish. The current project isn't perfect. We'll be working on a number of things, make it somewhat better. Yeah, we're also very, very open for any ideas. So just send them our way. If you think you know how to make this better without too much effort, we want to hear about it. Okay, next we have proving storage. The next decently big thing we have to do Filecoin as miners. Storage is proven through window post or window proof of storage, proof of spacetime. All sectors are proven every 24 hours, unless they are faulty or expired. in which case we probably can't prove them anyways. We split the 24-hour so-called proving period into 48 deadlines. Each deadline is 30 minutes. That probably came from dividing 24 hours by 48. Then in each deadline, you can have you can have 0 or more partitions worth of sectors. A partition is just an arbitrary group of sectors which you prove together in a single window post message, unless you have more than, I think, 10,000 sectors in a deadline, then you split it up more. But to get more than 10,000 sectors in one deadline, you have to be a pretty big miner. So currently it's unlikely to be an issue for anyone. And computing window post also involves computing a snark that can also use a GPU to make it faster. Deadlines. Each deadline defines a couple of important points in time. First, you have the fault cutoff, which is 35 minutes before the deadline opens, which is the latest time at which you can declare faults on recoveries. Then you have the challenge epoch, which is when the challenge randomness for the proof of spacetime becomes available. This is 10 minutes before the deadline opens. Then you enter the deadline at the deadline open epoch, and from that time you have 30 minutes to submit the window post message to the chain. If you, after 30 minutes, miss the deadline close epoch, you can't submit the post message for that deadline at that point. And when that happens, leads us nicely to faults. You have two main sector-related fault types. You have declared faults and skipped faults, skipped post faults. Declared faults may pay a smaller penalty compared to skipped post faults. So you want to declare that you are not able to prove your storage in advance. The difference is pretty big from what I remember. Sectors that are faulty for either fault type can be faulty for 14 days. And after 14 days, they will be permanently terminated unless they are recovered through the recovery mechanism. Like faults, you have to declare recoveries 35 minutes or before, 35 minutes before the deadline opens at the latest. And when you declare recovery, you claim that the sector that you declare as recovered will be proven in the next deadline in which the sector has. And after you declare that recovery and you do submit the window post for that sector, you will just recover the power for it. You won't recover the fee you had to pay for faulting on that sector, so don't just fault. It's expensive. The next pretty major thing that you do as a miner is mine blocks. This is where you actually get your block rewards and get paid for everything you do. The mining process is just a simple series of steps, all done automatically. So it starts by selecting blocks or a tip set, which you'll mine on top of. Then you check if we won. If we didn't, then we go back to the first step and just wait for the next epoch. If we did win, we start computing another type of proof called the winning post. Winning post is just a proof of space-time on a single random sector. And the thing it allows us to do is, if a miner lies about some percentage of its storage, so like they have removed, say, 50% of their sectors, but still weren't caught by the window post. With winning post, they will fail 50% of winning posts. So effectively, their power will be already reduced by 50%. So this way, you're lying about your storage. The only thing it does is it slows down the network somewhat, and to slow down the network significantly, you have to remove a huge portion of network power, which will also cost you very significant amount of funds, just because sealing sectors is very expensive. After computing winning post, we select messages based on gas premiums and some other factors such as ticket quality in a way which optimizes gas reward. And that's much more complicated than in other blockchains, because in other blockchains, you generally have one block at one height. In Filecoin, we have multiple blocks at one height and only the message. So yeah, every block can include a set of messages, and only the block with the lowest ticket to include a given message will get its gas reward, which makes optimal message selection a much more complicated topic. We already have a pretty optimal algorithm implemented there, so it should be doing a pretty good job. It can't be perfect though, because it turns out to be an NP complete problem, which is interesting. After putting messages into a block, we wait for the epoch timestamp, and we send the block to the network. And we have to wait for the epoch timestamp, because if we send the block too early, nodes which receive it too early will just reject it. Which, the mining timing. Basically, after each epoch starts, we wait about 6 seconds for blocks from that epoch to arrive from the network. This is the select mining base step from before. After the blocks have arrived, we check if we won. If we did win, we compute the winning posts, we put a snark, which has to be done quickly. Also, for winning posts, you really want a GPU, because it has to be done quickly. Like, it should be taking 10, maybe 15 seconds. If it takes longer, you need to optimize something or get better hardware. So you compute the snark, hopefully in less than 15 seconds. It can take a bit longer, but it gets pretty tight. After that, you put a block together with the messages and everything, and you wait for the epoch timestamp for the epoch to start, and then you release it to the network. So that's it for mining. Now we can either, we can either go to node setup or answer some questions. So maybe we'll do, maybe we'll go quickly for the node setup, because it may have some interesting things. Creating a miner node. You create a BLS address, you send it some funds from a faucet or in mainnet through other means. You then initialize Lotus Miner with the Lotus Miner init command, specify some flags. You usually want to set the sector size. For mainnet, it will be either 32 or 64 gigabytes. Also, something I mentioned that 64 gigabyte sectors, the only difference is that they use basically twice the resources for most cities. That can save you a lot of cost in mainnet on gas fees, and we don't know how they will look. So maybe worth supporting 64 gig sectors. Then you have the worker and owner flags, which allow you to specify the worker key, which is the free PLS address. It has to be the PLS address, and an owner key, which can be either PLS or SecP. It doesn't really matter. The difference between those two is that the worker is the address, which is used to create blocks. The owner address, in addition to not being able to mine blocks, it can do all miner related actions like the worker key, and it can also withdraw funds from the miner actor. The worker address cannot do that. Yeah, there are also some other flags in the init command, like no local storage, which just makes the miner not have any local storage. Currently, you will have to just add another storage path manually because the Lotus miner process has to have at least one local storage path. Unfortunately, this should be changing soon. And you will be able to run and answer post challenges from workers, which will be very neat because you will not have to have any storage in your local Lotus miner node. Yeah, the next step after you run the initialize command, you will have to fetch some hundreds of gigabytes of snark growth parameter files. There is fortunately no way around it currently. You just have to fetch them somehow. Though you are mining Filecoin, you probably have enough internet and other resources to do it. So next, after you initialize, you probably want to look at your config. It has some interesting fields to look at more soon. But right now, you will be mostly interested in the max seeding sectors and max seeding sectors for deals configs, which is the upper bound on how many sectors you can be seeing at any given time. An okay way to calculate what you want to set this to is to add up the size of your seeding directories. So if you have 3 workers with 2 terabyte and VMEs, you'll have 6 terabytes. And then you divide that number by 500 gigabytes. So you get 12. With that, you put that number for the max seeding sector for deals. And then you set the max seeding sectors for something a bit lower, like 6 or 8, because you don't, like you want to have some space for sectors with deals always, especially in space race where seeding deals is one of the requirements. The magnet, yeah, also gives you, yeah, like rejecting people's deals is not what you want to do. So you set the for deals number higher. Next is the wait deals delay. It's the time, it's how long your sectors will stay open waiting for deals. It's kind of related to the point below, the expected seal duration. It's just an estimate on how long you will take to seal a sector. And when you accept deals, each deal has a start epoch. When you put a deal in a sector, you have to seal that sector before the start epoch. You have a start epoch of any deal in that sector. So this means that if you set the wait deals delay for a value that's too high, you will have less time to actually seal the sector. So yeah, there's some balance between the wait deals delay and expected seal duration configs. There is the storage section, which is just used to configure the built-in worker. And then you have some fee config, which just lets you configure how much you want to pay for which kind of message. But it's if gas fees get very high, it might not be worth putting pre-commits and commits in chain. So with that, they will just wait instead of getting pushed to the chain. Yeah, next as miners, if you want to accept deals from clients, you really want to configure public addresses. There are decent docs on how to do it. So if you haven't already, you should do that. It may even increase your deal success rate. Yeah, the other thing that you may want to configure is additional control addresses, which is related to message gas fees. So you as a miner, you have to submit window posts, and missing a window post can be very expensive in some cases. So if the network fees get very high, you still have to post, but you don't necessarily want to pay high fees for pre-commit and commit messages. And the problem is that if you are sending both those message types from one key, the pre-commit and commit messages with low fees set on them can block, just because you need to put messages on chain with continuous nonces. The pre-commit and commit messages can block your post messages, or if there are too many pre-commit and commit messages, you will have to set a very, very high gas fee on the post message just to push those lower fee messages through. Instead of that, you can just use a separate control address for your post messages. So it's as simple as creating a new address, sending it some funds, and then calling Lotus Miner actor control set and that address, and that will make your miner use a separate address to send post from, which may save you for a bit of funds on gas fees. Next, attaching storage paths. Yeah, every miner and worker can have multiple storage paths. They can be attached without restarting anything, with just the storage attach command. You can also specify weight, which makes it more likely to be used. Yeah, this is just pretty simple configuration. We don't have a command to detach a storage path yet. We plan to implement it, but I don't know if that's going to happen soon or not. Yeah, everything else, there are a lot of topics that I didn't go much into that are still manipulated. Markets and data transfers could probably get another hour of talking. Yeah, there are topics like how to back up a node, node redundancy, which we don't really support yet, that we should go into. And then there's method selection and all the gas rated fun things, which could probably also use like another hour or two of talking about. Yeah, instead of that, I can get questions from people.
Awesome. Thank you very, very much, Magic. That was incredible. And I think the most comprehensive
Hey, everybody. I'm just filling in for Angie while she's taking an extended lunch break here. So just want to thank everybody who's been tuning in. If you have any questions for us, please leave them down in the chat below. But our plan is to start back up in about 45 minutes here with our next talk. We're going to throw up a little screen share for you. And if anybody has any questions or concerns, definitely drop them in the chat. We're still here watching and following along. But the rest of you guys, if you want to go ahead and grab a lunch and a break, we will see you in about 45 minutes. Thank you.
Hello, everybody. Welcome back. Hope you had a nice break. I hope you got some time to go and hang out with everyone else in the lounge or maybe in the Slack channel and answer some questions. I know that I had a lot of questions following the earlier sessions, so I hope you got a bit of time to relax, get to know everybody. Maybe you proposed a session for later on. If you want to do that, all you have to do is go to liftoff.filecoin.io and submit a session. Maybe you've got an awesome demo. Maybe you want to share a bit more about your architecture. Maybe you're building something really cool in the Filecoin network. We want to hear about it, so please make sure you go and submit a session. Okay, on to our next session. So we're going to be talking about mining hardware and architecture. We actually did a couple of sessions on this during Space Race, and it was a really popular subject. One of the things that we don't talk about enough in crypto mining is kind of like what people's different setups are. So it's really great to kind of have an open source approach to this and share that information and help other people get started. So I'm really happy today to have two folks who represent two different kind of sizes of miner, if you like. The larger kind of more industrial scale mining operation, and then the solo miner. So up first, we have Neo G. Hi, Neo.
Hi, how are you, Angie?
I'm great. It's good to see you again.
Good to see you again. Thank you.
Awesome. And Neo is the founder, co-founder of IPFS Main, a leading service provider that's committed to comprehensive Filecoin mining solutions in a cost-effective way. Before devoting his work to IPFS Main, Neo served as a founder and CEO of Mining Host, focused on the Bitcoin, Ethereum mining on a medium scale. Neo is also a Web3 enthusiast and a professional photographer. And I'm really happy that you're here today again with us, Neo, to share your wisdom.
Thank you so much, Angie.
Cool.
Hey everyone. Okay, I'll take it away. Hey everyone, my name is Neo G. I co-founded IPFS Main back in 2018, and we are the service provider inside of the Filecoin ecosystem. We've been committed to the Filecoin project for almost 3 years now, and it was a historical moment for the Filecoin mainnet launch last week, and I'm really happy to present today. The talk today will be very similar to the miner show and tell I gave last month. I'm going to go through our Filecoin mining solutions, which includes mining architecture and network topology. Then I'm going to talk about our hardware information as well. Let's get started. Over the past 2 years, we have had multiple architecture designs for large-scale Filecoin mining. After thousands of hours of testing, we've decided to use this Filecoin mining architecture. As you can see, when we talk about the architecture, we don't mean the macro architecture. We believe Filecoin mining architecture is the design of a communications network. It includes the physical and logical layout of the network. It also includes the framework of specifications of equipment, services, protocols, and functions of Filecoin mining. In this current mining solution, we are dividing major hardware into 3 different pieces: the storage rigs, seeding rigs, and snarks rigs. And by separating the storage and computational part, this architecture gives us really good scalability and improves the hardware utilization efficiency on a tremendous scale. In this design, we want storage rigs to complete the first step of POST, generate candidates on their own. At the same time, we use seeding rig cluster for seal pre-commit phase 1, aka PC1, PC2, and C1, and snark rig cluster for C2 and window POST. We modify and rewrote part of the code and made some redundancy changes to improve the POST success rate. By doing all that with this mining architecture, we've significantly improved the mining efficiency, especially for P1 and C2. For example, we could manage to finish C2 under 10 minutes at the start of Space Race 1, and we've done some other further improvements recently as well. We believe a robust network architecture should facilitate system-level functionality as well as robustness and scalability, especially in the face of changes in software and hardware components, application functions, and so on. In our network topology, we are using 2 different internet service providers for each WAN to increase the redundancy. The communication core switch uses multi-switches with 10 gig optical ports for stacking, which is connected to Lotus Node and Lotus Miner. And the data core switch uses dual switches with 10 gig optical ports for stacking, which is connected to the Lotus Miner storage, Seal Worker, and Snark cluster. And the space access switch have 4 10 gig optical ports plus 24 gig electrical ports, dual switch stacking, of course. The 10 gig optical ports are connected to data aggregation switches, and the gig electrical ports are connected to storage, and each storage is connected with 2 network cables respectively to the 2 switches. And we did the dual network port binding to improve the storage network stability as well. When you are mining Filecoin at large scale, especially like something over hundreds of petabytes, and a well-built operation and maintenance platform is a must to keep everything in order. So next, I would like to highlight our one-stop O&M platform called File Manager here as part of our Filecoin mining solution. The File Manager includes CMDB, CI/CD, monitoring system, and work order system. I'm going to break it down into details with screenshots for each system. The Configuration Management Database, aka CMDB, is an ITIL database used to store information about hardware and software assets. It is useful to break down configuration items into logical layers. And CMDB helps us understand the relationship between the components of our Filecoin mining system and to track their configurations. It can also be used for things like impact analysis, root cause analysis, and change management. So in the File Manager, we use it to help us automatically discover the host, get the host hardware information, identify host failures, and identify which cluster that host is working for in real time. And CI/CD means continuous integration, continuous delivery. It bridges the gaps between development and operation activities and teams by enforcing automation in building, testing, and deployment of applications. Our CI/CD module can help us perform fast and accurate deployment whenever there's an update in the Filecoin network. The component monitoring system provides comprehensive monitoring of the health status of the components like Lotus, Miner, Seal, Storage, Snark, Windows POST. Like this one, Lotus Monitor helps us node synchronization and monitoring the mempool as well, in case our message is being stuck in the mempool. And the Miner Monitor helps us on order status, miner status, order management, like practicing different pricing strategy and sector lifecycle tracking. The Seal Monitor focuses on the working status of Seal workers, like what is the sector ID and what stage that sector is currently in. It is able to identify various errors that occur during the sealing process and deal with faults automatically. It will stop receiving new tasks until the fault is repaired. The Storage Monitor helps us on the sector storage status. It will find storage failures actively and perform data migration in real time and make the migration history traceable. Snark Monitor focuses on the working status of Snark and the resource demand of it. Windows POST Monitor is responsible for Windows POST working status and history of all miners. And these monitors, as mentioned, are all part of the component monitoring system. After that, we have the host monitoring interface. all the monitoring system can work together to identify and classify faults in hardware, services, and networks, and notify the corresponding staff to deal with them in time. The work order system manages the workflow and can track various operations and maintenance events. All faults identified through the monitoring system can automatically generate work orders and dispatch them to the corresponding person in charge. This is our exception handling system. The system catches all the exceptions through logs and notified O&M personnel to deal with it. If there are any advanced exceptions like synchronization exception, window POS exception, the system will call the corresponding O&M personnel through the phone interface and ask them to deal with the exception. Hardware information. Just like I presented in the miner show and tell, I believe designing a good Filecoin mining solution is like building a wooden bucket. No matter how high a bucket is, the capacity of the bucket depends on the shortest plant. And Filecoin mining is different. It's different than any other computational crypto mining like Bitcoin or Ethereum. Filecoin mining is complex, especially when you are mining at a meaningful scale. If you are seeding too fast, for example, or too slow, so that other components have to wait and stay idle, then you are probably wasting the hardware performance. So the key is to find a balance with cost-effective hardware. It's so obvious that cost efficiency is another metric of Filecoin mining solution. And as a Filecoin miner, you just need to find the right hardware instead of the best ones. I made an analogy last month. It's like running an Uber using Lamborghini versus a Honda Civic. The hardware requirements for Filecoin mining are highly related to the computational resources needed to seal a sector and generating regular proof of space-time for every sealed sector. And these operations are computational expensive. And things like algorithm implementation, sector size would affect the hardware requirements. So let's focus on the current mainnet with 32 gig sector. First, as a storage miner, you will need a CPU with at least 8 cores. Also, the CPU has to support the Intel SHA extension. If you are choosing AMD CPUs, you will need at least a Zen macro architecture or later. And if you're choosing Intel CPUs, you will need, I believe it's Ice Lake processor or later. Secondly, you would need at least 128 gig of RAM. And as indicated in the Filecoin docs, this should be complemented with a 256 gigabyte of swap on a fast NVMe SSD storage medium. And a powerful GPU could significantly speed up the SNARK computations. The Filecoin team has provided a list of supported GPUs, but if you want to choose to use other GPUs, you can definitely do that, but you have to manually enable them. And remember, please don't mix the AMD GPUs and NVIDIA GPUs together, as it will cause issues with OpenCL. And the disk selection is really important as well. The Filecoin network parameters are over 100 gigabyte and needs to be read and verified during miner start. So you will need at least 1 terabyte of NVMe-based disk space for cache storage. And this disk will be used to store the data during the seeding process to cache Filecoin parameter and to serve as general temporal storage location. And on top of that, you will need additional hard drives for the final stage final storage of sealed sectors and Lotus chain and etc. Please note that the above spec I was talking about are general requirements, assuming all the mining operations are running by the same machine, which is different than our mining solution and requirements showing in the current slide. And like I mentioned earlier, we've managed to separate everything into 3 different parts. Another thing I'd like to highlight is that we are ready for the algorithm upgrade from SDR to NSC. And that's actually one of the reasons why we chose current architecture and hardware designs. They're built for algorithm upgrade. And I believe to make Filecoin a successful project, we need to move most of the parties in the Filecoin ecosystem closer to users. The current storage service provider could only go down to the IDC level. And I believe one of the most important milestone of Filecoin project would be the time that we lower the hardware requirements to a level where everyone could mine at any scale. And as a storage miner, we want that milestone to come sooner than later. It may sound crazy when I say this because we are one of the largest Filecoin miner in the world. Reducing the hardware requirements would lead to more miners and then increase the cost per Filecoin we mine. But the key is to treat Filecoin mining as a long-term thing. To be a successful miner of Filecoin, the Filecoin network needs to be a successful network first. And that's why we are supportive even to most of the miner unfriendly parameters in the Filecoin crypto economic model. It's super exciting to imagine the future of distributed web. I believe Filecoin would become a big part of it, where we could, where we will see lots of storage miners, retrieval miners, and repair miners. Hardware requirements won't be a barrier anymore. With repair miners' help, people could probably mine Filecoin on whatever hardware they desire and whenever they want with flexible time framing instead of 24/7. People could easily transfer petabytes of data with extremely cheap bandwidth. I think this is the end of my talk. Thank you so much for watching. I think I'm 2 minutes over the time. Sorry about that. Next, I think I'm gonna turn it over to the next speaker from Storage Hive.
Awesome.
Angie.
Thank you so much, Neo. That was brilliant and super interesting. It's really, really great. And I think just getting your perspective to put into context as well, Neo, you did very well in Space Race, didn't you?
I think we did really well.
Yeah, you did really, really well. And you're going to be in the winners panel later. So it's great to see how you're kind of thinking about mining long term, how the team and the architecture has kind of evolved over time, how you're kind of looking to the future and how to adapt, and obviously engaging with the community as well, which is really, really important. That's awesome. Thank you so much for sharing again with us today. I'm looking forward to chairing your panel later on this afternoon.
Sure, no problem.
Awesome. Thanks so much, Neo.
Thank you.
Up next, we have Jacques Swampole from Storage Hive. Jacques is the Chief Technology Officer with 26 years experience in a wide range of solutions and managing cloud environments across multiple data centers. He's got in-depth knowledge of storage systems, including distributed systems. He started his IT career in software development on platforms such as Windows, Linux, yay, and IBM. A very warm welcome to you, Jacques. Great to see you.
Hi, Angie. Thank you very much. It's good to be here again.
Awesome. Well, welcome back. And I will hand it over to you for your presentation.
Sure. Okay, I'll share my screen. Okay, my screen should be up now. So my talk's going to be, I think I was in Show and Tell Space Race 4. It's going to be a similar kind of information I'm going to cover, but definitely quite a different approach to what Neo just talked about. So on my side, I kind of looked at, as a small miner, solo miner, I do actually have 2 other people in my company as well that's helping out. So we're not quite solo, but certainly on the small side for now. You are quite keen and interested on the Filecoin platform. I want to understand the economics of the platform and how we can scale it up. So really kind of focused on how to build the platform as cost effective as possible, and at the same time maintain reliability. So kind of a lot of people talk that what are they doing and what worked. I actually want to step back a little bit and kind of, as my wording says there, you can kind of learn from my mistakes, scratched out experimentation. So that's kind of thing really key for a lot of people that might be new. I know the project's been around for 3 years, but now, of course, as it's going to get more popular, mainnet has launched. See a lot of the crypto news sites are talking about it. So more and more people are going to come into the platform and want to participate. So hopefully some of the information I will share will help people speed up their process of getting into the platform. It certainly needs to be reiterated for this is not like Bitcoin or Ethereum. You don't just buy a system, plug it into the network, and it's up and running. It's a complex platform. There are software involved, there's hardware, storage, networking, internet. All those things have to work really well together to just work in the first place. And then once you kind of get to that level, then the next level is to be able to actually do it cost effectively. So it's not for the faint of heart to get into this. However, if you do is successful, it's really kind of exciting once you get to that point. So let me kind of jump into it. So what I try to focus on is not on the high end, but kind of on the more on the single person, small end miner. What's kind of like the bare minimum requirement that you, at least for now, I know the systems are changing, things are being optimized. As New also mentioned, he's highly recommending that requirements do come down. But at the moment, the requirements are what it is. So as of today, October 20th, 2020, this is kind of like the minimum requirements that you need to get a miner up and running. There are like 3 major steps to the sealing process. There's pre-commit 1, pre-commit 2. Commit 1 is there, but it runs so fast you don't really notice it. Nobody talks about it. And then commit 2. So it's really kind of the 3 major steps are pre-commit 1, pre-commit 2, and commit 2. And so on pre-commit 1, this step for now, and I know there are actually some changes that it's being worked on. It's in test at the moment that will allow to use multiple cores. So that's will be coming down the line pretty soon. But as of right now, it's still at this point in time heavily based on just CPU and no GPU at the moment for PC1 work. And so kind of on the bad side, yeah, like I said, you need an Ice Lake or newer Intel CPU if you want to go that route. But yeah, in general, most Intel CPUs don't really work well, especially on the lower end systems. So I highly recommend that you have an AMD-based CPU, especially Ryzen 3s or Ryzen 5s are really cost effective at the moment to run those, as the multi-threaded option of PC1 is going to become available. Then the Ryzen 7s and Ryzen 9s will probably become more popular for PC1, but for right now, Ryzen 3 and 5 is like really cost effective to get your PC1 rig up and running. On the chipset side, what I found is not like you have to kind of be careful on the bottom end machines. A lot of them will only support like 32 gigabytes, sometimes only 64 gigabytes. If you do get a motherboard with, there are 2 chipsets. I know the B55 is one, and I think the 450 as well. But the B50 definitely does support 128 gigabytes on the motherboard, because you need at least 64 gigs available for every PC1 process that you want to run. So with having 128 gigabytes available, you will be able to run at least 2 PC1 processes on that one system. Swap space, from what I've learned, is you do actually need a little bit more than what the official documentation says. I've noticed the way the software does the calculation for what's available. There's overhead with other processes and things that's already running on the machine, and you need to make sure that you have space for that. Plus, then for Filecoin to run. So swap space wise, you do want to make sure you have 160 gigabytes available swap space. Again, it should be on NVMe storage to make sure it can swap really fast. The space, yeah, this is the part where it's doing all the work, and you certainly want to be on SSDs or NVMe for the work that's being done, and kind of, you know, depending on how you're doing your deals and, you know, different steps coming in. I know one process from a 32 gigabyte sector, it will actually grow to about 500 gigabytes of workspace as it's doing its sealing process. And yeah, so you need probably like bare minimum 1 terabyte. 2 terabyte is certainly more comfortable. But I even seen on some workers, I use 4 terabytes because depending on, you know, if there are, you know, some tasks that are waiting for deals, or it's kind of waiting for a process, or it has to get transferred to another worker as all this waiting has happened, it's good if you have extra space so that the system in the meantime can still actually start sealing additional sectors. Networking, I initially started with 1 gig. Don't recommend it. I mean, those 500 gigabyte workspace, when a PC1 gets transferred to a PC2 worker, it's 500 gigabytes that needs to be moved around on the network. And that could take like almost an hour and a half on a 1 gig link. So you certainly want to look at 10 gig. And now, guys, I mean, the prices have come down quite a bit on 10 gig. So it is becoming reasonably affordable. And if you only have a main miner and a few workers, you can probably even just directly cable them. You don't necessarily have to worry about having a switch. Just got to, you know, figure out your routing and stuff so that all the machines can reach each other. And yeah, and on the PC1, there's at the moment no GPU needed. So that's kind of like the PC1 process as kind of the bad side and good side that you want to use. Then PC2 and C2, in my environment, I actually run them on the same set of hardware because at the moment they do kind of need similar requirements. Both processes do need more threads and reasonable moderate amount of memory and GPU. That's kind of the main driver difference between having different set of hardware for PC1 and different hardware for PC2 and C2. So again, on the bad side, yeah, you don't want to use any CPU that's older than 5 years. Memory, you got to be over 128 gigabytes or more. Disk, yeah, if you, again, in general, anything while you're sealing data, spinning hard drives, especially if it's just a single hard drive, is not going to get you far very fast. It has to be on SSDs. Maybe one comment also on SSDs and NVMEs. You got to be careful with like really low-end consumer level SSDs, NVMEs. On one of my workers, I did kind of go really low end, and like shortly after the space race, that node did actually die because the NVMe like literally got burnt out because it can only take so many writes during its lifespan. So yeah, you do need SSDs, and you are going to need you know, higher level, like enterprise level SSDs that can maintain and handle quite a lot of writes and rewrites on the disk. GPU wise as well, you want to make sure if you are going to go a little bit lower end GPU, it should have at least 6 gigabytes or more memory per processor on the GPU card, because the Filecoin process allocates around 4.5. Don't know why it's 4.5, weird number, but it does allocate like 4.5 gigabytes of memory on the screen card. So do get a card with at least 6 gigabytes allocated on it. Actually, but I've seen sometimes you do get some errors on it sometimes still in the allocation. So it is still better to have like a 1080i or something that has at least, I think it has 10 gigabytes of memory on that card. So that's kind of like the sweet spot on the, you know, entry level card would be the 1080i. In general, on the awesome side, you do need more threads to do the work of PC2 and C2. So a Ryzen 5 or 7 or 9s work really well for these in general. Again, swap space, it's got to be a little bit higher than the memory that you have on the system. Then yeah, lastly, so on the post, just kind of for people starting out scratch, I've seen like over and over and over on the message boards, this is kind of like the main thing that they trip over once they got, you know, the PC1 and PC2 working. That's not too hard to kind of get accomplished, but probably the most difficult thing is to get your the window posts to complete successfully in a time frame. And there is it's these Lotus Miner proving deadlines command that you run. It has 38 48 sections. So it's basically a 24-hour window, 30-minute sections, where every 30 minutes it does prove some of the work that's already been sealed. And the challenge that it sends, you need to be able to do all the work, retrieve the data, do the hash calculation, and send the results, put it on the message pool, and send it back to the chain. And all of that needs to happen in 30 minutes. And if you don't have adequate hardware, that's why you're going to have, so when you see faulty sectors or you lost all your power on the network, it's usually because your posts are just not completing in time. I initially did start with a Ryzen 5 as my main kind of system doing the post, and it was just not fast enough. I did upgrade to the AMD Threadripper, which works really awesome. But I would say now that I've learned a little bit more, it's probably overkill. So you can probably get away with, if you have a dedicated machine for the post, a Ryzen 9 should do the job as well. And again, a good GPU, so at least a 1080i or better, and the memory and the space requirements, that should certainly be able to get you through your post. And just a kind of quick reference, I mean, this is kind of how I monitor my environment. Got a whole bunch of party stations up and running, and seeing what all the systems are doing. It's quite feeling good to see that everything is actually working and sealing some data. And that's it from me.
Amazing. Thank you so much, Jacques. That was really awesome. And yeah, again, just to hear your whole experience kind of coming all the way through Space Race and then through to mainnet. So yeah, congratulations. I'm sure this is a very exciting moment for you as well to get to mainnet. And thank you so much again for sharing your wisdom with everyone. If you would be so kind, I'm sure people will have questions. I know there's a couple in the Q&A. But if you and Neil were willing to pop into Slack afterwards, and if folks can just message you, that's a lot of really like interesting information. So yeah, I think it would be great if you chaps were willing to just pop into Slack, and if people have questions, you can pop over there. Maybe you want some more details on the architecture or hardware, and yeah, Neil and Jack can help you out. All right, thank you so much again, both. It's been really great to hang out, and looking forward to hearing from you both again very soon, I hope.
No, thank you very much, Angie. And yes, I'll certainly be on Slack. I'm usually on there always.
Me too. Okay, brilliant. We are going to take a very short break, and then we're going to move on to a session on Filecoin storage economy with ZX, where he's going to discuss the mechanisms and models presented in the recent Engineering Filecoins Economy report. It's not one to be missed, so please join us back here shortly, and we'll see you soon.
Alrighty. Hello, everyone. I hope I can be heard well. My name is Ayush. It's nice to see everyone, and I'm very excited to be around for these next few sessions as part of Filecoin Launch Week, Liftoff Week. Sorry. Thank you, everyone, for joining. This has been an incredible week so far, and we have so much more content coming up. It's a very exciting time for all of us. Getting right to it, our next presenter is ZX, who leads the crypto econ efforts here at Protocol Labs and on the Filecoin team. He's going to be talking about all of the decisions that were made and things that were considered when designing Filecoin storage economy. The one thing I will say is that an incredible amount of thought was put into this because it's a really complicated problem to solve. And I think it's going to be really interesting to hear what he has to say and to see the stuff that went into the recent Filecoin economy report. So over to you, ZX. Thank you.
Thank you, Ayush. Can you guys hear me?
Yeah, we hear you well.
Great, thank you. Let me just share my screen. Just 1 second. Great, let's see. So hi everyone, my name is ZX and I work on Filecoin crypto economics. And today, welcome to Filecoin Liftoff Week. Today I'm very excited to share with you about the storage economy of Filecoin and what mining Filecoin means and how can you have the maximum impact in this economy. To start, let's just start from what is crypto economics. So crypto economics is referring to an emerging field and study of designing economic games in a cryptographically enforced peer-to-peer network. That's why you have the crypto and also the economic. So the crypto part is basically setting like rules and like setting like so-called invariants and or physics inside the system. And the economic part is basically steering the system towards the direction that the system wants to go. Like an analogy that we often make with Filecoin as a software rocket, the crypto economic is basically steering where the rocket is heading. Next, using a diagram from a paper with our collaborator at Block Science. So it really is an interdisciplinary field with the computer science cryptography in the underlying layer of like how the ledger get updated and how engineering science, economics and game theory, where a lot of thought is being put in from this discipline to understand how do we build this economic layer on top of the blockchain layer such that the system collectively can achieve a goal. Well, if the system has no goal or it's a very simple goal, like this job could be pretty simple. But like the moment when you have different stakeholder groups and you have long, short, and this complexity of this decision space just blow out very quickly. And once we develop the blockchain layer and the economic layer, there's also aspects of ethics, philosophy, and political science and governance that sit on top of these layers as well. But it really is an interesting field, and I'm very excited to share more of our work with you guys today. And another lens to look at this could be like we have the crypto network, which is the software layer where consensus is reached and so on. And we have agents basically making decisions and taking actions given the action space that the protocol allows them to take based on their private information and their observation of the system state. And then there's also algorithmic policies, which is designed and agreed upon by the community that would perform state update based on this network state and steer the network towards a certain direction. And as this iterates and evolves over time, like human agents would participate in the governance. And through the governance, it will basically update both the policy and also update how the underlying software layer will work. And so, a very distinct thing about Filecoin is it's a blockchain network of useful work. So to do, and there's also a common mission and goal where that brings all these participants together to try to make this mission a reality. And the mission is to create a decentralized, efficient, and robust foundation for humanity's information. And on the crypto economic side, how do we make that mission come a rational choice and be incentive aligned for all the participants in the network? And this mission will take time. It would not be achieved within a day or within a few months. It may take many years to come. And how do we create this sustainable incentive and all this economic structure such that it's in the interest of all network participants to try to achieve this goal? And today is Mine Day. I think I'm very excited I think we are at the onset of something much greater. I think we are ushering in this new era of mining where blockchain is made useful. Blockchain can empower businesses, and all the participants can evolve together with the network. And I will explain more in detail. So first of all, let's just give an overview of what are the stakeholder groups within the Filecoin economy. So we have the storage clients, which would be storing and then we have storage miners, which who are providing miners, which include storage miner, retrieval miners, other kinds of mining. And miners are providing storage services on the Filecoin network, while also maintaining the underlying blockchain layer of consensus. And then we have developer building product and experiences on the Filecoin network to make storage-related goods and services more attractive to the storage clients. Together, developers and miners working together try to bring in more clients into the network. And then we also have token holders who provide liquidity and capital investments for miners and developers, and also for clients. And then there are also ecosystem partners like the Filecoin Foundation, Consensus, Block Science, Protocol Labs, and many others who are basically helping to grow and expand the ecosystem. An analogy that I would like to use is an island economy. This is where all these stakeholder groups come together to work towards a common goal. And Filecoin is basically like the native currency to this island. So researchers develop algorithms and make it more efficient and make the network more robust. Developers improve the user experience, build products on the platform, and token holders provide liquidity and capital for collateral and so on. And miners will amass all these resources and turn them into storage-related goods and services in collaboration with all the other stakeholders. And then clients can exchange these goods and services with Filecoin. And the goal of the economy should be try to turn this production cycle from raw storage materials into storage-related goods and services as efficient, as productive as possible. And the more attractive and more competitive these storage goods and services, there will be more potential clients and participants want to join the economy and want to do trades with the island. And the more attractive this is, the greater the demand of storage goods and services on Filecoin, the greater the demand would be for the native currency, which people would need to perform any exchanges with the participant in the network. And so the overall goal for all should be, how can we be more efficient in converting raw materials into storage-related goods and services, and how do we make it more attractive such that we can attract more potential clients and participants? And I mentioned just now, we're ushering in a new era of mining. And I think and many of us came from a Bitcoin mining kind of world, where both Bitcoin and Filecoin are decentralized blockchain networks, but I think there are quite a few differences in terms of mining. So first of all, I think in Bitcoin, people mine with specialized hardware, where Filecoin mining is on general purpose hardware with high resale value. Some of these differences in the paradigm and philosophy will lead to differences in the design. And because of Filecoin mining only requires general purpose hardware with high resale value, just hardware itself alone may not be enough to provide enough security to the network, and that's why we have some collateral requirements. For Bitcoin mining, most of that is wasteful work, and whereas for Filecoin mining, we want the work is useful to somebody. And because for the whole Bitcoin mining, because it's very hard to reason about the valuation basis of the network. So a lot of the value is speculation driven, where Filecoin mining is utility driven. The network utility is something that can be approximated and observed. And because of that, Bitcoin mining may tend to be a bit more short term, where miner mine tokens, and then they can most of the time they will just sell it. Versus in Filecoin mining, miners are incentivized explicitly to be long term and reinvest into the network. And because of some of that, sometimes Bitcoin mining can be a bit more exploitative and zero sum, versus in Filecoin, because we're building an economy, it's bigger than just agree on a ledger. It requires us to collaborate. It requires to develop win-win situation for all stakeholders in the network. And while we compare that with Bitcoin, I think it's useful to also compare Filecoin mining or operating Filecoin storage with being an Airbnb host. Both Filecoin and Airbnb are similar in the sense that these are both global platform economies, but there are also some differences as well. So like in Airbnb, hosts contribute housing resources, whereas on Filecoin, the miner or storage operator contributes storage resources. And Airbnb mining is labor in, once of course you need to get a house, but after that it becomes very labor intensive. Whereas on Filecoin mining, it's more it's more knowledge and experience intensive. And an Airbnb host is at best a contractor to the network, whereas in Filecoin mining, when you are a miner, you are an owner to the network, and there's a big difference. Sorry, there's some question. And what's this Airbnb host? Hosting Airbnb is managed by a company, whereas mining on Filecoin is governed by a decentralized ecosystem. But there are also some similarity as well, like both Airbnb and hosting and Filecoin mining share the same brand identity. And this is very important especially for Filecoin, because like in terms of dispute on Airbnb, there's always this legal recourse. But what we can rely on in a decentralized network is actually the crypto economic mechanism on Filecoin. And both Airbnb hosts and Filecoin miners are incentivized to create differentiated services to attract a diversity of client and a diversity of and to satisfy a diversity of needs. With that, I think I'll just on the crypto economic here, like we want to find patents incentives with the mission of the goal, with the mission of the network. This is done through rewarding reliable and useful storage. And we also need, as we saw earlier, there are like 5 different stakeholder groups in Filecoin. So you need to balance the short, medium, and long-term interests of all stakeholder group, present and future, and the utility of the network. And the goal is that Filecoin mining is profitable in the long run with little or no subsidy, and that's how we can create a sustainable economy. So to briefly explain some of the construction and mechanism within Filecoin, I would just highlight a few key areas on a high level and some of the innovation that and some of the thought and innovation that we did there. So first of all, on block reward, we introduced a concept called hybrid minting. So in most traditional proof of work mining, people follow a simple exponential decay minting model, but that minting model has a couple of problems. One of the dominant one is that it creates a very short participants to over-invest in the early days of the network when the network is least mature and the participation is at its lowest. And what that means is that the minting of the network is not proportional to the utility of the network. And therefore, on Filecoin, we create this notion called baseline, and we introduce a concept called baseline minting, whereby we define network time as we define a notion of baseline, which is a KPI that the network needs to achieve, and then we define a notion of network time as a measure of the network's progress in achieving that KPI. And the net result here is that compared to a simple exponential decay model, where the input to the reward is just times, and it's exponentially decaying, which it tells us pretty rapidly, the incentive structure now is rewarding more proportionally to the storage and utility that the miner provides than simply just time. However, we do the hybrid model, which is we do both simple minting and baseline minting. The portion of simple minting is to provide counter forces to shocks in the event that it happens. And the next part here is on collateral and penalty. So as I mentioned earlier, the key thing here is the incentive should go to reliable and useful storage. So when a miner onboards sector to the network, they need to put up some initial pledge collateral. And that provides storage security and consensus security to the network. And this is set based on how much a sector is expected to earn in Filecoin. So that would basically make the reasoning about whether onboarding a sector is rational a lot easier. And the initial pledge is returned when the sector promise and to incentivize reliable storage. And some slackness in the penalty was also introduced as part of the Filecoin improvement protocol to reduce the risk of penalty for reliable storage. And the third aspect is we put power back into the storage clients. So I think people might have heard this concept called verified clients, or we might be calling that Filecoin Plus clients. There will be a talk on it, I think, on during store day. So basically, sectors containing verified client Filecoin Plus clients deals will earn 10 times the storage power and hence 10 times the reward. This is putting power back in the hands of storage clients, and storage clients can now become active participants of the network to shape storage product and services on Filecoin. And the net result is that Filecoin is made more useful and more decentralized than a purely resource-driven network. And decentralization can happen over many different axes, including like token production, geographic distribution, and we balance the power of different stakeholders within the Filecoin network. So these are the three highlights of crypto economic structure that we introduced in Filecoin that would make Filecoin more useful and more decentralized as a network of useful work. And lastly, I want to just highlight the different stages of the economy. So we talked about just now for the reward structure, it's more tied towards the utility of the network through baseline, right? Like as the network progress, and achieve and achieve a higher KPI level in terms of baseline, we unlock greater rewards through baseline minting. So right now we're just at stage 1, where the sources of revenue mostly come from simple exponential decay. There's some coming from baseline minting, but because baseline is set in such a way that like it takes time to go up to the baseline. So right now the baseline minting is slightly muffled. We have some basic quality of service requirements that is enforced by the collateral and penalty structure. And we're building capacity. There are lots of product and lots of applications being developed right now. The proof is secure, and there is some basic level of retrieval. And this gives the community time to develop and evolve the economy. And we may enter stage 2, where the chain is made a lot more scalable. Operational cost of mining becomes lower as time goes on. Hardware becomes cheaper. Algorithm becomes more performant. Proof becomes more efficient. Retrieval also becomes more efficient. And as time goes on, simple minting will start to decay. And this is also when the network can achieve a greater level of the baseline, which is a function of like how much space time has been committed on the network. And the baseline minting will pick up. And the token minting to match the increase in the network utility has improved. We start to see some like client paying. We start to see clients paying for storage deals, and then we enter stage 3. We now have strong brand reputation, a full suite of product, diverse market, CDN level retrieval, and simple minting by this time is like coming down. And then we still have some baseline minting, but the quality of service on Filecoin is so great that that clients are willing to pay for the storage deals. And that's when we said earlier that the vision is that mining on Filecoin becomes profitable in the long run with little or no subsidy. And I'm very excited. This is just the beginning. And I think for the next couple of days, we're going to talk more about like what to be built on Filecoin and what to store on Filecoin. And I think we are at this very exciting moment of the industry. And I think like let's go out together to make blockchain useful, to make Web3 mainstream, and together we'll make some history. Well, now I think I see some question in the chat box. Should I just do we have time? I can answer some questions. Right. So the first question I saw here is, let me see Q&A, if there's more on Q&A. One sec. Great. I'll just answer a question from the chat room. So there's some just question about how is storage price on Filecoin in Filecoin. Also, what's the current price for storage on Filecoin, and how does it compare to AWS and other cloud services? Right. So this depends, but when the deal hits the network, hits the protocol, it will be priced in Filecoin. But when the client enter into the deal with the miner, the clients can price that in terms of dollar or any currency of their choice, which is decided by the market. And an example of this would be like, I'm a client, I want to use storage on Filecoin. So right now, let's say I found a miner, we agree on a deal, and let's say that's based on some fiat currency. And then I say, okay, so now I want to enter into this deal. So then I purchase Filecoin from the market and then enter into this deal. And by that time, the client's exposure to Filecoin has ended. And the volatility risk it's being bear by the miners. And there are other services and that can be developed on top of Filecoin to make the cost of volatility cheaper over time. And exactly, and there are also amazing things that we can do here because everything is on chain. So somebody mentioned that like community can create a website that compares storage metrics, and that's something that I think would happen very soon and indeed now. And it's not just for clients, but also it's not just for client looking at which miner is more reliable, but also for, let's say, all miners have lending needs for collateral needs for adding sectors. So like for token holders, having such a website and statistics would be also very useful to understand which miners are more reliable, and then they can do risk management on their loans. And I can't seem to open Q&A. Shall I just do stop share and see if I can open it? Right, so right, so there are two questions. So will the retrieval market prices charged to clients be visible? Let me see, visible on chain or to other miners? So like so this is a very good question because there are deals, but we can only observe the deals as they land onto the chain. So the short answer is yes, we can observe that, but there's also some part of that that is unobservable. But that can be modeled and understand and based on other feature parameter to understand what is that demand that is unmet, or there is demand but somehow it takes a long time to be fulfilled, or there's some other deals where like the real information was not disclosed to the chain, and that is also fine. But what we can observe is like once the deal lands on the chain, that is observable, and then we can compare with the Filecoin price at the moment in time to back out what is the fiat that people paid. But it's also unclear whether people denominate in one currency or the other. Another question is how are miners and other participants incentivized to put the long-term interest of the network first? And this is done through staking, vesting, and anything else. This is done through a few ways. So like for miners to onboard storage, and that's basically a vote of confidence in the network. And similarly, for all the block reward that miners, most of the block reward that miners earn, a majority of that will be vesting over 6 months to incentivize reliable storage, which also slows down the change frequency, and you also incentivize participants to think about the longer term interest of the network. Cool. I hope I answer your questions. Anything else?
Cool. I think that's it. If folks have follow-up questions for ZX, he's always available in the Filecoin Slack, and we always love to hear from you. But thank you very much, ZX. That was very informative, and I hope miners in particular, you had some of your questions about crypto econ answered by that talk. And I'll encourage everyone to read the report. It's very detailed and very well written. Thank you, ZX.
Thank you.
Cool. We'll take about a 15-minute break now before we move on to our next session, which will be about the various other implementations of Filecoin besides Lotus. We're going to be hearing from the people who are working on them, so it'll be a good one. Alrighty, welcome back, everyone. I don't know about you folks, but I'm very excited for this next presentation. I think by this point it's well established that having multiple implementations of the same protocol is really key to the security of any blockchain network. And so those of us who've been helping build Filecoin have always had that as a high priority. Although we launched mainnet with Lotus as the kind of reference implementation of Filecoin, a lot of work has been happening from various teams to ensure that we'll have other interoperable implementations live on the network very soon. And today we're going to hear from some of the teams who are building those other implementations. So they're kind of going to be describing the projects that they work on, what the focus of the implementations are, and where they are in their roadmap. So I'm very excited. So we'll get right into it. First off, we're going to hear from the folks behind Fuhon. Fuhon is being built by the Soromitsu team, and we're going to be hearing from Dr. Alice Zivkovic, I hope I pronounced that right, who's the CTO at Soromitsu. So I'll hand it over to you. Excited. Alice, if you're ready to start your presentation, that'd be good. We can't hear you. Cool.
Hello, everyone. My name is Ali Zivkovic. I'm a CTO at Soromitsu. I'm replacing Makoto Takemiya. He's a CEO at Soromitsu. Unfortunately, he was not able to join at the very last minute. I will be describing project Fuhon, which is a C++ implementation of the protocol. So before we start, maybe just, okay, having some problems with changing the slides. A few things about Soromitsu. Soromitsu is a Japanese company. We initially developed Hyperledger, blockchain platform Iroha that is now known under the Hyperledger Iroha. We are still the main contributors to that. Then we also developed the first CBDC solution for National Bank in Cambodia that is also in production, and build a platform, Ledger, that supports digital assets. And recently we are also working, obviously, for the Filecoin, also for Polkadot, and building a decentralized exchange and a wallet that's named Fearless. Regarding the Fuhon, as I said, it's a C++ implementation of the Filecoin protocol. It started in 2019. It was completed in Q3 2020, so not far ago, but now we are, as you will see later on, we are finalizing some things. We are working on testing, improving certain things, and focusing also what will be in the future. The idea is that this is more macOS and Unix oriented, but of course you can try to use this C++ implementation on any other platform and try to run a node. On the right side of this slide, you can also see our AHA board that is showing different phases after we started. Initially, we were researching the specification, and then we were developing C++ implementation over that period, and we were having, with Protocol Labs, we were having regular meetings every 2 weeks, reporting about the progress and getting their instructions, and also they were very helpful all the time, having additional meetings to explain technical questions before we continue with the implementation. So what is the current status of the Fuhon project? So we have a node and miner compatible with Lotus version 0.5. So now we are catching up with the latest version that is available. I think it's 0.9. And storage and the retrieval market are completed. We also received, which was very, very helpful, a conformance test suite, so which has a number of tests, as you can see here, altogether 577 tests. And we are very happy to announce now that just from this week, all the tests are passing. So it seems that our implementation is without any visible problems. Also, all required transport layers or security protocols are implemented. So this is TLS, noise, and security IO that we are also supporting in C++. So what is still in progress? As I mentioned before, we are working on some compatibility issues with the mainnet, because the mainnet is a little bit upfront of our version that I mentioned before, 0.5. So we are catching up with this. And then we will also verify whether the blocks that we are producing is also compatible with the latest Lotus version, so everything works together without any problems. And then we need to integrate and also perform security testing to make sure that there are no problems in this particular implementation. That means in C++ implementation. So what's next? One of the ideas, of course, having an alternative implementation of Filecoin in C++ is also to potentially make it faster in C++, at least under certain conditions. So we will be working on performance improvements, and then certain owners of the nodes might choose C++ in the future over some other implementations. We will see how that will go, and everyone will be able to test this in the future and decide whether this is in a certain cases more appropriate than some other implementations of the Filecoin protocol. And then the next improvements that we are working on is improvements of the command line interface, adding some documentation and providing some examples of how to use and run C++ implementation of the Filecoin. After we complete all this, which we believe it will be quite soon, so probably this month or beginning of the next month, then we will be following all the changes, all the upgrades and future versions, also in C++, obviously. And we were already exploring some new ideas. I would just like to say that this was not discussed with the protocol labs or with the community, but we would like to do this in the future, how we can expand what is offered now. So one of the ideas is to also support NFTs. For example, for Polkadot, we were already discussing some use cases where you can integrate Filecoin with some other networks. I will not mention the name, but it was one of the very well-known and major blockchain networks that are existing. But since we did not get approval for this or on both sides, I will not mention the network, but it's very interesting for the future. So I guess that's more or less all about the Fuhon, about our work. If there are any questions, we are happy to answer them.
Great, thank you very much. Yeah, folks, feel free to put questions in chat, and if we've got some time at the end of the session, we'll certainly get to those. But yeah, thank you. It's certainly very cool. Of the many benefits that we have from these other implementations, I'm really excited by the idea that innovation will start being driven from some of the brother and sister implementations. That's really cool. Thank you very much.
Yeah, thanks.
Yeah. So next up, we have Stephen Lee talking about Venus. Stephen Lee is the co-founder and CTO of IPFS Force, which I think is a familiar name and familiar face in the IPFS Filecoin ecosystem. Very active participants. And the latest endeavor is that they volunteered to pick up Go Filecoin after it graduated to community maintainership. So Stephen, I'm excited to hear how that's going. Over to you.
Okay, yeah, thank you, Ayush. wait a minute, let me share my slides here. Okay, I think link this. Share option. Sorry, wait a moment.
No worries.
Okay, I think it's here. Yeah, I think I got that.
We're seeing your screen, but not the slides just yet.
Yeah, can you see my slides?
Yes, that looks good. Thank you.
Okay, sure. I will play this. Okay, yeah, thank you everyone. My name is Steven. I'm from IPFS Force. Yeah, I'm the co-founder and CTO of the IPFS. As you all know, the IPFS Force located in Shanghai, China, and we have been working on the IPFS and Filecoin for about 3 years, and yeah, focusing on to build up the ecosystem. And in these 2 years, we are focusing on Filecoin mining and to build up some other services and applications. So now we're taking over the Filecoin to build up another implementations like Lotus. So yeah, before I show our next step, yeah, I want to talk something about how we yeah, transfer the name Filecoin to Venus. So we name it as Venus is because Venus is the first star we can see every morning on Earth, right? And as Filecoin is the first implementation of Filecoin protocol, so we want to keep that. And also, we think that the the whole Filecoin system is actually for the interplanetary system is like for example like the like the solar system, and the Venus is one of them, one planet of the whole system. So yeah, it's a part of the ecosystem. So that's why we use this name Venus. We pick up this project from mid of September, which is last month. Okay, in the last month past, we had done something. Firstly, we want to say that the Filecoin actually the development was paused in June. Stopped upgrading, and the whole Filecoin team actually focusing on the Lotus and also the Spec upgraded. So after that, and actually in late of June, I think the Filecoin had once to be able to interoperate with the Lotus. But after that, the Lotus had been evolved a lot. There are many kind of code change, and the spec also changed, and some others. For example, the gas mechanism and the spec actor change, and also data structure change, and all this. So when we pick up the Filecoin, we had done something to make it be able to interoperate with Lotus. What we have done is like, for example, all of the package dependency upgrading, and also the data structure change, to follow up the protocol change and the message handling, the gas mechanism, all of this. And also we need to handle the forks. So based on that, I would like to, I'm very glad to say that Venus right now can sync with Lotus to the height 20,000. Okay, there is also a long way to go, but we have done something to make it to this height. This height is we are continually to work on this. we currently we do not use the test vector. We just use the mainnet, the space chain to directly to sync with the chain and to find any problem and to fix them. The team here, my team thinks that that is more direct and perhaps more efficient to implementations and operate well, and we'll continue to this. We hope in 2 weeks we could have the two implementations could work together. So if we look forward, we want it's because Venus and Lotus actually are all written in Golang, right? The same language. So we want to have some difference between them, and to make the Venus to be suitable for some people to use. We define Venus is like mining pool friendly implementation, and the big feature we want to support is to support distributed mining pool. For achieving this, we will have kind of different architecture than Lotus. So we want to decouple many things. We want which can make this whole system very flexible. For example, we have the chain syncer as an independent component, and we could have a chain syncer. We could have a cluster chain syncer. As you can know that well in our in many mining pool, we cannot only have one chain sync load, is because we need to have some redundancy. While we have this redundancy, we could have multiple chain sync load to do the same verification. And actually, they can also do load balance, right? So we want to do that and to have the chain syncing more efficiency. And we also want to separate the messenger and to be independent to make sure that all the messages can be on chain. And we could have the secret manager, and we'll have the seeding process separated out of the chain syncing, and we have the post separated, and we could have the GPU outsourcing implemented. So we could have different components and which enable miners to build up their different kind of clusters or distributed mining pool. And also, with current Lotus implementation, I think that the CLI the command line interface actually is not so. Because the command line interfaces are separated in Lotus or Lotus Miner and some other components. We want to actually have this kind of Filecoin client interface, very small one and a light one to have all this to link to the chain sync messenger to make all this kind of command or message can be sent out. And another thing we're thinking about is about the storage. We want to currently we have the file system storage to build in the Lotus, but for the Filecoin system, we will think that the object storage will be more appropriate or more suitable for the Filecoin implementations. So that is also one option we want to do. There is that, and naturally it's a long way to go. So firstly, we're focusing on the chain syncer, and while the chain syncer is okay, we may use some part of the Lotus components to interoperate with with the Veda system, and we can build all the components one by one. So I think that's all. Yeah, thank you. Any questions? We're welcome.
Great, thank you very much, Stephen. And thank you for all of your work on this. It's great to see what used to be the Go Filecoin project getting the attention and work that it deserves. Folks, feel free to continue putting questions in the chat. But we're going to move on to Austin, who's going to be talking. Sorry, he's going to be talking about Forest, another implementation of the Filecoin protocol. Austin works with ChainSafe, who've worked on a few different cool blockchain projects. So we're happy to hear from you now, Austin.
Awesome. Thanks so much for the intro, Ayush. So yeah, my name is Austin. I'm the tech lead of the Forest project, which is basically a Rust implementation of the Filecoin protocol. As you said, ChainSafe works on a few different ecosystems: Filecoin, Ethereum 1, Ethereum 2, Polkadot, Cosmos, building Ethermint, ETC, and also we are hiring, so specifically also Rust developers. Let me just put some present mode actually. Specifically Rust developers. So yeah, I just wanted to give a quick note about that. So why are we building it in Rust? I guess the main reason for us is safety. So as a verifier.
Sorry for the interruption, Austin. I just wanted to check. Do you have do you have a deck that you wanted to be sharing? Or
oh yeah, I absolutely.
You're not sharing your screen yet. Thanks.
I thought I was. Sorry
not
about that.
Yet.
Might be sharing now, but can you see now?
Yeah, that looks good. Perfect.
Sorry about that. I clicked it before. It must not have switched. Awesome. So yeah, anyways, working on Forest project, the link's there. So yeah, why are we building Rust? So the reason for Rust is primarily for safety. Rust has a lot of unique features and a very robust type system. So the main things that kind of provide benefits to our implementation are pointers and immutability are checked at compile time, which means that there's no null pointers, no double freeze, no dangling pointers or use after free, which may not mean a lot to someone who isn't a developer, but just know these are very kind of common problems and kind of opens up to security vulnerabilities. Also, there's no data races, even with concurrent programs. The type system in Rust kind of ensures that if anything is sent over any thread boundaries, that it has like atomic counting for any references or any sync primitives that are necessary. Other is no seg faults and no buffer overflows. Again, all these like kind of memory unsafe issues may not seem like a big deal for a lot of people, but for example, Chrome and Microsoft kind of did a analysis on the security vulnerabilities that they encountered, and it was around 70% of them were memory unsafe issues. So this kind of just like avoids that altogether. And also the benefit for us writing this in Rust was that we were able to find bugs with existing implementation and kind of find a lot of these issues at compile time instead of finding them at runtime, which is kind of strange for an alternative implementation. So the next thing, so also we want Rust because of performance. It's a compiled language. It compiles the machine code through LLVM. There's no garbage collection or runtime, which means there's no GC pauses, no memory overhead. There's zero cost abstraction, which is kind of a buzzword, but it just basically means it's going to optimize any unnecessary code. Efficient generics, which means it's basically going to optimize if there was no generics and avoids dynamic dispatch. And then also the main benefit, I guess, in this use case is that we interact directly to the Rust fill proofs, and we don't have to go through an FFI, which is kind of a benefit for sure. So basically, to kind of explain what we're building, this is kind of like an extremely simplified version of the kind of architecture that's set up. where you have the Lotus node, the markets built in, and then the API which the Lotus miner connects to. Basically, what we're doing is we're basically swapping out the node for a forest node, implementing our own RPC API, separating the markets implementation, and then also basically just allowing you to use the existing Lotus miner, which will in future be replaced with our own native implementation. So basically, what have we done so far? So basically, what we have done so far is all the IPLD implementations, which includes the Hampton implementations, which are used all throughout actors. Basically, our VM and actors Rust implementation up to network version 4. Currently, we're right now, all the other implementations are kind of relying on the Go implementation of spec actors. So it kind of provides some, network resilience by having this in another implementation. And through this implementation, we are almost spec informant. We're more than 95% passing. There's about 1,000 testable vectors for us right now. There is more, but right now, because we're testing only specific, because we can't test network version 4 and 5, it's limited to about 1,000 test vectors. And the next things we kind of have is the syncing and networking. So we have all the sync protocols implemented, and we have full verification of blocks. The only thing that's kind of stopping us from doing a full sync of mainnet is just like a small state discrepancy, but we're solving that right now. And obviously the JSON RPC API, which is intended to be compatible completely with Lotus in the future. Right now, we're only implementing what we need, but yeah, this will be expanded. All right, so basically, what are our goals right now? So our goals, at least for the near future, like for the past, I'd say about a month or so, has been generally interop. There is a lot of code within the VM and actors that has to be like very meticulously matched. So our goal for this is passing all conformance vectors. We're getting extremely close right now. There's just very small discrepancies. Next is obviously syncing mainnet tipsets, doing the upgrade, the V2 actors upgrade, and then also being able to like sync mainnet completely. This is by far our primary goal. We're definitely getting close, and we'll obviously update whenever we make big progress in this. And then our kind of secondary goals, but definitely still in progress, are the Lotus miner integration. So we should have this soon as well. Basically allows you to produce blocks using the forest node as like the base node, and then allows us to like run internal test nets and actually like verify the functionality. But we are completely interoperating with Lotus as of now. So next is markets integration. So the integration we're doing is through GoFill Markets interface. It's another project that ShaneSafe kind of did, which separates the markets implementation outside of Lotus to be able to be used by any implementation. And obviously the goal for this is having storage and retrieval conformance. And then finally, our other goal to this is JSON RPC compatibility. So basically allowing it to having our API set up such that if you swap out a Lotus node for our node, you won't be able to tell the difference between the two. That is definitely our goal, and hopefully we'll get to that soon. And just to kind of talk about future work, nothing's really set in stone because it's very up in the air, and we have been kind of very focused on interop for the past, I'd say, month or so. But just to kind of give an idea of what we're kind of thinking about, we obviously do want to have a full Rust implementation of the storage miner and markets, just to be able to have like optimizations and then have the UX improvement of not having to, build and then run other code bases. And then the next is obviously researching and refactoring architecture based on client needs, just to be able to do kind of more intricate or unique architectures for maybe different client usages. This one's kind of, if anyone does have anything that they do want supported, like we do want to kind of obviously take in node operators' opinions and kind of wishes for this. So if anyone kind of has any suggestions, we would love to hear it, because we will be going through this kind of refactor once we hit interop. And then kind of another thing that's kind of more of an interesting point, I guess more personally interesting to me, is kind of compiling actors to WASM. So Rust does have great WASM compilation support, and this would be very useful in the case of having, as I said before, every other implementation is relying on the same code for the VM state transition. So it would be nice to kind of have an alternative. So if you do still want to use a Lotus node, but want to use, say, the Rust implementation of actors, you could swap it out if there is any kind of security concern or anything else like that. And then yeah, I would also just like allow other implementations to kind of share this logic instead of everyone either having to re-implement it themselves or go through an FFI or CGO. And that's pretty much it. I don't know if we're taking questions right now, but I'm kind of happy to answer any. Put my GitHub there as well.
Great, thank you very much. Folks, feel free to continue to put questions in the chat. We might have a little bit of time for Q&A at the end. But yeah, thank you very much, Austin. I just want to quickly say that it's really cool to see how close some of these implementations are to actually landing on mainnet. And speaking as someone who builds Lotus from within the environment of Protocol Labs, I know how fast things move, and I know how hard it can be to keep up with everything that's changing. So I just think that everyone working externally has been doing a really, really great job at keeping a pace with all of our changes and evolutions. And yeah, I'm very excited for the security benefits that'll come from the other implementations, from any innovation that's driven by it. As well as maybe some healthy competition between the implementations in aspects of like performance and user friendliness and so on. I think it's going to be really, really good, and I really appreciate all the hard work that has been put in by these other teams. I have a little bit of an update, given that folks were talking about sort of what comes next in the session. I have a little bit of an update for what Lotus has been doing and what Lotus has coming up next. We can go through that really quickly. Give me a second to share my screen. So that should be good. So obviously Lotus is what's running by all of the nodes on the network right now, at least, except for folks who have written their own private implementations. So I'd like to talk about what we have coming up next in Lotus land. Version 1.0.0 is out now, and that really just flags the code that we launched mainnet with, the code that was running for our Liftoff epoch. We actually just put out 1.1.0, which is the first kind of mandatory release of Lotus. It'll be implementing a FIP that a lot of miners have been very, very excited about. And the current network upgrade epoch has been set for Thursday evening PST time, so maybe early Friday morning in some parts of the world. So that's kind of been our immediate focus. Apart from that, kind of work splits into two categories. There's work that we're doing in the core protocol itself. Obviously, given that we've just launched, we think there's a lot of attention on Filecoin right now, and we are kind of in a state where we're like really monitoring the network, making sure everything is working as intended, making sure no rules are being violated, and so on. So if there are any issues, we want to act on them as quickly as possible and fix them in releases of Lotus. We're also always talking about improvements to the protocol, improvements to the specs actors code. The actors code is kind of where all of the pre-compiled contracts in Filecoin world live, as well as FIPs, which are Filecoin improvement proposals that we may want to include. The cadence that we're looking at is around one network upgrade release a month, but especially in these early days, we might have to move a little bit faster than that. And I just want to say we really appreciate the cooperation from miners and our various other integration partners to move as quickly as we need them to. It's critical to the network, to the security of the network. And outside of protocol stuff, there's also a whole bunch of improvements that we're planning for kind of core Lotus itself. One of our engineers, Magic, who's a friendly face to a lot of y'all, has been working really hard on a major refactor and improvement to the core mining logic. Some of this has already landed, and we're going to be kind of carving it up and landing it in Lotus over the next couple of weeks. We have improvements to the Proust libraries coming that will hopefully speed things up and make those work a lot better that we're hoping to land soon. And then, as anyone who's been on the Lotus GitHub repo will notice, we have a lot of open issues submitted by users, miners, community members. We welcome all of them. Please keep them coming. And we're excited to kind of work on some of the maybe smaller bugs or feature requests that we've had from there. Yeah, so that's kind of what's next in Lotus land. We're at time, so I think we're gonna have to move on. But please keep your questions coming. Feel free to reach out to folks who are working on the external implementations, especially if you'd like to take them for a spin. I think contact information was included in this, and they're also mostly available in the Filecoin Slack channel as well. So yeah, thank you everyone. Thank you for being a part of the session.
Thanks. Bye bye.
Hello, everyone. A very warm welcome to How We Won Space Race. I have been so excited for this panel. I get to reunite with lots of my friends from Space Race this evening, so that's super cool. And I'm also really excited to just have a chat about the Space Race experience, what's happened since, how the teams are doing. I'm hoping that everyone got a lot of sleep. It was a really busy 3 weeks for everyone. So I'm just going to start the session this evening by asking all of my amazing panelists to do a quick introduction of themselves, talk a little bit about their teams, where they're based, how big their teams are, how small their teams are. So let's start, please. Should we start in winning order of Space Race? Does that mean? I don't know. Let's start with Neo, please, from IPFS Main. Neo, do you want to introduce yourself?
Yes, absolutely. Thank you so much, Angie. Hey, everyone. My name is Neo G. I'm the co-founder of IPFS Main. And we grew from a 4 people, a small company. Over the 2.5 years, we grew to like 50 people only working in the headquarters. That number doesn't include the O&M, like personnel working in the mining farm. We are based in Shenzhen, China. And for myself, before I started at IPFS Main, I was the founder and the CEO of Mining Host, which was a mining startup focusing on Bitcoin and Ethereum mining on a medium scale.
Awesome. Thank you very much, Neo. Next, Lee, can I ask you, Lee from Six Block, can I ask you to introduce yourself?
Yeah, hello everyone. It's the second time I take part in such activity from the official group, and nice to see you again. We are a group of developers in China. We are located at Beijing and Shanghai, 2 big cities in China. Yeah, we have maybe 10 or more than 10 people here who are working on the 6-block Filecoin mining solution and the Firefox Explorer. So we'd like to contribute our power and our knowledge to the Filecoin economy ecosystem. So glad to see you. So I'd like to share our mining solutions for the Space Race 1 in today. Thank you. Yeah.
Thank you so much, Lee. That's awesome. And next, can I please invite Stephen from IPFS first to introduce himself?
Okay. Yeah. Thank you, Angie. Okay. My name is Stephen. I'm the co-founder and the CTO of IPFS Force community. IPFS Force community was set up, I think, 3 years ago, and we had done a lot of them before we set up a company. We have many kinds of meetups to make the IPFS and Filecoin recognized in China by many people, and actually we are continually doing this because we have the IPFS Force Open Day every week. So right now, actually, we have done about near 150 ones. So yeah, it's amazing. And also we have done something, for example, to translate the white paper, and we have many articles. So we actually consider us as software and solution provider for the whole ecosystem. Yes, it's because we never sell any hardware machine. We only have the software development, and we have the global global partnership actually to help our to help any people or any company who want to be in the Filecoin ecosystem to help build up the network and to build up some services and applications. So yeah, we are very deeply involved in this ecosystem, and also right now we're taking some dev grants projects. For example, right now we're pick up to resume the Go Filecoin implementation. Yeah, we learned that. So right now the current changed from Go Filecoin to Velas. From today, I think. So we'll continue to support all of this. It's all. Thanks.
That's awesome. Thank you very much, Stephen. And last but not least, Wayne, would you please introduce yourself?
Okay.
Wayne, you can go ahead and introduce yourself. Oh, sorry, you missed the last part. Yeah, if you want to just introduce yourself, tell people your name, where you're from, a little bit about your team.
Okay. Hello, everybody. My name is Wayne Yang, the CTO of AIS. AIS is founded in 2010. We are in Shenzhen, China. AIS is a national and Shenzhen high-tech enterprise, and the company has focused on early and new technology development and purchases near 60 patents, more at invention patents in relation to blockchain, private cloud, and other field. And we have and our team have more than 40 people developers. Thank you.
Wow, that's amazing. So an incredibly impressive lineup of teams and projects. Thank you so much, all of you, for being with me today. I know that you're really busy mining Filecoin at the moment, so thank you for stepping away just for a moment to share with the community. I'm going to start by asking how you found out about the Filecoin project. If I can start with Neo, where did you come across Filecoin? What was the start of this journey for you?
Well, I heard about Filecoin several years back in the Filecoin community while I was still doing the Filecoin mining and hosting at that time. And as you know, the cryptocurrency community, they share news very quickly. And actually heard of IPFS first, then the Filecoin project. And after quite amount of time, Protocol Labs released the newer version of the Filecoin web paper, and that's when I started to learn and get more interested in the Filecoin project.
Awesome, really, really cool. And I think IPFS is a gateway for a lot of people to have learned about Filecoin. It kind of is an underpinning for the infrastructure of a lot of Web3 projects. So that's really, really, really great. What about you, Lee? Where did you find out about Filecoin?
Yeah, I started to study Filecoin in November last year. I remember now at then there is a new release of the Lotus, a new testnet, maybe testnet phase 1, and then we started to study the underlying technology of the Filecoin. We mostly focus on the zero knowledge proofs part. We just wonder how Filecoin uses zero knowledge to solve the problem of to prove fire on the blockchain, use some very short proofs. So and then we found that we can just sometimes to improve the calculation process of the Filecoin to make the mining process more efficient. So we like to develop some improvements to the mining part, the field proof to do the mining part to make the sealing process more have a shorter time have a shorter time. So then some people would like to they ask us if we can provide overall mining solutions, so they can buy hardware from us. And then we started to develop start our business here in China. So we just do some we just took part in the testnet phase 2 and 3 and the space race. So that's how we get into the area of the Filecoin. Yeah.
Awesome, very interesting. Completely. So you're fairly new to Filecoin, I guess. Like given the Filecoin timeline, last November is fairly recent. So that's super interesting. And Stephen, what about you? When did you come across Filecoin?
I remember the first time I learned about Filecoin is in a meetup I attended back to 2018. Yeah, I think perhaps in June or July. At that time, I think, yeah, it's very interesting. It's because before that, I had studied IPFS for some time. Yeah, which is because I have been working on the storage industry for a few years, and I found that actually the centralized storage technology out of date actually, which cannot support the demand of the new era. So I think we need to find some new technology, and the IPFS is really amazing and attractive to me. So I had started some of that, and so while I and also at that time, I'm trying to find a new opportunity for my career. So yeah, once I did this Filecoin, and after that, perhaps I said for about in 3 years, I met my partner who has set up IPFS community, and he actually participated into the ICO. So yeah, and after that, yeah, we worked together on this since I dive into this and working on this for a long run, I think. Yeah.
Amazing. So that's a fairly long time ago. Kind of came through that IPFS funnel, if you like, then met another great mind who was interested in decentralized storage, and together you formed a company. So that's a really exciting journey to where we find ourselves today. That's really, really cool. And finally, Wei Yan, what about yourself? How did you find out about Filecoin?
Oh, hi. In fact, in 2017, ARS launched the IPFS play that focuses on practical application of IPFS technology in the and in 2019 we start in focus on notice and do something and in the first in the testnet and development that AIS create the first node to reach 1 PB and 2 PB computer power in Filecoin testnet, which is also the only 2 PB node in the first phase of the testnet. I think we think IPFS not only Filecoin, and the IPFS is a very amazing work. So we will focus on it continuous. Thank you. Thank you.
Thank you very much, and that's wonderful as well. I feel like everyone had quite different journeys to discovering Filecoin and becoming part of the community, which is great to see. And I'm sure a lot of the people here in the chat, like, please tell us your stories. Like, we'd love to know how you ended up finding Filecoin. Was it an accident? Were you looking for a decentralized storage network, and there it was waiting for you? Okay, so you're all winners. You were all so successful in Space Race. That's why you're sitting here today. Tell us what the secret to your success was. You know, was it your teams? Did you write some great custom software? What was it that really kind of drove you to be very successful in Space Race? If it's okay, we're going to start with Neo again and go along the panel. Neo, why are you a winner? Why are you a Space Race winner?
Yeah, I think, first of all, the skill matters. The skill would bring you more rewards, but at the same time, you need to, you know, pay more for the hardware, fiber, labors, and other resources. And also skill would bring other issues with stability of Filecoin mining, which is another really important part of to be considered. And that's why the mining architecture is the key to the Filecoin mining. I have shared twice during this official EA events and about our architecture, the hardware, and our mining solutions. Yeah, I think I will leave most of the time to other panelists here since I already shared a lot about it. And if you guys are interested, feel free to take a look on the Filecoin YouTube channel.
Awesome, thank you, Neo. That's very gracious of you to give your panelists more time to talk about why they're so brilliant. Lee, what was the secret to your success in Space Race?
Yeah, okay, I think we at the first time we noticed that when the mining cluster is in large scale, the large scale will bring more and more problems to the mining process. So we divide our servers into many small clusters. And as you see, we have we have a lot of miner accounts on the Filecoin testnet. All these clusters are named by some chemical elements, yeah, like H, like Fe, like whatever. So when we divide these servers into small clusters, we have fewer problems, especially in the Filecoin in the synchronization of the node and the transportation of the Filecoin sectors. So I think the reason for our winning is that the small clusters make the whole system more stable. So and if one of them have problems, it will not affect the overall all servers. So we also have some problems during the Space Race 1. For example, some nodes will lose to connect with other nodes, and they will lose the synchronization. So, but this cluster will only have a few of the clusters will have problems, and the others keeps working well. Other keep working well. So our software engineers will handle these problems as soon as possible. So overall, all the servers are working stably during the Space Race 1, and I think we are the first. We are the only mining solution providers which would like to use small scale clusters, and I'd like to prove this is a better way for Filecoin mining. Yeah, thank you.
Thank you very much, Lee. Stephen, why are you a winner? Tell us a bit more.
Okay, so yeah, first of all, I will say, yeah, there is no secret. Yeah, why we say that, yeah, say this is because that I had been working in the storage industry for many years. I know that the storage provider is not easy. The storage technology is quite quite complicated, and it's because that you need to maintain a very big system, and you need to have your system to serve many clients, right? So it's not easy. So I think many people who just joined this Filecoin mining, they have some experience of the Bitcoin or Ethereum mining experience, yeah, but that is not enough. It's because Bitcoin mining is much simpler than Filecoin, is because Filecoin is really providing useful services. So the whole thing is that you need to have the traditional storage provider methodology to apply into your system build up. So you need to have some people to dive in the system, to develop, to do some research, and to have a very strictly process to make your software stable and also efficiency. Based on that, you need to have a very good test before you launch your system, right? Just as Filecoin is doing right now, and also for each miner, you need to do that too. Because of as ours here in this panel, we all actually customized the software. So you need to do all the testing and do the integration and to think about everything about each piece of the whole system. And also based on that, you need to have professional operation and maintenance engineers. And actually you need to have a team to maintain all of this. Is because, for example, for the IPv4 community, we have many partners, and we need to make our partner success, and we need to provide professional services for them. And that's also why I say there is no secret, is because we share all of this with our partners, to make them success. So and then we could be successful, right? That's all I think.
Absolutely, I couldn't agree with that more. I think you're right. There is no secret. It's a lot of hard work and a lot of dedication. But I think you're right. I think it's about working with partners, working with the community, working together. Filecoin is an open source project. I think that's been integral to the success of the project. And as it develops, it becomes more and more important that people we're operating that way and we're collaborating. So I think that's a really fantastic take. And what about yourself, Wei-Yan? What's the secret? Well, as we've agreed, there is no secret to success, but what do you think made you so successful in Space Race?
Okay. Personally, I'm very happy that the miners supported by ARS is works very well. I want to talk about our standards. We think Filecoin Miner is a product that includes production attribute. We think we have four dimensions. This is the first one is the security, the security and stability and efficiency and cost. I want to say without security it's meaningless to talk about stability, and without stability it's meaningless to talk about efficiency. Without the safety, stability, and efficiency is meaningless to talk about cost. I do some. We do very more works in security works. It includes chain security and mining pool security. Okay. During the operation of the miner, we make sure the stability is very okay. Okay. Thank you.
Yeah, I think that's a really good point, Wei-Yan. I think security, stability, resilience, these are all really, really important factors in Filecoin and Filecoin mining. It's important what we're doing. Filecoin mining isn't just mining that goes into the ether. This is a utility where you're providing like a real use So like having security and stability is so core to that. So I think that's a great answer and a great perspective on why you're a winner. Okay, my next question is about your vision for Filecoin and Filecoin mining. You are all you've all been participants in the network for a while now. You're all very active community members. What is your big dream for Filecoin? Where can Filecoin go? If we'll start with Neo, please.
Sure. I believe the future of Filecoin will become more and more hardware friendly. There will be more and more people to join in Filecoin mining, no matter consciously or unconsciously. What I mean by unconsciously doing the mining is that even though they are sharing their disk space and or bandwidth with the Filecoin network for profits, they actually use application built on top of the Filecoin project with smart contracts without knowing what Filecoin is. And I think there's a really good example of this is the repair miner. Repair miners are the miners who replicate files to keep them available in the network. Especially when a storage miner present a fault, right? And they are responsible to repair offline and faulty sectors. We could treat the repair miner as the general contractor who takes order from the network. Then find storage miners as subcontractors to get the job done. But there are much more repair miners could do. They could utilize smart contracts to create a secondary market where anyone could join to share disk space for profits. And they don't even have to keep the hardware running 24/7 and still get paid by the repair miner. And I think it all depends on the smart contracts terms they would be utilizing. So I believe in the future, the application built on top of the Filecoin will be increased by a tremendous scale. And right now is a really good timing to do some founding and development over the Filecoin network.
Definitely, and that's really great. I think repair miners, and yeah, that's really interesting. That hasn't really come up so far while we've been talking in Liftoff, so it's great to see that introduced into the conversation. Lee, what's your thoughts? What's your vision for Filecoin's future? What's next for the network?
Yeah, I also think that the application is very important for Filecoin in the future. As we know nowadays, on the Filecoin network, most data are garbage data. And I think with the mainnet, after the mainnet was launched, more and more people will notice that Filecoin is a platform that good for storing their own data, and they can retrieve the data anywhere they want. So I think maybe in the future, more and more important and valuable data will be stored on the Filecoin network. And for the people who want it, they need to pay some fee to the miners to retrieve this data. And based on this data, this valuable data, more and more applications will be developed. So I think based on Filecoin, there will be some important applications, like especially something like data analytics and like something like machine learning. And I think because Filecoin is good platform for the data used for like machine learning, like some data analytics, we can store some public and some data, like for example, like self-driving data, like the weather data for that will be public on the Filecoin network. And for scientists and developers, they only need to pay a little fee to get access to this data. I think based on the Filecoin, some scientists will be the first bunch of users for the Filecoin network. So only when applications growing more and more on the Filecoin network, I think the network will be more valuable, and the price of the field will rise. Thank you.
That's awesome, Lee. No, I love that. And I think so later this week, we've actually got Store Day where we're going to hear, there's going to be some exciting announcements about folks who are going to be storing humanity's most valuable information on the network. Yeah, so definitely if you're interested on the data sets and some of the case studies that we have on Filecoin and to hear some announcements on that, join us on Thursday at Store Day. It's going to be really exciting. And I can tell you, Lee, you're going to be excited because there's definitely a couple of scientists in there. So stay tuned on Thursday and you'll learn more about that. But yeah, I love that. I really want to see academic data. I'd love to see machine learning applications being built on Filecoin. I think that's a perfect use case. So yeah, that's wonderful. Thank you for sharing. Stephen, what about yourself? What is your dream for Filecoin? What is the next kind of steps for the network?
Okay. Yeah. Firstly, I want to say that the mandate Liftoff actually is just a very small step for the Filecoin. As just the Filecoin team just did. Okay, what the team just did is very cool. I would think that is because it's not like any other blockchain. You know that any other blockchain, if the mainnet launch actually is a very big thing, but the Filecoin team consider this is a very normal thing. We just let it go and move on, and it's just another height, right? It's not anything special. So and I think that is very cool is because the Filecoin has a very long way to go and to achieve its target to be the base of the human civilization information the storage base, which is very cool. I would think that it can really achieve this is because the Filecoin is built up a very fundamental infrastructure for the for the storage. We will so firstly, I would think that the most valuable data could be stored on Filecoin is because the Filecoin is a non-lab infrastructure. Is the it is not like any data center controlled by any company. You know that any company can only, for example, for about 100 years is a long time for a company. But for one infrastructure, it could live for many long time and very long time, and it could evolve, right? And could continually improve and to have works. It is open source and built up by many people by this is one thing about this. And the first thing I want to say, the Filecoin, this is only the start of the Filecoin. The Filecoin actually is open a door for the blockchain industry. It's because the blockchain has the bottleneck for the storage. Because the blockchain actually cannot store any main data, but the Filecoin can do that. And so the Filecoin can integrate with many other blockchains and to open a door for the apps, and for any apps to this decentralized infrastructure. This is one thing the Filecoin can do, and I will say that it can also contribute to the whole blockchain industry in the next year. So that's why I would think that Filecoin is the blockchain version 3.0. Okay, yes, Bitcoin is 1.0, right? The Ethereum is about the smart contract is 2.0, but Filecoin is 3.0. So there's a long way to go. We will keep moving and build up this together. Okay, thank you.
Thank you very much, Stephen. And I couldn't agree more. I actually love the way you phrased that. Like it's, it's blockchain 3.0. Like I'm going to steal that. But yeah, no, I think that's great. And I think that's it. There are two really vital elements that you've talked about there. One is that this is being built and is owned by all of us. This is a community effort. This is an open source effort, and it only gets better by us all building and improving together. And then the second thing is this is for the long term. We've just begun. Launch just means the opening of that door, the beginning of like many stories, many companies, many applications. So yeah, I think it's a really great perspective on how far we have to go, but what an exciting journey it will be for all of us together. So thank you very much. And what about you? What is your vision for Filecoin? What does the future look like?
Okay. About this question, I want to share one slide to. I want to share my screen to you. Yeah. About this question, I want to talk about 2 points. The first one is the Filecoin technology. Filecoin technology is more complicated, which is depends on it. Has both function of a chain and the function of storage. So everybody must have some patience in Filecoin mining. The 2 point is about warm storage. Warm storage, according to current development of the network, Filecoin is only used as a cold storage, but when Filecoin really slows warm storage, I think the volume of the whole Filecoin network will be truly very awesome. And this is also the most exciting moment, in my opinion, for Filecoin. I also hope to see this situation soon. I think the warm storage is very important point. I think if warm storage is done, the Filecoin can doing very more thing. Thank you.
Thank you very much, Marianne. Yeah, so that's a great perspective. I think having patience is important. Things that are as huge as this and as important as this take time and take patience and take collaboration and understanding. So I think that's a really good point. Well, I'm so sad to say that this is the end of our chat today. I have so enjoyed catching up with everybody. I want to thank you all for being just wonderful community members, wonderful contributors to the project. We're all building this together. And it's just been a real honor for me to be able to sit down with all of you, take some of your time away and to be able to hear your perspectives. So I thank you so much again for sharing with us this evening. And I wish you a happy mining from here on and look forward to chatting to all of you in Slack. If you have any questions for our amazing panel, then please talk to them on Slack. I've had, we all talk to each other all the time. It's a great place to ask questions, to collaborate. If you're stuck on something, I can guarantee that all of these wonderful people will be willing to help you out. So please reach out on Slack and say hello. And thank you so much again to all of my wonderful panelists. It's been a delight to chat to you this evening, and a huge congratulations on winning Space Race.
Thank you so much, Angie.
Thanks, Angie. Great.
Thanks, everyone.
Bye-bye.
All right, thanks so much, everyone. We're going to take a quick 2-minute break, and then we're going to go on to our next session. So join us back here. Thank you.
All right. Hello, everyone. Okay. Okay, great. So I think we're rolling. This is the Retrieval Markets meetup. So I'm just going to quick introduce it, and then we're going to have 4 teams who are working on Retrieval Markets present. So one sec. Okay. So my name is Mike Gelzer. I'm from the Filecoin project. You can reach me at mgelzer on Filecoin Slack. And I just want to sort of introduce things by talking about first just a second what is the retrieval market. So if you go back to the original Filecoin white paper, the first Filecoin paper came out in I think 2013. It's been updated several times, but what it describes is actually 2 markets. So the main one is the storage market. That's the one that is launched this week. That's the impetus for the whole Liftoff week. That's what the Liftoff is. And the storage market is where you buy storage from different storage miners who are competing with each other to provide the best reliability at the lowest cost. But the paper also talks about a second market, and that's the retrieval market. And the idea with the retrieval market is that in some cases, you'll have content that you want that's not private to you. You want people to be able to retrieve it, a large number of people. And so in that case, what you actually want is for the providers of retrieval to be in a competitive market with each other where they're competing to provide you with certain content at the lowest cost at the highest reliability. The same idea as the storage market. And so what we're going to do tonight is hear from 4 different teams who have taken different approaches to this problem. And they all have very interesting perspectives on it. So I think it's gonna be a good event. I want to ask the presenters, please keep yourself to 10 minutes. And for the audience, please feel free to use the Q&A at any time. You can ask questions, and presenters can address them either in their presentation or in writing after they finish. So with no further ado, I want to move to Peter, David, and Robert from Consensus to hear about their retrieval markets architecture.
Thank you, Mike.
Yes.
I'll just share my screen, and there we go. And yep, I'll just make sure my timer is started. Yep, okay, we're off and running. So as Mike said, I'm going to talk about, so I'm Peter Robinson, and tonight I'm going to talk about the Filecoin secondary retrieval market architecture. So David Highland Wood and Robert Drost and I have collaborated to create this. So when you're thinking about markets, there's the primary retrieval market and the secondary retrieval market. So primary retrieval is really about going directly to a storage miner to get your content. Whereas a secondary retrieval, it's all about discovery and having the information in highly available off-chain sources. And so it's all about being able to discover where the content is and being able to get it. And by market, it's all about having choice and being able to have a market between buyers and sellers to find the best deal. So you can think of a primary retrieval as you've got a Lotus node which talks directly to a storage miner to get the content. So when we were thinking about this, about what the objectives for this system should be, discovery is obviously a big one. We need to discover where the content is. We need to promote caching in the network so that you might have content cached near you. Low latency is incredibly important. So people want to be able to get their content and have it available immediately. We need to support massive scaling, so 2 to the 60 objects in the system. And we need to have an appropriate incentivization system so that we have a healthy ecosystem. So this is the overall grand plan. And so rather than trying to attack it in one big diagram, let's go through it piece by piece. The retrieval client is a software library which integrates with applications. So you might have an app that might run on a phone, on desktop, on browser, or on all of those platforms, and you want to be able to integrate it, integrate a library so you can access your content on Filecoin. And rather than asking for every single CID in the whole system and discovering that, we've broken down the problem into finding a piece CID, and then based on that, then you find a CID. And so this breaking down of the problem allows for 2 to the 60 objects to be supported. Retrieval providers publish offers. So they are essentially saying, we will supply this content at a certain price, and here's an expiry date for this offer. And so you can think of the idea about these offers, as I said, is associating with all of the content inside of a piece CID, the cost of the content, the expiry date of the offer, and some quality of service metric around that content. And the reason for having CID offers is really latency. So if you go with the bid, ask, deal mechanism, you've got 2 overall round trips there. Whereas if you've got and you might have to talk to a variety of miners. Whereas if you can have these pre-signed offers, then you talk to a single node and it can give you a list of offers for that content. So you have much better latency. And so these retrieval gateways, they hold the offers that the retrieval providers have published. So the retrieval providers are connected with storage miners and they publish these offers. And then the gateways hold a set of offers and the clients talk to the gateway and then they get the offers. So which provider will provide the content at what price. And to have a market as well, just in case, say, one of these retrieval gateways turns out to be malicious, or maybe it just doesn't have all the offers, you might talk to a variety of gateways. And not all gateways might have all of the information because you've got essentially a publication subscription model of the retrieval providers publishing the data, and some of the retrieval gateways might choose to store it, but they might not choose to store other pieces. So because of that, we've created a DHT for discovering content. And so if a gateway doesn't have a PCID and offers for a PCID, it can use the gateway DHT to locate that information. And this gateway DHT is not your typical DHT. So your gateway nodes register on chain in a gateway registration smart contract. And when they're registered, they're staking some money, some Filecoin, so they can be slashed if they provably do bad behavior. And the number of gateways is likely to scale with the network, but you'd assume tens of thousands of gateways is probably going to be your upper limit. So you're going to be able to have a table of all the possible gateways in memory in one of those nodes. So because of the registration process and the staking money, it means that the nodes are going to be stable. They're going to be long-lived and the addresses are known. And what this means is that we should be able to do a single hop DHT. So that means you should be able to talk to any one gateway and it will know which other gateway or set of gateways will give you information about that PCID. And there's redundancy across nodes just in case nodes fail or nodes are malicious. And so the DHT is a ring DHT, but a gateway effectively owns an area within the ring. And so it has to cover all the CIDs that are in that ring. So you can see all those in the middle, you've got blue piece CIDs, and on the outside, you've got the gateway IDs, and they map to the same number space. And so in here, the example I'm showing is where the DHT span would be 4, but in a typical system, it would probably be more than that, maybe 16. or sorry, maybe, and we're finalizing that number. So in addition to what I've shown, there's also the possibility of having these retrieval providers not associated with a storage miner. What that gives you is in-network caching. So say I live in a city that is far away from where all the storage miners are who have the content. If some content is hot, and the retrieval gateways will be able to detect that the content is hot, then it could choose to work with its own retrieval caching provider to store that content locally and get retrieval fees based on returning that content. Also, content needs to be paid for. And so typically it could you could do it through a gateway if they have payment channels set up. But additionally, you could imagine nodes emerging called payment brokers that would have payment channels with all of the providers. As well, not everyone might have Filecoin. And so a subscription service where maybe you pay $100 a month or $20 a month, some amount per month to a subscription service, and then it retrieves as much content as you need on your behalf. So that's all I've got time for today, and please fire me any questions if you have any, and with that I will end. And that was just under 9 minutes, Mike, so hopefully that's good.
Excellent. Yes, thank you. That was perfect. Okay, so I'm actually the next presenter. I'm going to present on sorry, one sec, let me get this set up. I am going to present on the browser-based retrieval network that we built, the Filecoin project built over the summer. And so I'm just going to set my timer. I'm also going to do a demo of the software. It's very close to being usable at this point. It's taken us a while to get there. So basically, let me just explain what this whole thing is. The idea is that browser clients, we have a peer-to-peer network of browser extensions. So the software is a browser extension. You install it in your browser, and then your browser becomes part of this peer-to-peer network that anyone can join. And there are two things you can do. You can download CID from another browser client who is storing that particular piece of content, or you can make a request to the Filecoin storage network and retrieve from a storage miner. And the way that you talk to the storage network is through something called a cloud Lotus, which is a concept that we invented, but it's a public Lotus instance. It doesn't have any wallets on it or anything. You only use it to you sign a message and then you submit it to the cloud Lotus, and that message will go into the message pool and get mined and get incorporated onto the chain. So the cloud Lotus is really just a vehicle for you to publish messages to the chain. So the advantages of this model are there's no Lotus node required. You don't need to run your own Lotus. You also don't need to trust the cloud Lotus, by the way. Your signing keys stay in your browser. They're never shared with the public Lotus. It's just, you just send it pre-signed messages and it publishes them. So because there's no Lotus node required, you don't have to wait to sync to the chain, which can take like a week or something. And you can just do retrieval mine by leaving your browser running. So that was kind of the concept behind this. Okay, well here, I'm gonna go to the demo now. Live demos almost always fail for some reason. So here's a bit.ly link to a pre-recorded version of the demo I'm about to show you. You can check that out if I fail now, but let me try to give this a try. So one sec, I need to hide a bunch of controls. Okay, so this is what the browser extension looks like. Obviously, we haven't done any web design or any kind of put any thought into graphic design or anything. Most of the complexity of this is kind of behind the scenes. But the basic idea is you're on a peer-to-peer network. Right now, I'm running this browser extension in both Chrome and Firefox. So each node sees that there's one other node on the network, and that other node is just the other browser. And so you can do two things. You can either request data, you can query for a CID and request it from the other nodes on the peer-to-peer network, or you can be a provider of data. So you see that this Firefox is storing a CID already. It's about 4 kilobytes. What we're going to do is request it from Chrome, and then I'm going to explain a little bit about Filecoin payment channels and what's happening behind the scenes. So let's take this, copy it over to the clipboard, go to this Chrome one. This guy doesn't have any CIDs stored, so you don't see anything there, but we can still query for a CID. That's going to send a message out to all of the other nodes on the peer-to-peer network. And that message is requesting the CID. Now, in this case, there's only one other node, and it happens to have the CID since I copy and pasted it from Firefox. So this is the Firefox node responding. And what he's saying is, yes, I have the CID. Here's my price for it, 3.7 million autofill, which is an autofill is 10 to the negative 18th Filecoin. So this is actually a very small price. Just to show you quickly, you have configuration options. So you can set a price. Star is a wildcard. It means all CIDs are going to be priced at 1,000 autofill per byte. You can also do it on a per CID basis. And so anyway, this price makes sense, right? The file is about 3.7 thousand bytes roughly. So times 1,000, the price would be 3.7 million autofill. So now we're going to hit the buy button, and a transfer is going to start. And you can see this guy is downloading, and we see on the Firefox he's uploading. Now there's a lot happening behind the scenes, and you can see it in the logs. Actually, both have logs. And but rather than walk you through an execution trace of a program, which would be very boring in a demo like this, I've actually made a slide to explain what is happening right now. So here's the basic idea. The Chrome extension is buying a CID, and the Firefox is selling it. So the Chrome extension needs to create a payment channel, and then it needs to exchange signed vouchers with the Firefox in exchange for chunks of data. So the Firefox sends a chunk of data, and then the Chrome extension sends back a signed payment voucher. And then you can go around in this loop, 2, 3, 4 loop for as many cycles as it takes. I think the default chunk size right now is 1 megabyte, and it increases each time. It's a model of escalating trust. So anyway, you go around that loop for a while, and for a 4 kilobyte file, you're only going to go around that loop once, but then eventually all the data is transferred. At that point, the Chrome has sent all of the payment vouchers. He's out of the picture now, but the Firefox, who's the blue text, has a bunch of things that he needs to do in order to get paid. So first he calls a method on the payment channel actor called settle, and that means that the transfer is over, and it opens up a 12-hour window during which the Firefox extension can submit signed vouchers to the channel, and that's an on-chain operation, gets published on chain. And that during that 12-hour period, the Firefox browser would submit the highest value voucher it has received. Each time you go around that loop, the voucher values get higher and higher. So there's always one highest value voucher that the provider of data will have. And so he submits that, it's published on chain. Then 12 hours or more later, the Firefox can call collect on the payment channel actor, and that is what actually distributes the funds, tears down the payment channel. And so if the transfer is successful, 100% of the funds would go to the Firefox. If the transfer broke down halfway, then 50% of the funds would go to the Firefox, 50% would be refunded back to the Chrome, the requester of data. So that's how the model works. I'll just show you really quickly in these logs. You can actually see a lot of this stuff going on. Like here, this is Chrome. You can see this is the signed payment voucher that he sent. That's what a payment voucher looks like in base 64. It's actually a CBOR encoded as structure. And then you can see some of the operations that are going on in the Firefox as well. I think up here he checks the validity of the voucher. which is a signature check to make sure the voucher is really coming from the Chrome, and that it's that it's real, and also a verification that the amount is correct. And so I just want to wrap up by saying this is an open source project. Anyone can participate. We have probably about 10 contributors right now, and we are very close to having everything working. I think the one thing we don't fully have working yet is the retrieval from storage miners. But I think a lot of that stuff will come together this week, and I'm hoping to get more people excited. So this is the repo, and there are instructions for how to install you git clone the repo, and then how to build it, how to install it in your browser. And there's a little more information down here about what's complete and what's incomplete. So that's all I have right now. Thank you very much. Oops. Okay, let's turn it over now to Thomas, who's going to talk about Mild, his retrieval startup. Thank you.
Hey guys. All right. Yeah, thanks, Mike. That was a really awesome demo. My demo is actually quite similar in implementation. So here I am running, for the purpose of the demo, of course, two versions of what we have is a decentralized file finder. So I'll just go ahead. On my right, we have the provider. On the left, we have the client, which are exactly the same app. We're just running two different roles. So I'll go ahead and load some data here in my provider. So both are running IPFS nodes. And so when I'm loading this, I get automatically a content CID. And so for retrieval here, we are only supporting by content ID, but obviously we will be supporting different types of naming systems in the future. So as I make a query for this content, I can immediately see this local peer, which is found through local discovery right now. And so I can just kind of load and get a quick preview of the content directly through IPFS, then get the ask. And so the same kind of parameters as Mike outlined. And so we're ready to just kind of hit retrieve. So right away, we are loading the content and creating the initial payment channel. So while that's processing, I'll just kind of run you through what we've been up to. So I'm Toma. I'm the co-founder of Mile. And what you're seeing is our first prototype, which we call Beam. And so our vision is kind of twofold. First, we want to kind of increase the speed of retrieval on Filecoin. And then we want to enable anyone to just monetize their extra storage and create new sources of income. And obviously, we want to get those solutions to market as soon as possible. And so, we've been focusing on two challenges. Is as a provider, how do you find content to serve, which, as we've seen in the previous presentation, is definitely a challenge. And then as a provider, how do I serve the best deals, which means how do I most utilize the available storage I have to essentially maximize the income. And so our strategy is really for our network of providers to collaborate instead of competing. So how do they collaborate? They collaborate by sharing information, and they share information about deals, about content. So as soon as you've shared a content ID to one peer in the network, this information about content is kind of spread. And essentially, we have this idea of this concept of a deal faucet. So as soon as you join the network, you automatically get propagated through GossipSub a feed of content. And so any Mile peer can become kind of a faucet. So what that means is that they run additional caching of information through events, and then they run some type of local optimization that we built a prototype of it during HackFS actually over the summer. And so now we're kind of experimenting with different models to optimize this process. And so right now, this is very simple. It's kind of manual a little bit, but we try to make it really a very simple app that anybody can download and tweak their parameters. And then gradually we're gonna automate things. So essentially you just kind of run the app and it automatically optimizes the best deals for you. So behind the hood, it's really using, your normal IPFS nodes. It's using each of those two apps are running libp2p nodes, and so we kind of reuse the same kind of data transfer protocol as Lotus is using. For example, when you retrieve from Lotus, you have the same kind of graph sync data transfer where you can kind of track the number of bytes and get events. And so what really is interesting for us is to kind of record as much about those events and understand how the retrieval deal happens and what was the speed, what was the feature, and how can we optimize this? How can we see which client worked better, etc. It looks like we're sending a new voucher, so we're really close. There you go, transfer. We're getting the first bytes. There we go. Okay, so we're good. And here is the content. It automatically it's showing here now. And so essentially now, there's normally a notification that pops up, but it sounds like it showed on my screen and not the one I'm sharing. But now both any parties can settle this transaction, and there's actually a payment channel open. And so the interesting part is what kind of relationship those two parties can build in the future. And so we really anticipate that clients and providers can build longer term relationship. And what happens is by investing more in the relationship, you can essentially put more funds in a payment channel, for example, and reuse the same payment channel to avoid having to wait, for example, for this message. So we're really kind of exploring different relationships between peers and ways to kind of build trust in the long term to kind of, go faster and not have to go through all those different processes to verify that content is stored, etc. So we actually have another kind of prototype exploring different types of payments as well for ETH Online that we're about to showcase. So definitely tons of features, and we'll be releasing this for people to play very soon. So that's our presentation for today.
Okay, great. Thanks, Thomas. Let's move on to David from ChainSafe, or David and a few other people, I think. David and Elizabeth, at least. Yeah. Okay. Go ahead. Thanks.
Cool. Hopefully you can see that.
Yeah, it looks good.
Cool. Whoops, I'm not sure what happened there. Seemed I managed to hit the escape button. Sorry, just give me a second.
Hey, David, I just want to warn you, your background is sort of colliding with your face a little bit. It
Yeah.
looks like you're wearing war paint. Okay, just want to make sure you know.
Clearly, my GPU is not as good as it could be, but hopefully you can make out my face.
Okay.
So yeah, I'm David, and I'm joined today by my colleague Elizabeth, and we're here to show you guys some stuff that we've been doing, utilizing gossiping to enable some of the functionality of secondary retrieval markets. So as we've kind of talked about already, looking at the existing protocol, this is kind of the picture that we see. We have clients interacting directly with storage miners to both store and retrieve files. But when we start to look at the secondary market, the picture starts to look a bit more like this, where we're depending on these providers that sit just outside the immediate network. And then clients are interacting with them, and they are in turn interacting with the network as necessary. Some of the benefits of doing things like this is that we can reduce some of the reliance on storage miners and allow them to optimize their setups specifically for providing storage services. It also lowers the storage requirements for providers who are participating in this system. They can instead focus on expanding their resources on getting faster connections or better geographical locations and stuff like that. It also helps improve the availability of all the data on the Filecoin network. We have more nodes that are caching that data and are providing access points. One key benefit of doing things this way is that we're really avoiding some of the complexity in the core protocol. It provides all the kind of fundamentals that we need, and then we can really build a more powerful and dynamic system as an extension of that. And one of the really cool points here is that this data does not necessarily need to be stored on Filecoin. We can certainly construct a mechanism in which any data can be referred by CID, and assuming that it's profitable to provide, you can kind of expect its lifespan of availability. Looking at some of the key requirements for building this sort of secondary retrieval system, some of these things we already have. So context addressing is definitely a big one. It really allows us to guarantee that the data that we're retrieving is the data that we're asking for. It also allows us to address it in a global context so that any retrieval provider who's coming onto the network will immediately be able to identify any kind of any CID effectively. There's also the data exchange protocol, which is primarily for doing the actual data transfer, but it's especially critical here in that it needs to protect both parties in the transaction that occurs through the payment channels that we've just been looking at. Some of the things that are still kind of in progress here are the discovery mechanism. So really figuring out how to find the best provider for a user. And that definitely, the definition of best varies a lot depending on the context that we're in. And then one big requirement here is kind of considering the lost opportunity cost of storage, so that if somebody is expending resources to store something exclusively for retrieval, that they couldn't perhaps be making more of a profit by just storing that instead. Some of the goals of the implementation that we've built here are to provide a novel discovery mechanism, specifically using Gossip Sub, to just allow the clients to find providers of their data. We also wanted to start to inform providers of what data is being requested. This is really to allow them to develop mechanisms for caching and try to analyze the network and understand what is really profitable. And one key goal here is to allow these participants to be exclusively retrieval providers. So remove any dependency on the kind of storage miner components. Looking at the basic flow here, we have a client who's looking to retrieve some data and several providers. That client will simply submit a query, and the providers will gossip that to their peers. Any provider that is willing to offer the retrieval can do so by directly engaging with the client. And then the client can select which of those to follow through with and perform the data exchange with them. To just look at this from a slightly different perspective, the client is simply a component that is responsible for submitting requests. And then it's accepting responses directly from providers and acting upon those. The provider piece is specifically listening for those requests. It contains some data store of data that is it's making available, and it's responding with this response structure to allow the client to decide if they want to engage. Definitely one of the big challenges in all this stuff that we've been talking about today is really optimizing for profitability or potentially availability, depending on what incentivization model we're really looking at. One of the big challenges for providers is determining if it's worth spending the cost themselves to actually retrieve something from the Filecoin network and make that available for retrieval. They could certainly use alternative means for obtaining the data that they're providing. A lot of this stuff is very volatile and subject to change, certainly as the incentivization model of Filecoin grows and adjusts. We'll see some changes here, as well as the popularity of any given piece of data definitely plays an effect on how available it needs to be made. And then it's also important to consider that the locality of a provider could definitely have a big impact on this. Any one provider is going to have a very different perspective on the network. And so it's important to kind of take that into consideration when you're looking for optimizations here. Just some very simple things that we've done to just kind of make this a little more usable and explorative. It has a built-in LFU cache just to simply keep track of the n most frequent requests, so that somebody can kind of take a snapshot from here and see what is popular around that node. And then there's also a more extensible measure to allow some external service to actually hook into the request. And then it can apply its own logic as to determining profitability, and in turn decide perhaps whether or not to retrieve that from the Filecoin network. So our work can be found here on GitHub under chainsafe/Phil secondary retrieval markets. In its present state, it is effectively the query and response mechanism. Kind of our next aim here is to integrate some of the existing Go tooling for markets so that you can actually do the retrieval within the same process. And now that we've actually completed another interface for that, we can look at moving ahead with that. So yeah, I'm going to turn it over to Elizabeth to do a small demo, but certainly check out the repo. Feel free to reach out to us if you have any questions or are interested in this stuff.
Elizabeth, I just want to warn you, you only have about 50 seconds left. I can give you 2 extra minutes or something like that. Would that work?
Okay, yeah, an extra minute would be good because I'll try to go fast, but not sure if I can do it in 50 seconds. Cool. Okay. Okay, so hey everyone. So I'm going to do a quick demo of just using the secondary markets. So what I have here is the Lotus node running with, so this is a fork that we have that has the secondary markets inside of it. So, and I also have the storage miner running here. So I am just going to quickly get the, so I'm just going to use our secondary client to query the Lotus node for some data. So I'm going to first import some file into Lotus so that it can be retrieved. So I think I have just some random text file here. Okay, cool. So then I'm also going to print out the what's it called? The addresses for the node. So yeah, so I'm just gonna use the secondary client. So I'm just building it. Okay, and then build retrieval client. And I'm going to connect it to the Lotus node and then query for this CID that I just imported. And then we should be getting a response from the node. Okay, cool. So we have a response from the secondary provider inside the node. So yay, that's good. Okay, so then I'm also going to very quickly show just the provider on its own as well. So without Lotus. Okay, so I'm gonna launch, I think I'll just do 2 for now. I'm gonna launch one of the providers with some data, or I'll let it know that it has access to some data. It doesn't really need to necessarily know about the data yet at this point, since it's just letting the client know that it has it. So sample data.json. Okay, so I'm starting this with some data. And then
Hey, Elizabeth, could you wrap this up in about 1 minute? Is it possible?
yeah.
Okay.
Sorry, this is the last thing. So then I'm just gonna start this one with connecting to this provider. Oh dear. Okay. Okay, so, okay, cool. So that one has no data and it is also connected. So now I'm just going to connect this and then query for the data the first one has. And then we should only get one response from this guy. So yeah, cool. So we got it. The parameters that it would like for the retrieval. Yeah, so that is the demo for now. So cool. Thank you.
Okay, awesome. Thank you, Elizabeth. That was a great demo. So I want to encourage anybody who's in the audience, if you have questions, post them in the chat or the Q&A, whatever works for you, and we can address them. In the meantime, I have some questions for the various presenters. So while we're waiting to see if there are any audience questions, I'll just ask a few questions. The first one I had was for the consensus team. I think one of the things you've put a lot of thought into is different parts of your system where entrepreneurs could come in and it would be profitable for them to, they'd have some way to make profit. So can you just explain a little bit about what the incentives are in that system, Peter?
Sure. So you've got, for a retrieval gateway, you've got incentivization for you to do essentially the lookup between a PCID and CID offer. So who can give me that content? You've also got incentivization for participating in the DHT, though if you're going to run a gateway, you have to do that, but you get recompensed for that. So you get recompensed for seeing if you've got something, and if you don't have it, you'll still get something, and you get recompensed for giving the content. As well, there are providers. And so providers either get paid to return data, but if you've got one of those caching providers, it would be a way of you making money by running a gateway, seeing what's hot, and then hosting that locally, and then being paid for retrievals.
Okay, great, thank you. I also had actually another here. I have a question for Thomas from Mile. Can you tell us a little bit about, I know your project started at HackFS, so is everything open source, or is part of it open source, like open core, or what's your model like there?
Yeah, so we haven't invented any new protocols, so it's basically using all the available Lotus and Filecoin IPFS storage Legos. So it's been really about stripping everything down to exactly using what we needed. So there's actually open repos where most of the backend that's happening is all available, but the UI is closed source. So we have been developing our own native app in a private repo.
Okay, interesting. Yeah, I think that, do you also rely on a public Lotus node? Or are you running a client-only Lotus on your Mac, or how does that work?
Yeah, so I used to run on my Mac a Lotus node, and then I just ran out of space, and so it really made me realize that I needed that to be stored somewhere else. So yeah, it's kind of the same as your node. Very like, I mean, right now it's a full node, but eventually, I mean, it's just like a light client type model where, you know, we're just getting the chain head and replicating some of the state locally, but and wallets and everything is local, but you're connected to kind of a message pool and everything remotely.
That might be an interesting avenue for collaboration, I think, because I'm also interested in hosting a public cloud Lotus. I want to harden it a little bit, close off some of the APIs. Yeah, but yeah, so that could be interesting. We can talk about that offline.
Absolutely.
Yeah. I just wanted to ask ChainSafe. So, what can you talk a little bit more, David, maybe about the next steps? I know you want to decouple the storage miner from the retrieval markets code, so that you don't have to also be running a full storage miner, and just talk a little bit about the direction you'd like to go with this.
Yeah, certainly. I mean, as it exists right now, it's definitely it's kind of POC stages. There is some great work by Hannah and a number of other people on the Filecoin team in the GoFill Markets repo, which really provides the kind of fundamental building blocks to perform retrieval. And so we would definitely like to integrate that component with our provider to allow it to exist in isolation. And then we can really start to deploy it in a variety of circumstances and play around a bit more with the discovery mechanism. Also from the client perspective, being able to run the GoFill Markets piece, much like how you were just talking about, without actually depending on a private Lotus node. We have just built an interface to allow that to be a lot simpler, so you can run against any node. We definitely hope to, yeah, very soon have it up and running against some of the other Filecoin implementations.
Okay, great. Yeah. All right. Well, thank you. This was a really great session. I don't think there are any more questions. So I'm going to wrap it up now. I just want to make a plug for Giannis, who some of you may know, and I are planning an unconf session either tomorrow or Thursday. We haven't decided yet. It would be sort of middle of the day in the US, early morning in Australia, China, and what would that be? Sort of evening in the EU. So if any of you want to attend that, I think it'll be on the schedule when once we find a time slot. But yeah, I'll try to. It's just a session to kind of bounce around ideas about how retrieval market should work, and you're all welcome to come. Everyone is welcome. Okay, so with that, I think this was a great session. I'm really glad we have a very diverse set of sort of approaches to the retrieval market idea, and I'm really looking forward to seeing how these progress. Okay, thanks everyone.
Thank you.
Thank you, Mike.
Thank you.
Hey everyone, welcome back. Hope you all had a nice little break. Our next session is going to be presented by Deep, who's a member of the Filecoin team here at Protocol Labs. And he's going to be talking about our Bug and Bounty program, which is basically an incentives program for folks to report any issues with the Filecoin protocol or bugs in Lotus itself. So he's going to be telling us how that works. Over to you, Deep, if you're here. Perfect.
Hey everyone, thanks Ayush, really appreciate it. I hope everybody's enjoying the Liftoff week so far. I know we've had a day full of some really cool talks, and hopefully you'll enjoy the session where, as Ayush mentioned, we're going to dig into security a little bit, as well as the bug bounty program that was recently updated. If you have any questions, please post them in the Q&A section. I'll keep some time at the end to make sure that we can address them. So with that, let's get started. So I'd like to start out, actually, let me do this. So in this session, I want to cover a few things with you. So the first is we're going to talk a little bit about the Security Research Fellowship. So this was really the start of real community engagement with the open source project of Filecoin to ensure that when we reached mainnet, it was actually being done in a secure and safe way, and that Filecoin was ready for consumption by you, whether you're a miner or a user of the network. Second, we'll talk a little bit about the overall security program of Filecoin. We recently launched a new website as well, and I'll take you a little bit through that. And then last, we'll cover the specifics of the bug bounty program so that, after this session, if you're somebody who's a white hat researcher, a security researcher, have inherent interest in participating in the security community for Filecoin, you'll know exactly what to do. So starting out, let's talk about the Filecoin Security and Research Fellowship. So for those of you that don't know, this was announced over the summer earlier this year with the intent that we created a forum full of select group of security researchers or members of the Filecoin community that had demonstrated interest, willingness to engage on the security front, had the skills, and were willing to make the time for it, with the intent that they could help us prepare the network for mainnet readiness. So they participated in a myriad of different ways that included code inspections, stress testing the network, fuzzing, which we also saw, and you'll hear about a little bit more in our audit processes, but also in like deep dives and conversations into the theory and the implementation logic of the actual network. We had a very active Slack channel with them, and we learned a lot from the experience. So I want to also call out, a huge thank you to the Security Research Fellows. You've had a huge impact in the way in which the security culture for Filecoin is being shaped. Specifically, the attitude that each of you brought, the mind space that you created for the conversations, the behavior that you demonstrated towards your willingness to participate, as well as contribute towards Filecoin as an open source community and as an open source blockchain network was awesome. It was awe-inspiring, and it has continued to inspire us now. And you'll see a lot of how the bug bounty program is actually shaped by our learnings from the interactions with you. And we continue to hope to engage with you in the future as bug bounty reporters or in whatever capacity that you're comfortable to continue making improvements to the network. With that, over the past few months, they made contributions in a variety of different repositories in the overall project, including Lotus, including specs actors, and a bunch of other parts of the code base as well, all critical elements. And the contributions are not necessarily always in the form of issues, but also that deep engaging conversation, that willingness to understand the thinking that went behind the actual protocol, and then helping validate the implementation of the protocol was actually correct, made this program a giant success for us. And with that, you helped usher in the network into its mainnet. And so with that, we are also ushering in the overall enhanced sort of security program that includes a bug bounty program and a few other concepts. So building a strong security culture in the Filecoin project, it's been a core goal of the project from the very beginning. I don't know if you saw some of the prior presentations today, but a few other folks have mentioned this. Wayne, for example, from the community, who was also a research fellow. Ayush also called this out in his previous presentation. Security is a huge deal because security is what allows somebody to actually have trust in a system. And if you don't have trust in the system, then it's very difficult to choose to participate in it. It's hard to take a dependency on it. It's hard. We're trying to design the store for humanity's information. But if people aren't willing to put their data on there because they can't trust the network, then it's not going to succeed in its ability to do that. It's not going to be able to deliver on its promise. And so having a comprehensive security program is paramount to the success of the Filecoin technology, the protocol, its implementation, the network, in any way in which you choose to engage. So roughly speaking, the current state of the security program is it includes rigorous auditing, both for theory and for implementation. You heard a little bit about the Security Research Fellowship, which is sort of morphing now into a bug bounty program, ensuring that we create safe channels in which you can report issues, report vulnerabilities, have safe harbor policies and clear disclosure policies to ensure that you're given the confidence as a participant, as a researcher or a community member to figure out ways in which the network can be exploited or might have gaps so that we can continue to improve and ensure that we're headed toward a more secure and stable future for the network. And of course, as mentioned before, the bug bounty program, where we're trying to ensure that we create incentives for participants in the community to continue enhancing the stability and security of the network as opposed to just exploiting vulnerabilities when found. But of course, security for Filecoin as an open source project is also an open source initiative. And so I'll show you some links towards the end, but we'd love to continue to hear your feedback. You can share that with us right now, but also in the future to make Filecoin the most robust data store for humanity. So let's check out the new website. For those of you that didn't see the blog post that went on the Filecoin blog on Monday, I believe, so just yesterday, at least in my time zone. I know some of you are dialing in from different parts of the world, so it might not be the case for you. But we released this new website, which you can check out at security.filecoin.io. I have it open here as well. But this has got, this is meant to serve as the hub for like Filecoin security, like all things related to security. Again, we're going to continue iterating on this, so definitely would appreciate your feedback. But here you'll find information about auditing, about responsible disclosure, the bug bounty program, and then any updates that are coming out of the overall security program, whether that's recently reported and disclosed issues or new audit reports being released or anything else. So we definitely invite you to check this site out, participate in the way that you feel comfortable and feel fit to. And I'll refer to this website a few times through this session as well, so you know that you should go look at it to get additional details as are interesting to you, depending on how you want to participate. I had a couple of screenshots in case I wasn't able to get the screen share working, but that worked. So I'm going to skip past this and instead talk a little bit about the specific parts that I referred to, starting out with the audit reports. So audits are super important because they give us the ability to bring in a different perspective or a different set of eyes to review both the specification and the design of the protocol, as well as the implementation of the protocol. And that's important in ensuring that, one, we design a system that actually delivers on its promise, and then two, we build the software that matches that design and actually ensures that the network in its state or in its point in time state is delivering on the intended value of Filecoin. So there's actually a section that was added to the Filecoin spec earlier this week within the appendix, which has all of the published audit reports with a little description on the scope of the report, as well as a link to the report in case you're interested in reading it. I also snagged these two small screenshots from the spec dashboard. So if you go to spec.filecoin.io, on the landing page, you'll actually be able to see whether or not audits were done on certain parts of the code base, as well as on certain parts of the protocol design. There's a section specifically on theory audits that'll show you sort of the last date at which we conducted an audit, whether that was something that we published on behalf of Protocol Labs or a different organization within the community, or an actual security firm that helped us do it, as is the case typically, especially with the implementation reports that you will see in the implementation status dashboard. Yeah, so definitely check out this section. Please read the reports. They have some really good information in them. And they're very helpful in terms of painting the context of what the state of a certain part of the system actually is. Like Filecoin itself is a pretty complex system. It's not a trivial distributed system to understand. And those of you that are very engaged with it know this and have participated with it substantively to get to the point that you are, where you've been able to contribute and work around it. And as such, these reports are very important for us in ensuring that these systems, as they were built by different people in the Filecoin community, are actually going to do what is required of them. And we have somebody else who's an expert in this space giving us like a thumbs up that, yeah, this is actually accurate. This works the way that we want it to. And so please continue to also expect more and more audits to continue to happen to different parts of Filecoin. And of course, as we get more FIPS, as different parts of the code base continue to evolve and change, so will there have to be reports and auditing done on those new versions or iterations to ensure that we're continuing to push Filecoin in a direction that it stays useful, but also trustable and secure. So wanted to highlight a few of the recent reports that we published via the spec. So there was one that was actually just launched today on the Lotus implementation for mainnet done by Sigma Prime. Recently, we also published one on the actors, specifically the spec actors repo, if you've seen that, with consensus diligence. There are a couple in the proof subsystem. So looking not just at the overall design and implementation of the proving subsystem, but also on the very specifics of how we did the zero knowledge snark proof circuits and things like that. And there's a couple more reports that'll probably be published in the next couple of days. So definitely keep an eye out for that. The best way to do that is by looking at the security side or checking the audit section inside the spec, as I mentioned before. With that, I also wanted to take a second to thank the security partners that we've been working with over the last years. You've been excellent partners to work with. We've learned a lot from you, but more importantly, you have done a very critical job in ensuring that the Filecoin network at its state today at mainnet is something that is safe, is secure, usable, and delivers the value that we wanted it to. And the whole community is very grateful to your contributions, and we certainly look forward to continuing to engage with you because we're going to need it, and it's important that we continue to engage experts such as yourself. So specifically calling out a few names, and you'll see these names as well because they're the ones that publish the reports that you'll be seeing in the audit section of the spec. But Consensus Diligence, Least Authority, the NCC Group, Sigma Prime, Trail of Bits, and also the large amount of independent security researchers that have made the time to work with us to deeply understand the Filecoin code base, the systems, the protocol, and then help us conduct reviews and audits on them. Switching gears a little bit to the next sort of section or piece that you should understand about the overall security program. Let's talk a little bit about the vulnerability reporting side of things. Typically, if you find an issue, the right place to go to is the GitHub issues in the repository that issue belongs to. However, in the case that you find something that's an actual security vulnerability that could be exploited and would harm either the user experience or the state of truth or the actual protocol in the network, then we'd like you to report in a way that we can follow up on it and ensure that it doesn't result in negative externalities on the overall network. So the two ways that you can do this, one, you can email us at security@filecoin.org. And please, feel comfortable to encrypt the information, especially if there's sensitive information. There's a GPG key that we've published. Of course, you can't click on the link here, but the link is on the website as well as in a couple of different places that should make it fairly discoverable. But yeah, please encrypt the information and send it to us. And that's one very easy way. And I guess quick shout out to that email address. Of course, we're monitoring it. So if there are other questions that you have or feedback that you have, that's also a good place to go. And the second way in which you could get through to us to report a security vulnerability is through Keybase. So for those of you that aren't familiar, within Keybase, we actually have a team called Filecoin_sec, or short for security, that you can request to join, where me or somebody else from the admin team will accept your request, and then you can create a one-on-one channel or a private channel between you and one of us to ensure that there's a safe and secure way in which you're able to communicate with us. This is also, having this communication channel is important, whether it's over email or Keybase, because if you're a researcher that is reporting a vulnerability to us, we also owe you the right of knowledge that has been taken seriously, confirm that we're actually doing something about it, and keep you abreast of the updates and the investigations, as well as the investments that are happening in the actual code base to ensure that the Filecoin network does eventually consume the fix and the vulnerability is no longer a problem. And in that vein, I'd also like to call out our disclosure policy. We've gone with something called a coordinated disclosure policy. by which specifically a researcher can share the details of a vulnerability after a fix has been applied and our security team is provided permission to disclose. So if you're a researcher and you found something that's actually a critical issue or security issue with the network, we ask you to wait to disclose until we have reached a point that we have high confidence that a fix can be rolled out. We're obviously going to do our best to do that as fast as possible, but we also expect to be in close communication with you. And so we'll work with you on a timeline by which you can also report your findings, and we can also disclose the vulnerability officially from the Filecoin project side. With that, the part that most of you are excited to hear about, because vulnerability reporting is great, but it's interesting when you can be incentivized and you can actually be rewarded for the contributions that you're making and ensuring that Filecoin stays as a safe and secure network into the future. And I do also want to call out that we updated the site and announced it on Monday, and we've already got a bunch of interest in the bounty program, which is really cool. But also, we're expecting to hear feedback from you. So if you've engaged with us, please share any feedback that you have about the bounty program, about the information available on the bounty program. We do want to make it as easy and as safe as possible for you to continue reporting vulnerabilities, because we want to make it so that the Filecoin network can continue to stay safe without increasing the friction that it takes to do that. So let's talk about what it means to be participating in the bug bounty program. So one, as we discussed before, there's safe ways for you to report your findings. But it should also be noted that if you're a researcher, you are protected by a safe harbor policy, which means within the right limits, we do want you to stress the system and push it in different ways. And you should feel comfortable doing that. You can read the specifics of this on the Bounty website, where we detail what the safe harbor policy actually entails. In terms of the rewards that you get, we're probably going to go with a point system. Well, not probably, we are going with a point system where, depending on the level of severity of the issue, we will assign a certain number of points. Those points currently map directly one-to-one to a US dollar. But the points are also interesting because we'd like to be tracking a leaderboard of sorts over time, so that this also becomes a community within the larger Filecoin community where security researchers can see their progress and see how their contributions are stacking up to the Filecoin network relative to others that are participating in the program. And currently, we want this bounty program to be open, so we haven't set an end date. This is likely going to stay the case because it's important to ensure that, in the limit, Filecoin continues to be a safe and secure network. And so whatever you're willing to do in terms of the time that you can make and the expertise that you can bring, we'd love to have it. The security side has a subsection specifically on the bounty program, which has these details, some additional rules, policies, and all the links that you've seen in my slides. You can obviously click on them there and learn more as needed. The scope of the program is set to the core protocol and its implementations, as well as many of their dependencies. So a couple of highlight repositories, Lotus, actors, the proofs, proving system, and tons of others. There's a massive list of repositories that we're calling in scope. And that's because we want as much coverage as we can get. So please check out the site for the full list. But it's also worth calling out that not everything is covered by the bounty program. So the Filecoin website, or any like tooling and infrastructure or dashboards that you may have seen, like FIL Stats has been making the rounds recently. So if you see any, especially if they're third party and put out by other community members, they're definitely out of scope. And the last bit that's worth calling out is if a vulnerability was publicly disclosed instead of via one of the secure channels, or if an issue that you're calling out was also reported either to us already or via like a security audit where it's eventually been published, then those obviously won't count for reward. So it's worth staying abreast of the updates of the progress that we're making on the overall security front. So definitely check the website for that, and keep an eye out in the right GitHub repositories, because the information will be available there. Last thing I wanted to cover was ensuring that you have some resources. So the security website link is here, spec link is here. So this is the one that actually has the audit report section that you should go check out in the appendix. I believe it's section 6.4, and that has descriptions on each of the reports, as well as links to the actual published reports, so you can read through them. There's the security.md that is available in the main Filecoin community repo. That has a lot of this information in a single markdown that you can consume, but will also probably be the first spot where updates are coming with regards to how the overall security program is changing or evolving. So definitely keep an eye out on that. The last two I wanted to call out are on test ground and test vectors. So test vectors is this awesome repository. I don't want to take up too much time talking about it. Instead, what I'll do is I'll refer you to a session that'll happen at 1 p.m. On Wednesday at UTC time. So I believe that's like in 11.5-ish hours by one of the PL team members named Raul. He has some awesome stuff to share with you about ways in which you can contribute to the test suite for Filecoin. So if you're somebody who's in the security space that's finding issues, vulnerabilities, and wants to help contribute to the long-term solution, ensuring that they actually do get fixed, then also contributing a test vector alongside your report is an awesome way to do this, and will also bump up the reward that you get for your time. And then Test Ground, there's also a session on this on Thursday at 5 p.m. UTC, I believe, called Testing Blockchain Projects and Decentralized Applications. With Test Ground, you should check that out to see how you can create a testing environment for yourself, so you can provably reproduce the bug that you may have seen once you decide that you found something that's worth reporting. So with that, thanks so much for your time. Happy bug hunting. Looking forward to engage in whatever way is comfortable for you. You can find me on Twitter, GitHub, email, or of course on the Filecoin Slack. If you have any questions about the overall security program, about audit reports, about participating in the bug bounty program, please hit me up anytime. And yeah, thanks so much for your time. I hope you enjoy the rest of Liftoff week. Lots of exciting sessions to come. And so I'm going to take a quick look. I think we have a few minutes in case there are any questions. I don't actually think there are. So that's awesome. Almost right on time. So appreciate it and hope you all have a wonderful rest of your week. Happy bug hunting.
Perfect. Thank you very much, Deep. If questions do come into the Q&A, feel free to answer them offline, so folks can definitely submit more questions. But with that, we'll move into our last session. Before getting into that, a quick note. We've had a few requests come in for us to host one of our very popular AMAs, Ask Me Anythings. So we're actually going to do one tonight. So basically at the end of the next session. So that's going to be at 8 p.m. PST, 11 p.m. EST, and other time zones. Sorry, I can't convert them. So if you do have any questions you'd like to ask the team, definitely do so. But with that, we'll go into our last core session of the night, which is called The Future of Filecoin Mining. This is, there's obviously, Liftoff is really chapter 1 in the story that we're telling here. So we're going to have Jeremy Johnson, or Why Are You Sleeping, the Filecoin tech lead, talking about the many things that the future might hold for Filecoin, which I hope folks are excited about. So I'll invite Y to present now. One thing worth saying, speaking as someone who works very closely with Y, he is not afraid of hard questions. So there's going to be lots of time for Q&A at the end, and I really, really encourage you to ask questions, even if they're hard, even if they're in his face, so to speak, because this is a great opportunity to get them answered. But with that, Y, if you're here, you can start presenting.
Hey, yeah, can you hear me?
Yeah, I can hear you well.
Sweet. All right, so this is going to be probably not too long of a presentation. I've been fairly busy with a lot of other things, so I haven't had a lot of time to prepare. But I want to present the future of Filecoin mining, kind of an exploration of some thoughts of what's in progress and what might come in the future. So first off, right now we think about two different main types of mining. There's really storage and retrieval. But I also want to talk about some other things near the end of this presentation that might factor into futures of mining. But first, storage. So the future of storage mining. In the near term, we have a number of different things in progress. We have proving performance improvements. We have some markets improvements, validations, window post improvements, and a bunch of other stuff. But these four main things I kind of want to go a little bit further into. So the coolest thing, the thing that's most exciting is some of the optimization work we've done on pre-commit 1. Recently, Magic used our new pre-commit 1 code to pull off a really, really fast pre-commit 1. And I figured it's worth sharing that he managed an under 2-hour pre-commit 1. I think the time he actually got was 1 hour and 50 minutes. And that's not even with like any sort of like extra, tweaking of the processor or any overclocking or anything. That's just a stock like AMD Ryzen, not a Threadripper, but I think he has a 3900 that he was running this on. So under 2 hours is like crazy fast, which unlocks a lot of things for a lot of people. This means, a miner that is using pretty stock hardware, just like, you know, a normal non-enterprise level hardware can do like pretty significant amounts of proving, which is very exciting. So some of the other mining perf work streams that we're working on is we have some optimizations to pre-commit 2. We're targeting around a 30% improvement there. And there's a bunch of different things that go into that. This is mainly like building Merkle trees. There's some new GPUs coming out that people may have heard about that we're likely going to see some very significant gains on, especially with the growth in the amount of memory those cards have. So, you know, we get more memory and more compute cores. Obviously, we're going to do things more faster and likely to see very significant gains in performance per dollar. On our snark proving speed, so this is commits and window posts and so on, we're targeting a 2 to 4x improvement with some of the work that Supranational is doing for us. This is really exciting. 2 to 4x on the snark improvement is going to mean your single GPU is going to go much farther for the number of proofs they can compute. We're also working on better scheduling, taking better advantage of existing resources. There's a lot of room to grow here. So, you know, expect the same setup to get much faster as the scheduler grows and evolves. We're also working on market improvements. So, you know, why should you as a miner care about market improvements? Well, improved market, things that make the market better mean you're likely to get more deals. So we're working on improving the interfaces. This is both internal interfaces and like external interfaces for different groups to build on top of the markets, to make better deals, to do all sorts of things that make it easier for clients to store data. We're working on improving transfer performance and in general, like making graph sync and our storage protocols better and faster. We're working on light clients, which means clients can not have to sync the chain in order to make deals, which like opens up the door for a lot more use cases than are existing right now. And generally, like focusing on improving the client UX, making it just a better experience overall for people to use and interact with Filecoin will make more people store more files. Better UX, more clients, more deals, you know, generally happier miners, because more deals means more people paying for storage, which is exactly what miners want here. We're also working on optimizing the validation of proofs. So if you guys haven't noticed, it's kind of tends towards being on the expensive side for submitting some of your proofs, especially under congestion. And a lot of this is because, well, verifying snark proofs is really expensive. Like, yes, it's cheaper than doing the work, but still it takes significant amount of time to actually do the work of verifying the snark. And we've been working really hard at optimizing this code. Across the board, we generally have around a 10x improvement to the time it takes to verify different snark proofs. So this is, you know, proof commit, this is for window post, and so on. And this is really exciting. We also are working on some specs actors optimizations that will also reduce the gas usage and you know, cost of submitting these proof commits and so on to the chain. So using, you know, all these things are working on making all the messages you have to send to the chain take less gas, cheaper messages, higher chain throughput, and generally makes, you know, mining much better when you don't have to worry about fees as much. And then the other big thing that we're focusing on is windowed post improvements. So right now, window post is secure, but and security was the primary target initially. But now that we have that goal, we need to figure out how to make it much cheaper, much more reliable, much more better for miners. There's a bunch of different directions here. Like one of the directions is that we can find ways of just having to do fewer windowed posts. We can find ways of making window posts cheaper. There's a bunch of different directions there where, you know, we can change the construction to maybe be like commit reveal. We can change the ZK snark proof. We can change how the inputs are processed. We can do some pre-computation. There's a bunch of different directions here that the research team is working on. And this is one of our main priorities, is getting window posts to be significantly cheaper and like dramatically more robust for everybody. So that's one of our, you know, more important things here. So those are all like near-term things. And in the mid to long term, there's a bunch of different work streams we have open to think about, like, you know, what can we do to make mining better? And the main top of mind thing is getting better POREP schemes. Now, some of you may remember that before launch, there was a lot of talk of switching to a new POREP scheme. And we didn't end up doing it because it wasn't going to be easy to get it done in time and proven secure and have all the optimizations done. If we would have switched before launch, it would have probably delayed things, significantly. So we decided not to do that and to ship SDR. SDR is secure. Many people have hardware dedicated to SDR, and that works well. But newer POREP schemes are going to allow us to do a lot of things. So I'm going to go into that. And there's other things like POREP ASICs, potentially offline sectors where you can you can seal a sector and not have to windowed post it very often. This will have different security properties, but and potentially like being able to update the data in a sector so that people can have more mutable data on Filecoin. And there's a bunch of different ideas that will make mining better overall. So diving in a bit to at least one of those things, new POREP schemes, there's a lot of thought and direction that goes into this. And the hardest part really tends to be finding something that can be made secure, which is why we ended up with SDR in the first place. But as as our understanding and knowledge and research in this space has grown, we have found, a bunch of different directions that should result in secure POREPs. And so with those opportunities, we need to figure out what is our actual design space? What are the considerations we're looking for here? And really the main thing is we want cheaper hardware requirements per terabyte sealed. And, basically the proofs need to be much cheaper per terabyte. We want fast unsealing. Ideally, the way that the POREPs are constructed make it easier for posts. And also, we should consider that miners have lots of existing hardware and that we want to take advantage of the existing hardware and not have to have people go and buy, a whole bunch of new different hardware. That would be pretty bad. And even if the POREP was significantly better, it might not be the right thing for the network at this point. And at the bottom line, we want to design a POREP that ends up with the result of most money that people invest in mining Filecoin gets spent on disks, not on compute power, not on CPUs, GPUs, and so on. You shouldn't have to have thousands of sealing rigs in order to have a mining operation at scale. You really just want to have thousands of disks because Filecoin's about storage. Filecoin's not about compute, and that's the direction we're heading. So yeah, and with that, go on to the future of retrieval mining. So retrieval mining right now, it works and you can retrieve data, but it's, there's not a market yet. There's not a lot of the fleshed out, pieces around that. So there's a bunch of different directions that we're looking into here. But some of the main ones here that I'm gonna, dive into a little bit is, some standalone retrieval miner software, where right now we have the same piece of software for storage mining and block production, consensus, participation, and everything is also wrapped up with your retrieval mining. And maybe it seems like it could be a lot better if we had a dedicated piece of software for retrieval mining. Additionally, we're working on some browser-based retrieval clients. We're looking into aggregators and market utilities. We're working on better discovery, figuring out how clients who want to retrieve data can find the data to be retrieved. And also another very relevant component to retrieval is part of the POREP schemes we talked about before is more efficient unsealing. Storage miners storing the data should be able to unseal that quickly and get the data back to clients. So the standalone retrieval, something hypothetically called Lotus Retrieval Miner, be a piece of software focused entirely on serving retrieval data. The idea here is that you have something that's as thin as possible that just serves data for Filecoin. You give this, would ideally give you fine-grained control over the content that you are, that you're serving, allows you to have different controls over who serves what, and maybe some ACLs or payment controls. Very easy to load content into so that you can just add a bunch of data that people might want to your retrieval miner, and more detailed APIs for controlling and scripting and really programming around this whole process and automating a lot and making this a really nice, easy platform to use. So this is, not something we've really started yet, but it's on the list of stuff that we're really excited about for retrieval mining. Another thing that we're working on is browser retrieval. So being able to retrieve data entirely in the browser, just within a web page, go through and retrieve data from a miner, which is kind of moves towards the dream of having this really nice incentivized CDN where you pay Filecoin to have very fast, instantaneous, web browsing experience. And yeah, so Jim Pick has a really cool demo where he's compiled all the retrieval protocols into WebAssembly and has it running in a browser. I'll post a link to that demo in Slack afterwards, but it's really, really exciting so that you can just in your browser go and request data and pay in Filecoin for data without even running a Lotus node. And all sorts of other interesting things to improve upon retrieval mining, like aggregators and market utilities, better discovery to make it easier for clients to find and fetch their content. Right now, if you know which miner has your data, you can go ask them and get the data and pay for it, right? But in general, we want to enable situations where clients of the market don't have to go and specifically know which miner has their data. They want to just be able to look for data, and as they need it, find it and pay for it and download it. And we need to look at building utilities that make that better. And so a lot of that work is being done by different groups. I think Textile has some work in this direction and so on. So there's a lot of exciting stuff there. And then, more efficient unsealing so that storage miners who are, currently storing data can more easily unseal the data on demand. Right now with SDR, if you are a storage miner storing data, you either have to store a second copy of the data to be able to serve it quickly, or you have to unseal the data from the sector, which is moderately expensive. It's a similar process to actually sealing the data in the first place. So doing that is not right now is not super cheap, and so future PORAP schemes may make this better for us. And so that's storage mining and retrieval mining. So what else is there? There's a bunch of different ideas out there. Early on, people who have been following the Filecoin project for the past few years may remember the discussion of repair mining. And this would be an actor in the network who accepts your data, you make deals with them, and they store your data redundantly. And if any of the redundant pieces of that data go down, those miners drop their sectors or something, that miner would be on the hook for re-replicating the data. And so this would be a miner, on the network whose job it is to make sure your data is properly replicated and stays online over time. And this could be an entirely separate job because maintaining a very large set of data redundantly across this network, requires significant amounts of attention. If miners go down, you're trying to get really cheap deals so that you're paying the lowest you can for the miners, but sometimes those miners are maybe less reliable. Well, the repair miner would be able to abstract over that and just fix things as they come up, and you pay a small premium to them to make sure that all works. And that's kind of providing some redundancy service to the network. Other things is, well, Filecoin uses payment channels a lot for retrieval and generally just payments in the network. We could have Lightning node type payment channels or payment channel networks that miners can earn. Miners, since they already have a bunch of payment channels open and around to them, could form a payment channel network and do routing and earned fees that way, which is pretty cool. Another idea is that we could have some form of hot storage where right now when you store data on Filecoin, it's kind of like a cold storage. You store the data and it gets sealed and it gets stored, and then that data is there and you can't really change it. We could work on different mining schemes where you send your data to somebody and they just keep that data around, and then they can prove it to you on demand, but they don't necessarily seal it immediately, which would allow you to change it. And so you could have a very fast, mutable storage from miners that allows you to have more scratch space and changing, and makes it much easier to update data than the current way SDR works. There's a bunch of more stuff in this direction. I didn't really have time to brainstorm as much as I wanted to because I was making these slides today. So definitely more to explore here. And yeah, that's the end of my slides. And I'm excited to open up Q&A and answer people's questions and field anything anybody's curious about. So thank you. Yush, you want to?
Yeah, thanks, Y. You've got a few questions have started filtering in. I can read some out for you. Let's see. Let's try to start at the beginning. Let's see. Folks, feel free to put questions in now, either in chat or in the Q&A section. Ricardo speculates about how it'd be cool to do a deep learning algorithm for miners to choose hot or cold storage, and wonders if that could be done in PowerGate. What do you think?
Yeah, that seems interesting for PowerGate to do. Definitely discriminate on like which, for a given client, should the data be sealed immediately or should it wait longer, and what's the best outcome for everybody. I think that could be something miners could provide, or it could be abstracted through PowerGate.
Mm-hmm. Cool. Yeah, I'll say, Ricardo, the PowerGate folks can also be found in the public Filecoin Slack, and are also very open to ideas and suggestions. So it might be something to share with them. Yongjun Lu asks, will the cost of mining be reduced in the future?
Yes, absolutely. One of the biggest considerations for storage mining improvements is how do we reduce the cost of storage mining. So this is generally falls down to how do we make the hardware required to seal data as cheap as possible. Because as I said, what you want is for the money you invest in Filecoin to mostly go to disks. You want to be able to, if instead of buying a ton of sealing hardware and all these like fancy AMD processors and a few disks, you want to buy like thousands of disks and maybe 2 sealing machines. So yeah, like a lot of the new PowerUp designs that we're investigating are specifically trying to make sealing cheaper and mining in general cheaper.
Gotcha. Yeah, I'm sure that's good for lots of people listening in to hear.
Yes.
A question from the same individual about whether we'll have a Windows version of the mining program.
Oh yeah, we'll get there. Right now, the bottleneck is the proofs code is difficult to compile on Windows.
Mm-hmm.
I think, well, that and nobody on our team is really that competent with Windows. We all either use Linux or Mac, and so having somebody who's who knows a lot about Windows development to maybe help us debug a few things would be beneficial. So if you are that person, if you know a lot about Windows, then stop by and let us know.
Fair enough. Yeah, I don't see any more questions. We can hang out for a couple more minutes and see if folks want to put a couple more questions in chat.
Yeah,
it's a good opportunity to pick Jeremy's brain.
Yeah, is there anything you're excited about for the future of Filecoin mining?
I'm excited for the rest of Liftoff week, honestly, and that's what everyone else should be excited about as well. That is a question worth asking, though. Like, what's your most out there idea for Filecoin? What was so out there that you did bother talking about it in your presentation itself?
Is there anything? I mean, there's all sorts of future crazy things that aren't that crazy, honestly. But one of the potential futures is more chain sharding, or splitting the Filecoin network into subnetworks, so that you can increase the scalability a lot. So Ethereum is talking about sharding a lot, and I think there's a lot of interesting work in the sharding direction that Filecoin, as a not necessarily proof of work chain, might have a fairly easy time doing, since Filecoin has registered power where your effective hash rate is registered on chain. It makes it a bit easier to do sharding type setups because you can't power hop between networks as easily, which tends to be a problem with some of those
The problem
things.
with this, yeah.
Yeah, so that's one of the things I didn't discuss, but is interesting to think about.
Yeah. Speaking of a closer to ground solution to the scalability question, I think there's been lots of discussions about snapshotting the Filecoin chain, because as you may have noticed, it grows pretty quickly. When do you think that will become absolute unavoidable? Essentially, what's your expected timeline for that?
Oh, I think we're gonna do what I mean. We already recommend people use snapshots as their primary way of syncing. But I think doing an official, like, this is the new quote unquote Genesis, we probably should be doing that in the next couple months.
Okay.
It's getting pretty near term immediate. The chain, I think, takes up 400 gigs on my machine right now, which that's a lot. So we need to figure out how to clean that up. And I mean, at the end of the day, it's big because the Filecoin chain state is big. Like, we have 600 petabytes right now. Each sector of that has to submit their proofs to the chain, and those proofs are part of the the chain, because in order to validate the chain, you need the messages containing those proofs. So your full chain archive includes what is it, millions of proofs by now. How many snark proofs do we have in Filecoin right now? It has to be in the millions.
Yes, almost definitely.
Yeah, and I think we send, like, the network processes over 1 million messages per day right now. So if each message is like several hundred bytes, that's hundreds of megs a day in just the messages, not counting the blocks and the state.
But I guess the question is, do you think that's a problem with the design of Filecoin itself, or do you think it's perfectly fine to, like, challenge the kind of blockchain puritanical idea and say, no, it's fine to snapshot regularly, like there's nothing valuable being lost by doing so?
I mean, blockchains are all about community consensus, right? And so if the community agrees that at height X, this was the tip set, there's no reason to not snapshot at that point. The only reason the Puritans the Puritans are like, no, you can't snapshot, is because they have this weird idea that if somehow a heavier chain came along, that everybody would switch to it. So, like, the Bitcoin people will say, if somebody forked Bitcoin from Genesis and somehow managed to mine a, like, longer chain Bitcoin, that everybody would somehow switch to that. And that's just ridiculous.
Because that's several years of real economic activity that you'd be undoing in doing so?
Yeah, many years of real economic activity that you're just like, nope, that didn't happen. I mean, even like shorter forks, like, we have our finality in Filecoin set to 900 blocks, which is what, 4.5 hours?
Yeah.
I mean, even doing a fork of 4.5 hours, you're potentially erasing 4.5 hours of economic activity, that's scary, right? Like, if you just said, like, oh yeah, all transactions that happened in the world for the past 4.5 hours, sorry, those didn't happen. They happened differently. Like, that's crazy.
Yeah.
These sorts of things, I don't know. We need much tighter bounds on finality in general. And once something's final, there's no reason not to checkpoint it.
Yep, I think I agree. Here's another question.
Oh, we have new questions there.
Yeah, and there's one that I think kind of comes up a lot, and so I think I'd like to address, which is, do you see Filecoin being potentially used as a data availability layer for other blockchains that are doing different things?
Oh, definitely. Yeah, I think like we want Filecoin to host the Filecoin chain. Like, sure, we'll checkpoint, but I think we should keep all the historical chain data, but just store it in Filecoin. Like, have the network itself contract miners to store itself.
Right. Yeah.
You can do this cheaply by just like having some random person store the chain data with miners. Yep. But I think there should be some interesting stuff in the future where the network automatically like places deals with miners to store data.
Yeah, it's almost like a new block reward mechanism, except it's storing itself. And obviously, Filecoin is an obvious platform to try something like that. One question that I don't fully understand is, will the miners involved now have no advantage in the future?
It's interesting. So it depends on like what scale of future you have, because the miners now have existing power, right? And so, you know, what do you call an advantage? Obviously, a miner right now who has 20% of the power of the network is going to have 20% of the power of the network, mine 20% of the blocks, and, you know, get 20% of the block rewards. Well, that is an advantage. But in terms of, do they have an unfair advantage in the future? I think generally no, because as things change and as things evolve, like you know, for example, existing miners have already purchased their hardware. If you're a new miner and, you know, you're joining, you get to purchase the most, you know, the most recent, most like new efficient hardware. Like for example, the new AMD processors that were announced, we're estimating that with that new like 5950X processor, we think we can probably hit under an hour and a half on pre-commit 1, which is, you know, significantly faster than the current best that we've seen. And so like, and also the price per, you know, whatever unit of these processors is the same, or, you know, roughly the same as the previous generation. So with each new generation of hardware that comes out, a miner joining has like a significant advantage in terms of investment costs on previous miners. So like, that's one small thing of how like new miners have an advantage.
Right.
But yeah, there's not really any like unfair baked in advantage to being an existing miner, other than the fact that, well, you're an existing miner, you have your stuff figured out, you have operational experience, you have like, you know, the know-how of how Filecoin works, which that's an advantage. But
yeah, kind of rephrasing a bit, it sounds like you're saying you have kind of like some softer real world advantages potentially, but like the system itself only awards you for having been an older miner, in that you were more active for that period when others weren't around. But there's no historical advantage that kind of carries over time. Indeed, it might almost be a disadvantage. Is what you're saying? Yeah, cool. Right, we've got a couple more minutes.
I see one from Ricardo here.
Go ahead.
Yeah, it's asking what channel on Slack I'm going to post Jim's browser project. I'll probably just post that in the lobby. Gotta grab a link from him. I was going to post a link in the in my slides, but it's an IPFS hash, and I'm not sure if that's super useful to put in the slideshow.
Gotcha. Yeah, that sounds good. Yeah, I'll remind everyone that in the spirit of asking questions, we're hosting a bit of an impromptu Ask Me Anything session starting in 2 minutes. So you can check out the Phil AMA channel in the public Filecoin Slack for details about that. It's another great opportunity to ask questions of the team more broadly. There'll be engineering folks there. There'll be folks from BD and operations. So be sure to check that out, especially if you have burning questions you'd like to ask us. But I think with that, we can probably call it for tonight. Thank you very much, Y, for hosting the session, and thank you everyone for attending. I hope it was informative. We've got 3 days of Liftoff week left and a ton more content. So be sure to stick around. Thank you for being a part of this journey, and I hope everyone's excited.
Yeah, thanks everybody.
Cool. Bye, folks. And Jennifer Wang has helpfully posted a link to the AMA info in the Zoom chat. So go check that out. Bye, everyone. Take care.